Okay, I think in the paucity of time we will start. So, good morning everyone. Welcome to this 143rd edition of the Zak World of Façades conference series. My name is Ahmed. I'm part of the organizing team here at Zak. I'll quickly introduce the Zak World of Façades conference series to you, and then we'll get straight into the proceedings. So we've been organizing this event since 2012. We started as a small networking event, and now this event's completed 142 editions in 39 countries around the globe. This is our second one in Dublin. We were here 2 years ago in March 22, and we had a fabulous event. So decided we'll repeat this event here. New speakers, new topics, all have a story to tell. And if you see, we've got events lined up right from New Zealand up until Canada, all well spread out. Every region, the way facades are designed, engineered, executed is different. Different regions have their own challenges. So for us, it's a nice learning curve when we can get people from different regions to come and speak on their experience in different regions and vice versa. So it's been a great experience for us. So this is our 2024 lineup. We've got almost 30 events in 23 countries, and it's very unique because right now certain regions are doing extremely well compared to certain other regions. So it's making us also adapt as event organizers in terms of the agenda, in terms of innovating certain things. I'll talk about that a little later. But these events are not possible without our event partners. So I'd like to thank, by starting our presenting partner, Shuko. We've been working with Shuko from a very long time. We've been a very a loyal supporter of this conference series. So Shuko, if those who don't know, are world leaders in aluminium door, window, curtain, wall systems. And then our associate partners, starting with Cosentino. So Cosentino have an innovative cladding product called Decton, which is originally used as a surface for kitchen tops, but now it's been engineered to be used on the facade. Then Equitone are into fiber cement cladding solutions. Curare, they are the mother company of the laminated glass, interlayers, Trocifol and Century Glass. NBK Terracotta, one of the world leaders in architectural terracotta solutions. Obex is a British manufacturer of a breather membrane, tapes, films, and a lot many more value-added products. Partel is again here, local Irish company. They're into membranes and a lot of other value-added products. A. Procter Group from the UK, from Scotland, into membranes, vapor barriers, and other value-added products. Saint-Gobain Glass needs no introduction, one of the leaders in coated glass solutions. And of course, our next few events, we're doing Chicago next, we're doing Los Angeles, we're doing our first two-day event in Dubai, which is something unique. Obviously, the Croke Park's a unique venue, but we are trying something on a little smaller scale there at the Coca-Cola Arena, but we're taking the whole arena itself. It's a 4,000-seater arena where we're trying to transform this event into an art show. It's something unique. It's our 10 years of hard work, which we've tried to experiment at this event. It's very bespoke, and it's something which has never been attempted before. So the Middle East, the UAE is a place where they like to go big, grand. So we're trying something very special over there. We're also doing our, which is return of our awards, but these are the first time we're doing them in the Middle East, which is the Zak Awards for Excellence in Facade Design and Engineering, where we reward excellence in facade design and engineering for projects based in the Middle East. Back to the region here with a Manchester event on the 9th of May. We've got our first event in Miami. Toronto, we return. Zurich, Paris, Lisbon. And yes, that's our events for 2024 till June. But the idea is to do these networking events where we can have people sharing their experience on the way they perceive facades in the respective regions. And these events have always been very valuable, I believe, from a lot of people. That's why we've been able to do this from the last 12 years. 142 editions is no joke. Every week we're almost in some country or the other executing these events. And today over here we've got some eminent speakers who are talking about their storytelling, predominantly on facades which are executed in Ireland and the nearby regions. So I hope you'll enjoy today's event. Just a few things before I call upon the event hosts hosts for today. We've recorded today's event, so those who have given us permission to share their presentation with you will be sharing a YouTube link a week from now, and you can watch all the presentations in case you've missed. All our 9-10 sponsors have their tabletop displays outside. Please do interact with them in the networking breaks. They've got some nice solutions which you could apply or specify in your projects. It would be of great help. That's it from me. I'd like to call upon today's event hosts and convener. So obviously, those who attended the event last time will know Stephen Tanno. He's the Director for Pre-Construction Technologies at Shuko International KG. And joining him, we've got a local lad. We've got John Downs from Lendlease. He's the global head of the facade supply chain. I can't seem to find John. Oh, yeah. Okay, right. He's here. I think Stephen will call him. So that's it from me. I hope you enjoy today's day. And over to you, Stephen.
Thank you.
You have a presentation?
In fact, there was so much sunshine and blue sky, I was wondering why people say Ireland is cold and rainy. We did a lot of walking, cycling, swimming in the sea, and didn't see one drop of rain for 2 weeks. So this got me thinking that maybe actually global warming has finally reached Ireland. And if you were looking for proof that global warming has reached Ireland, I have just such proof. There you go. Please excuse the hairy legs. This is what 2 weeks in Ireland does. This is not Greece, it's not Spain, it's not Italy, this is Ireland. And if you're wondering whether we really enjoyed Ireland, I think a picture tells 1,000 words, so I'll let our faces speak for themselves. So, moving on to slightly more serious things. This graphic is telling us what the Irish construction output looks like over the last 3 years. You see some signs of recovery in 2022 after the end of the pandemic, but this gets plunged very quickly into negative growth at the end of 2022, beginning of 23, and that's where we are since. It sort of mirrors also what is going on a global stage. This graphic shows you that the North American market has been in serious decline over the last 3 years, and Europe also mirrors the Irish experience of decline generally. The only region in the world that is really bucking the trend is Asia Pacific, which seems to have continued to grow over the last 3 years. As well as the tough economic conditions, we've all had to adjust and adapt to becoming more sustainable, doing more with less, to adapt to the carbon economy. I love this graphic, which I nicked from the Institute of Engineers Ireland. It shows how complex the sustainability issue is, that there is no quick fix to this. You will hear more with our first presentation on the topic, and you will also hear later from my colleague Stuart, who will mention a little bit about how we are approaching sustainability and our approach to carbon control. I also want to share with you a small story about circular economy. We talk about recycling and reusing materials, and this is a key cog in sustainability. Especially for aluminium, keeping a closed recycling loop on construction-grade aluminium is one vital component, because mixing aluminium from other industries means we cannot reuse it. We cannot provide construction-grade material if we mix it with other sources of aluminium. So to that end, we did our own little bit of recycling. Some of these samples are more than 25 years old, and we decided to dismantle them. And we basically removed the glass, removed the gaskets and so on, and we took the scrap aluminium to a recycling center, and in return for 91 kilos of aluminium, we got £43.68. This makes 1 ton of construction-grade aluminium worth approximately £500. this material recovery and monetizing of the circular economy is still embryonic. We will hopefully see this grow over the next few years, and this will be a key process for us to be able to reuse and supply low carbon and ultra low carbon material in the future. So before I move on to the events of the day, I'm really delighted that this morning session, at least, not the whole day, the morning session, I will be sharing the moderating and the hosting together with John Downs. John is well known to all of you, and we are really all delighted and relieved that he has made a fantastic recovery over the last year. And it's an absolute pleasure to invite you, John, to please come and join me on stage. John will help to moderate the morning session and to give us his insight into the facade business in general and the state of the economy that we're dealing with. So welcome, John. Nice to have you with us.
Thanks, Stephen. Thanks very much. So it's a real pleasure to be here. Obviously, you'll know from the accent I'm from Dublin. So particularly special to be here in a very special place, Croke Park, which anybody from Ireland will have a great affiliation with and affection for. So it's fantastic to be here. I haven't worked in Ireland for about 15 years, so again, I think it makes it even more special for me to be here. The company I work for, Lendlease, are a global organisation, so I don't do any work in Ireland per se, but some of the things I'm going to talk about maybe are a more global perspective and then bringing it back to maybe a more European perspective. But the slides that Stephen showed, I could very much, it nearly reflects exactly what I'm going to say, to be honest. So if I look at the global markets at the moment, like the property and construction markets are very stressed at the moment. We're seeing that in the US, in Europe. We work in Australia, that's where our head office is, so in Australia as well. But interestingly, we're seeing the same thing as Stephen just alluded to, is Asia is quite a buoyant market at the moment, where our build-to-rent market, our retirement living, our data centres, which, you know, it's kind of way 10 years behind where we are here at the moment. Data centres are booming in Asia at the moment. So we're looking there and we're seeing something different to the rest of the world. You know, if we come closer maybe to this market, to Europe, Ireland and the UK, we can see that the construction industry is stressed. There's no doubt about that. The margins are wafer thin, programs are even thinner, and you would look at it and say, it's quite a tough time at the moment. Insolvencies are rising, which is for anybody, I suppose, in a contracting business is something that we need to be very, very aware of. But there is light at the end of the tunnel, I think. We're looking at everything that was in abeyance, let's say in the UK in particular. Things that were in abeyance in the last couple of years are now starting to come through. The capital markets are reflecting that. We kind of would see some issues with that as well. It's great to be busy, but things are going to get busy very, very quickly. So I go back to that insolvencies kind of red flag, where as a main contractor and developer, we're looking at that quite seriously at the moment. In sustainability, I think it's a very positive message for the European region in particular, and I'm quite passionate about this kind of subject, and I chair the sustainability committee in the CWCT. They do all the work. I just take some of the plaudits, but it's so there's really good work going on there at the moment. But Europe is definitely by far streets ahead of anywhere else in the world. So if you go over to the US, you don't get the same maturity of language that we see here. Australia would be probably about 4 years behind where we are here at the moment. I say here, generally Europe in general. And And Asia, you know, sustainability, let's say from an embodied carbon perspective, is not even on the radar at the moment. So, you know, so I take a lot of heart from that. We've still a lot of work to do, but we're streets ahead, and that kind of leads me into maybe a little bit of call for arms to the audience and the CWCT. If you don't know who that is, it's the Centre for Window and Cladding Technology. We started a conversation. I say we because I chair the Sustainability Committee. We started a conversation 3-4 years ago about embodied carbon. And the reason for that was that we all know operational carbon is part of our DNA. It's what we would have studied in university, building physics and U value, G value and all that type of stuff. But embodied carbon, even though we're probably starting to become armchair experts at the moment, it's not part of our education system, which I think is really interesting. So from a CWCT perspective, that's where we started. It was an education process and producing papers, guidance for people to read and start to get familiar with that topic. Fast forward 4 years, I think we're in a really good place. Lots of work to do still. And I think Anthony's going to talk about that in a few minutes. I haven't seen the presentation, really looking forward to it. But we're at a point where we're streets ahead of the rest of the world, where we've got to keep pushing. So the call to arms for the CWCT is, you know, if you've got a complaint, voice your complaint to the CWCT, but then put your hand up and volunteer to do something. Because collectively, that's the only way we'll move forward. I love the slide, Stephen, from the Institute of Engineers, but and it shows how complex sustainability can be. But I think the bottom line is we don't know enough, and you don't know what you don't know. And I think putting your hand up, and you know, I see Arap, Ecclesy O'Callaghan, Shuko, you know, we're all involved in the CWCT, and there's various different working groups doing great work, but we need more and more help just to accelerate the process. So delighted to be here, and thanks, Stephen. Looking forward to the rest of the morning.
I have one quick question for you.
Okay.
Lendlease is working all over the world. Do you ever think Lendlease would come to Ireland one day? Do you see that?
I don't see it. Having said that, I went by the glass bottle factory site the other day, and it's those size of projects that they look for.
Yeah.
So they work kind of 10 to 15 years ahead. You know,
Right.
so they're buying up sites.
Yeah.
Maybe in a market that's distressed.
Yeah.
And then you know that's the kind of
Yeah.
prolonged program that they have. So, yeah, I don't think so. I don't think so.
There you go,
We'll
guys.
see.
No
We'll see.
Lendlease in Ireland just yet, but watch this space. Thank you, John.
Thank
I'm
you,
going to
Stephen.
just say a very quick thank you to all the presenters today, all the speakers and contributors, because they take the time to prepare and come and talk to us and lead us into discussion. So thank you to everybody who is involved in presenting or contributing to today. Our first presenter is Anthony McCauley. He's Associate Director at Arup. He's Facade Discipline Leader in Ireland, and he will talk to us a bit about tackling sustainability challenges, a bit like what you saw in the earlier chart from Engineers Australia. So over to you.
Thank you. Thank you very much. I'm basically going to build upon what John and Stephen have just been talking about. I'm not sure that's a coincidence, but I'm going to take you through a facade consultant's journey from existing buildings, the new approaches in the new buildings, direction of travel, and then the information at the end of that and how we try to manage that. So from an existing building perspective, you'd be very familiar with a kind of a chart like this. And really the decision time is kind of 20, 25 years on. We start having these conversations with our client, going, what are we going to do with the building next? And the kind of questions you start asking yourself at that point is, I suppose, what are the components? What are the cladding systems? Are they bespoke? Are they proprietary? And the reason you're asking those kind of questions is because you're obviously from a sustainability perspective, you're trying to hold on to as much as you can. Who were the facade contractors? What are the performances? Are there any known issues? Has an air pressure test been undertaken? Air pressure tests, for argument's sake, we done one on a building that was grade A, 2003. It wasn't mandatory to do air pressure tests back then. BET did it for us 3 weeks ago. It held no pressure. So you can imagine the starting point from that building now from a refurbishment perspective. The lease agreements, they always come up in the conversations in those older buildings. And the reason for that is because the clients are looking for their full repairing leases. And you're thinking then about due diligence teams and how they're going to perceive the kind of refurbishment you're going to do. So where do we go looking for the information? Generally, the historic buildings, it's hard copies. So you start running through the hard copy information, try and find out what you can gather. It's a struggle, if we're honest. It's a struggle to understand what information's there. It's a struggle to understand what installation was used. Sure, some of this information happened after Grenville when everyone tried to find out in their buildings whether there was PIR or combustible installations in them. But it's a challenge nonetheless. A few examples of ones we've done in the past. This is Museum Plaza, the old Bank of Ireland building. You can see there in the middle, the double glazed unit had misted. And that tends to be, as you're well familiar with, that tends to be a problem with buildings. Once they're kind of 20, 25 years on, you start to have misting units. The Bank of Ireland Baggot Street, if I recall correctly, it was about 5 per year they were having. And at that point, the facilities guys just gave up. It was costing too much to refurbish it. We took on that building. We went looking for information. We found all the hard copy information. And that allowed us to understand what the system was. In this case, it was a kind of hybrid unitized type system. So from that then, it was non-thermally broken. We came up with a thermally broken version. And this allowed us to develop a solution that brought that particular building up to today's standards. So we stripped the building, took all the panels away, took them back to, it was architectural aluminium that done this. Everything got stripped out, reglazed, repatinaed, and put back on the building. And that's how it looks today. So from a warranty perspective, even though it was no building, it was a full refurb, full warranties, and now the Irish Health Board is back in there on a full lease. This is a Schuco building. Again, we started off having conversations with this one, asking those same questions. And what came out of this was it was Alucraft was the facade contractor who originally did it. They were still in business. So we started negotiating with them. You can see there on each floor level, there's three glazed panels high. Only the middle one was a vision panel. So we looked at this. Fair enough, it was an old Schuco system, so we couldn't put back in maybe an overall thicker unit because we were caught on the size of the glazing pocket. It was 10 mil, if I remember correctly. But we still nonetheless allowed us to replace all the glazing, keep the framing, keep the weights as per the original. And then because it was all negotiated through Alucraft, we got, again, full warranties for a brand new system, effectively. And the OPW have taken over that, and that's how it looks today. This is one we're working on at the moment, North Wall Quay. It was a bimodular system, non-thermally broken. So again, the performances weren't particularly high, but it was of its day. Interesting enough, when we started looking at this particular building, we found that if we kept the frames and replaced all the non-thermally broken with a thermally broken cassette system, the amount of aluminium involved, it was just more effective just to take it all off and replace it with a unitized system. So what we've done here, as you can see on the south facade, we have a narrow twin skin unitized system, Schuco, and then we have a traditional Schuco system with the 3 elevations. So a takeaway from existing buildings is there will be limitations. There will be limitations to how far you can push the systems. You do need to understand what warranties you're really going to get, because what we do find is that when the due diligence teams come in and start asking questions, we need to understand what warranties we're going to have, and does that ultimately have an asset risk? And I suppose I would have a concern on that one, that I'd have a concern that I think incentives are required really if we want to try and retain a lot of these things, because I think we'll end up with these kind of compromise warranties, which could affect the asset if we're not careful. Now, from the new buildings perspective, one of the first things really I'm sure you're all familiar now. Wellness has been the big thing for the last number of years. Natural ventilation, daylight, comfort. And that puts huge challenges on our facades. Gone is the day when we put in the same facade in all 4 elevations. As you saw there on the North Wall Quay project, we had on the south facade, we have the narrow twin skin facade with a dynamic facade, and on the other 3 elevations we don't. So there's an awful lot more challenges for us now, correctly so, to make sure these buildings are more higher performance and are more reactive to what we're doing inside them. Over the last number of years, similar to what John was saying there, we're now finding that the sustainability consultants are coming on board now, and they're producing charts like this, and they're looking at the whole life carbon assessment of the building and of the asset. Interestingly enough, go back on those buildings, the Grade A office buildings we talked about from 2003, 2004, the current building stock is actually, I would argue, fantastic from a U-value air tightness performance. So they are very, very efficient, and I think there's a legacy there, a much better legacy we're leaving behind us than we did, say, 20 years ago. But the one factor in all this is that the one big thing is the construction. The construction, the carbon, and what's in those buildings is really where the focus is now. Because from an energy perspective, truth be known, most of our commercial offices now have a cooling problem. They no longer have a heating problem. So it's interesting then when you start looking at images like this, and you can see there, to make them more efficient, to put natural ventilation in, but look at all the framing. Look how much framing is in that photograph. So from an embodied carbon perspective, yes, we're trying to achieve a higher performance, but there's a price to pay on the amount of embodied carbon we put into these facades. So there's a kind of a seesaw effect when we have to kind of work through what is the best thing for the buildings. How are we doing that? John alluded to the CWCT. So these have come out in the last number of years, so we're working through our tools and our calculators and how best to do this. Have we reached a harmonized thing throughout the globally yet? No, we have not. But as John mentioned there earlier, yes, we're working ahead of what we have, and hopefully the rest of the world will soon catch up. Critical to that is understanding what we're putting into, what products form part of those carbon calculations. So EPDs are essential. Again, they weren't around in any significant way 2 years ago, but we are finding now the industry has responded. We are getting the EPDs. It's coming and it's improving, which is a positive. What impact does these whole life carbon assessments have on our design solutions and our optimization and our discussions with the architect? We start off with these kind of carbon budgets. The sustainability consultant will give us a budget, and you'll try and stick within that. But it is driving change in the supply chains. Where's the material coming from? Are we bringing stone in from China when we should be bringing it in from Italy? What's it doing to the aesthetics? We are finding that the days of adding jewelry, inverted commas, to the outside of our facades is limited. Unless a component has a reason to be on a building from a carbon perspective, why are you putting it there? So I think everything has to have a purpose. And as I finish off there by saying build clever. We have to build clever going forward. Interesting enough, you see single glaze. This is a very simple chart to say single glaze, double glaze, triple glaze. Going back 10 years ago, we were looking for the highest performance. We were making buildings as efficient as we can. But as you can see there, the more you make them more efficient, the more material you're putting into the building, therefore the more embodied carbon you're adding to that building. So there's a sweet spot between what the payback period is on that, and that's an assessment we have to go through. Our London colleagues, for argument's sake, this is the horizontal skyscraper you'll be familiar with. You can see how the glazing is orientated in a certain direction. And I suppose that was simply they went through a sun path analysis, and then they end up putting in scripts and working out then how best to come up with the right facade solution for that. But again, it's a balance. It's a balancing act between the amount of carbon you're putting into the building and what the payback period is over the life of that building. So takeaways from a new building perspective is early engagement with sustainability consultants, understand what the harmonized approach is to the whole life cycle carbon, what the carbon assessment are driving design changes. Components have to earn their position on a building. If there's no purpose for them being there, they shouldn't be there. And I suppose it's getting access to those EPDs to allow you to make the correct assessments. So looking ahead, direction of travel. When I started my career, we were very much on the left-hand side there. It was a linear economy. I would like to believe we're in the recycling economy at the moment, and obviously we're looking ahead to the circular economy. Let's hold that thought on the circular economy, because Stephen mentioned it from the outset. From a carbon perspective and an aluminium perspective, we are seeing that improving significantly. There's been huge changes in the last number of years. You've got hydro using hydroelectric power, recycled aluminium in their materials to drive down that low carbon aluminium. Other suppliers have different approaches. The North Wall Quay project I mentioned from the outset, the Schuko one, is a mass balance approach. That's what we have on that building. We have the low carbon aluminium from them. But it's simply not enough. Stefan mentioned earlier on about the putting the aluminium back in, the structural grade aluminium back into even if we put it all back in, the amount of new buildings we're building at the moment, it's not enough. So it's incumbent on the rest of us, the designers, the architects out there, to use what we do very efficiently. So we have to look at our structural side of things, we have to look at our defection criteria, we have to look at architectural dependencies. If it doesn't earn a position on the building, it should not be there. So aluminium has moved ahead leaps and bounds. The glass industry is coming, but at a slightly slower pace. And I think you'll find that'll be the one we'll be focusing on over the next couple of years. Sure, you can crush glass down, recycle it, you can put it back into the cullet line. But where my nervousness there is we've spent the last 20 years making sure there was no nickel in the glass line because we were terrified of nickel sulfide inclusions. And now we're actively putting laminated glass back into the cullet. We're actively putting coated glasses back into the cullet. So we're adding impurities back into that process. So I think there's obviously an R&D exercise to be done there to make sure we're not adding in future risks and leaving stuff behind us. And similar to what Stephen mentioned earlier on, getting the glass back from the construction sites back into that mix needs to be thought through. But I do have one ask of the glass industry. And it's interesting, like when we started that, when I showed you that diagram at the very beginning about those conversations we have with our clients, when a building is kind of 20, 25 years old, it's coming off the end of its full repairing lease, and they're looking ahead to what to do next. We start talking about double glazed units or insulated glass or triple glazed units, warranty periods 12 years, design life under the codes 25. In reality, you're probably getting 35 out of a double glazed unit. But we don't know that. There's no science to that. There's nothing you can turn at that point in time when I'm having the conversation with the client, say, I can guarantee you that glass in that building is going to last another 20 years, another 15 years. Our glass team in London at the moment are working with a developer, and they're stripping some, I think, 15-year-old IGUs to try and understand what the desiccant is in them to see if they can try and predict that. But I would like to see more research there. Because just imagine the conversation we could be having with the client if the building was 20, 25 years old, and we could turn around and positively say that glass is good for another 20 years. Then it would mean then that building could very easily go back in for another full repairing lease for another 15 years. So the whole life carbon assessment formula completely changes. And you shift that whole needle in a whole different direction. So that is one big change I would really ask for the industry to be focused on the next number of years. Again, from a circular economy perspective, design for disassembly, you saw there Museum Plaza, 1970s building, we did it. There's absolutely no reason we can't be doing something similar on our buildings today. The amount of unitized facades that's coming through helps that, to be fair, because then it's a unitized facade, it can be taken away, stripped down, and put back on again. So I think that is the future. We will do that. The only thing is understanding what's on the building and knowing what it is and having that information available to us. Which brings me to data. We've heard about material passports. A material passport is very simply a document telling you what's on the building and understanding what the material is. But I suppose I would add to that, we also need to know its performance. Go back to the conversation we started on with the existing buildings. When we have an existing building, the first question the mechanical guy is going to ask is what's the U value, what's the G value, what's the daylight transmission. So the material passport has to have all the performance data with it. And if we have that there and we lock that away, then that's something that when someone comes to renovate these buildings, from a legacy perspective, we're leaving behind a really good, strong source of information. Interestingly enough, this is what we started with on Museum Plaza. This is what I started in that George's Quay building. There were file rooms with all the old safety file information in it. But we got it. It was all there. It just took a bit of time to sift through it and find the information. I showed you the Smith and Pearson drawing at the very beginning. The information was available. I would have a concern now that these online systems, in the last 10 years, if you go looking for the information, you cannot find it. And what you find is there's folders set up, there's product sheets in them, but the information simply isn't there. So there's a lesson there for us all. We have to get better at pulling all this information together and making it accessible. It's structured in a certain way so we can get at it. And if we do that, then we're leaving behind a really strong legacy that we can understand what these buildings are, and we can redevelop in the future. So to summarize, early engagement with the design team, a harmonized approach going forward on our carbon assessments, components earning their place on the building. If it doesn't have a purpose, shouldn't be there. Working harder to use less materials, and then understanding the impact of these 25-year leases and the full repairing leases. If we can get some more surety out of the lifespan of our double glazed units, I think it will transform that equation. And you can have a 25-year lease, you can have a 15-year lease straight after it. EPDs are improving, recycling of laminated glass is improving, and glass in itself, and aluminium. And really, from a data perspective, having a robust set of data at the end that we leave it behind us. So when people come back, and it won't be me coming back to refurbish all these buildings, but when they come back to refurbish these buildings in 20 years' time, all the information is available. Thank you for your time.
Thank you, Anthony. That was very succinctly put, and you made a lot of really good points there about materials. John, if you have some questions, please join us. We will ask you a couple of questions, if we may. Regarding material data, what initiatives are you seeing to digitalize that process? You showed us that on one of the projects, you were able to recover old drawings and understand how the system was put together. You showed us that picture of the room, the archive room full of old drawings and documents. What modern processes are you seeing people put in place to digitize that process of information retention?
What we're finding is the older building stock from 20 years ago is the hard copy files, and that is still the case. They haven't been digitized. What we're finding is in the interim period, say going back, say 10 years old buildings, if the safety file is set up, it is digitized, but there's little or no information in it. The folders are set up with nothing there. What we are finding, to be fair, in the more modern ones is all the information is there. There has been in the last, say, 5 years.
Yeah.
A much more stringent approach on putting information in there, but we just need to get better at that.
Yeah.
But what you do find, though, for argument's sake, is that, like from a facade consultant's perspective, I'll go looking for the as-built drawings, and I'll go look for the U values, but I'll also need the mechanical model at the time, the Part L assessments and things like that.
Yeah.
But the Part L assessment won't be necessarily in the safety file. So unless you know, and that's the whole picture. That's the whole envelope assessment done. The facade contractors components were there, but not necessarily the overall, the holistic approach. So all the information needs to be there going forward to allow us to fully understand what we're doing.
Yeah, I mean, in the modern digital age, you would think that sort of stuff should be easy to collate at the end of a project and put it all on a cloud data center that you can recover.
And that's what's happening. But what you do find, I suppose, is design teams are getting tired towards the end of the job. Their eyes are on the next job. The focus and attention isn't going to that. I just think we need to get better at it.
Fair enough. John, I don't know if you had some...
I'm just laughing there as you're talking about data. On one Triton Square, which Arab were on, when we got all the boxes in, we found a hard hat in one box, an old sandwich in another. It was amazing. And I think it was the first time that it really kind of struck us that we needed to get our act together. And we've got a plethora now of online platforms that we're trialing on different projects. So it's a big focus. And the golden thread obviously, ties into that. But I could ask questions all day, Anthony. Just a quick one. So in our business, we've seen a very, very big shift from, let's say, a ratio of new build to refurb Do you see that in your business, and would you have any stats on that?
Yeah, it's coming. There was a huge focus, say, 2 years ago on refurbs, but I suppose with the slowdown in the commercial market, the pressure's gone off that a little bit.
Yeah.
The need hasn't gone away. I mean, it keeps coming up. I would say we're shifting into kind of, I go back even 3 or 4 years, it was 100% new builds, the odd refurb, maybe 20%. We are seeing that move to, say, a 50-50 type of split at the moment. It's become much more to the fore, absolutely. Yeah. And it will continue to be. But I suppose the challenge there is not to go to the default and just strip the facade. You know, we need, like as you saw there in North Wall Quay, we did go through the exercise, we did look at it to see if we could retain this. I think you have to go through that process, because if you can retain it from a carbon perspective, then it's a huge win. You know?
Yeah. And those numbers are very similar to ours. So 5 years ago, 90%, 10%, whereas it's now 50-50, moving the other direction, actually 60-40 now. So there's a definite shift that we have to respond to, because we were challenging our own business now and saying, do we have the capability and the competency within the business to start to look at cut and carve rather than new build? And there's a distinct difference, which I think
but depending on how far you push the refurb, it's very easy to go full refurbs, put a new facade on, because then you got brand new facade, brand new warranties, brand new everything. If you're in that kind of compromised territory, what are the due diligence teams going to say when they come in and analyze the building for a potential tenant? They'll start throwing grenades. Do you know what I mean? So we need to be in a situation that we have a robust product at the end of that, depending on what level of refurbishment we do.
Yeah. So one more question.
More question.
So just in terms of warranty, I was listening very carefully to what you were saying. So can you see a scenario in the future where the client will start to accept a little bit more risk in the refurb cut and carve market?
No, because it's not the client. It's the tenant taking the full repair and lease. That's where the challenge is. So when they're on a full repair and lease, they're essentially responsible for the facade no matter what. So I just think we need, like for our mistake, that's why on the George's Quay project, we just negotiated everything with Alucraft. We went into them and said we kept all the frames, didn't add any extra weight. So therefore we improved the facade, improved the UV, improved the daylight. Maybe we couldn't push it as hard as we could. So did the client accept the risk in that case? Absolutely. So did they get a higher performance facade? No, they didn't. But they ended up from a warranty perspective with something that was acceptable to the market. So I suppose maybe I'll rephrase that. The clients will accept the risk on not getting full performance, shall we say, because the value added is a better product at the end. But we still have to have the warranties. So the question is will the facade contractors take on the refurbishment of a facade and include what's been left behind? That's the question.
Yeah. And then what we're seeing is the pushback from specialist contractors on that. So how much risk do they want to take?
Correct.
I think the vital thing you mentioned was allowing the facade contractor to negotiate, to come in and say, this is where I think there might be a risk and this is how I want to mitigate it.
Correct.
I think to have a traditional competitive, sort of nail the contractor to the wall approach type thing,
it doesn't work.
It doesn't work for this type of scenario.
No. Like I'm trying to square, you had Sheldon
partnering
and you
approach.
negotiated with Sheldon. We had Alucraft.
I mean, these companies, even Skeldabau, is able to take somebody else's facade, work on it, improve it, and provide a warranty for it to give it another 30 years of life. But they won't do it because there's so much effort involved to assess what's needed. You can't do it on a kind of hard and fast competitive basis. You've got to work on a little bit of trust, a little bit of partnering.
Correct. Yeah. So from that perspective, the clients are taking that risk. Yes.
Very good. One more question? Quick one, very controversial one. So early engagement with sustainability consultants in the appointment process, can you see more shift to sustainability scope for facade consultants to give, let's say, an end number to a sustainability consultant?
Oh yes, no. We're definitely moving into that space. Yeah. Oh no, it's in infancy. We've been doing this. Sustainability consultants are only coming on board in the last 12 months, 18 months. Really, there's not enough of them out there. If we're honest.
And that, from a CWCT perspective, that's the thing we're trying to encourage at the moment, is to bring more sustainability consultants into forums so we can start to discuss, but maybe educate as well, because sustainability consultants wouldn't know as much about facades as our facades are.
Yeah, I mean, a lot of them are not construction people.
No.
They don't know the process of how much effort goes into doing things. So,
But also, we can't have the sustainability consultant turn around and give me a budget to say that's your carbon. But as you saw there, I showed you photographs. If we go natural ventilation, for argument's sake, I'm putting an awful lot more carbon in for that particular product.
Yeah.
But then the saving is on the mechanical side.
Yes.
So there has to be a kind of a seesaw effect, you know.
Yeah. Brilliant.
thank you,
Very
Anthony.
good.
Fantastic.
No, pleasure.
And I'll let you, John, introduce our next
Lovely.
speaker.
Thanks, Anthony. Cheers.
Good luck.
So Stephen asked me to introduce the next presentation. So, Owen?
Change Paul O'Brien.
Paul O'Brien.
Yeah.
Same presentation.
Same presentation.
Beg your pardon. Yeah. Okay. The pictures didn't match. Yeah. So the next presentation is Paul O'Brien from Henry J. Lyons, Breathing New Life, which should be an interesting presentation on, I suppose, the facade fabric. Is that what we're going on? Yeah. So big for the visitors to Ireland. Boola bus means a clap. So big boola bus for Paul, please. Yeah.
Thank you very much. Sorry. Am I switched? Oh, I am. Thank you very much. Good morning, ladies and gentlemen. Yes, I'm Paul O'Brien. My name is Paul O'Brien. I'm standing in for my colleague, Owen Flanagan, who unfortunately was taken to hospital. So, I'm going to talk this morning about an old historical warehouse building that has been reimagined. The name of the building is the Tropical Fruit Warehouse. And I suppose in deference to what Anthony was saying, and this is a reimagining of a building that goes beyond just changing the external envelope. It results, I suppose, in the conservation of the old warehouse building and the new facades that occupy the site together with the old warehouse create sort of, I suppose, a great instance of talking about new and old together and how they can work in harmony. The building itself is located along the River Liffey. The address is 30 to 32 Sir John Rochester's Quay. The riverfront context, it presented a unique opportunity for us to create what we think is an enduring architectural set piece. And again, the resulting design actually comprises really of three different buildings. It's the restored and converted 1890s warehouse building, the two-story elevated glass box over, and an 8-story building to the rear. The total development is about 123,000 square feet, and it includes a new restaurant cafe, artist studios, and offices. Each of the building types are readily identified through their geometries, their shapes, their spatial qualities, and their materiality. As I said, there's a cafe just on the corner. There's a artist studio further down a new pedestrian street. The entire development overlooks the water and has been called a reflective design connecting innovation and history. The historical building that you see here in the photograph, you see the front elevation of it, occupied most of the site. it had been in use for quite some time as offices. The new building over, I suppose, is a volume of space that reflects the warehouse building, and I'll go into that later on in the presentation. The new extensions are uncomprising modern designs. There's a full glass box, as I said, over the warehouse building. It's cantilevered over the warehouse building. And the glass box creates a sense of transparent structure in contrast to the heavier masonry warehouse building beneath. So just on the slide that's on the screen there, you're looking at the front of the building that fronts out onto the River Liffey. The old warehouse building is, I can't point, can I? Or, the cursor. The old warehouse building is the brick building there at the very lower part. It's a two-story warehouse building. The glass box over is a two-story glass box. And then you see at the right-hand side, my right-hand side, the 7-8-story building at the rear. So this is, I suppose, an elevated view that gives a far better understanding of what's going on. You see the warehouse building here, the glass box here, and a new office building to the rear. They're all interconnected, but are all defined as distinct elements. Just on a project overview, the client here is iPut. It was completed in late 2022. It's got the restored 1890 warehouse building, which was a protected structure, the glass box extension above, and the new building at the rear. It's really classed as office workplace, but it has other uses within it. I'm going to go through quickly the building history and the warehouse itself, because I want to concentrate on the extension and how this led into the development of, I suppose, integrating an old building and repurposing an old building and new structures. But this is a view inside the old warehouse building. You see the Queen Anne old timber pine trusses. This has all been reinstated or reimagined. And the building itself started life in the 1890s as literally what it's called, a tropical fruit warehouse. And fruit came from different countries up along the Liffey. They were unloaded. There were rail tracks across the River Liffey, promenade from the docks into the warehouse building. And you can see them here packing, in this instance, bananas. And there was great stories, that we were heard while we were doing all of this work, of times where the bananas went overripe and they'd be dumped into the Liffey, and the locals would go and rescue the overripe bananas. So in 1991, there was a restoration project undertaken. The warehouse was transformed into offices and storage for the band U2. So you see over on the far side some of their office. There were private offices as well, but you see a lot of their, I suppose, awards, everything like that were on the walls. But it was really, really interesting that the main part of the warehouse building had these huge big cold rooms, and U2 stored all their stage gear from all their previous concerts in there. So I'd say it was worth quite a penny. And this is a plan here. You can see the cold rooms here. This is the ground floor plan. And you can see that it's heavily cellularized. We were trying to work out what was really original structure and what was interventions in this. And just following Anthony's point, we didn't find any drawings of this building. But there was a couple of things. It had very poor natural daylighting. The circulation systems were extremely poor. Most people entered in through the side, and there was a small staircase. You could probably see it there, 2/3 of the way up the image of the plan. And that led up to the main offices, which were on the first floor. This was when we, I suppose, took over the building, the image of the front of the facade of the warehouse building. And there were tall buildings surrounding this whole site. Taller, I'd say, not really tall, but first of all, we got to, I suppose, stripping out the building and looking what was there in terms of structure. We had the roof trusses themselves, the Scots pine queen post roof trusses, and then there was the original brick and stone external wall constructions. While we were stripping out the building, we discovered, I suppose, remnants of old windows and doorway systems. And these had been infilled with concrete, and we were just wondering what these were. Because it was a protected structure, we had close scrutiny by everything from not only our own conservation architects, but from Dublin City Council Conservation Department. What we did find was that those opes and part of the wall were actually part of what would have been the Hibernian, and you can see it just up here. Sorry, I don't have a pointer, but you can see it just here. The warehouse abutted the wall of the Marine School, and they had left those walls and built on them to create the warehouse building. Sorry. And this is just an image of that Marine School. It was built for the care and education of the children of mariners. And it had been used up until the 1970s and was demolished in 79. But they left, obviously, this element of the wall here and here because it was part of the warehouse building. And that's not unheard of in terms of older buildings, that external parts of one building become the external part of another adjoining building. Okay. And this is these apertures, I suppose, reformed, and we were able to reglaze them and repurpose them. The interesting thing also was, because the development next door had taken place, they're at a higher elevation, so you can see the lower parts of the windows are blanked out. The roof trusses, this was a huge undertaking for the entire project, because you can see they had suffered huge deterioration. You see on the top slide, over the top part of the slide there, they had been, I suppose, undergone some structural repairs previously, and you see that the ends of the timbers are converted into steel sections. But we took them all away. We had to take them off-site, crane them all out, and bring them to a factory to repurpose them. So we spliced in new sections, you see here, and then came up with an oil application. We tested lots of different products to get it there. And you can see pre and post. The original clay facing brickwork to the River Liffey was all restored. One of the key things were the top parts of the elevation had to be buttresses back. I also found really interesting, you know, as an architect, these heads, there's two heads here, and they were from the old Carlisle Bridge, which is now O'Connell Street Bridge. They were taken away in, I think, 1870s and became part of the Tropical Fruit Warehouse building in 1890. And then we redid all of the windows in the warehouse building. Again, we were using a slimline section, the Schuko Janso. All of the brickwork was repaired. The brickwork to the side elevations and everything, and it is, I just like dwelling on it, is that a lot of times we all talk about historical buildings that they're fine. All the side walls were just rubble and pieces of brickwork, and we had to really rebuild, for the most part, the side elevations. You see here where we're coming up with the actual brick that would have been salvaged, but also from other sites. I just want to talk mostly about the extensions, and because they are modern extensions, unequivocal modern extensions. I dwelt a little on the historical element because I think it's very important, you know, of when you're talking about elevations or fenestration systems, about the context that you're in. This system here we used, we had high regard for the protected structure. And we came up with a concept of how do you extend and, I suppose, build onto an old historic warehouse building. What we decided to do was keep virtually the warehouse building intact, not just the elevations, but also the roof system, the trusses, which you saw, which we all felt were an integral part of the actual historic warehouse building. How do we extend? So what we did in the end, we came up with a system, and you see it here. There's a concrete core in the center that virtually does all the heavy lifting. It takes the weight of the structure above. So that core, you see where the arrow goes up and down, is a concrete core in the center, penetrates the roof of the warehouse building, and the warehouse building itself is hung off and cantilevers out from that core. So you have, I suppose, you can see it, you can't see the roof structures, but there's roof structures in the very top of that new glass box that, I suppose, are doing all the work, and they cantilever out. What was also quite interesting, what we did with the glass, we wanted to produce a glass box here. And again, you know, this is sometimes in developments, sometimes in when you're treating with sites, you can't, you have to reimagine something that is quite different. You're not working with recycled or products that are available on site. So we went for an image here that was totally meant to be a glass box. You can see the glazing at the perimeter there on that section. It's a twin skin. The outer sheets are about 8.6 meters tall by 2.2 meters. So they're a very special glaze. It's a very special glaze system. It's designed to be lightweight in appearance and floating in appearance, and it sits above the existing roofline. But just to go into some of the detail on that twin wall system, you can see it here. You can actually walk through that twin wall system, because we had to come up with a system where we were able to clean the inside of the glass, both the inner face of the outer pane of glass and the actual outer pane of the glass to directly attach to the office plates. So what it is that we have a hanging sort of system. You can gain access at the very top and drop, ropes, so somebody can go along and rope themselves up and down to clean the inside of the glass. But you can see here, we took the actual, you can't see it really defined here, but here and straight up are actually glass fins that connect. I don't know if you can really see it on the far image, but they actually connect the outer panes of glass to the inner structure. So it's quite a unique part, I suppose. And the degree of difficulty, we worked with Arabs on this, the degree of difficulty in coming up with these solutions are quite outstanding. We did look at quite a number of different systems around the world that had something like this that would enable us to provide a system like this. And I suppose we were working with Alucraft, and then we also then brought in Optitube on this glazing system. And we had looked at, in particular, the Sofitel in Vienna, Jean Nouvel's Sofitel, which has a similar twin skin. It has the same sort of access systems. It's not as tall as where we were going here, at 8.6 meters tall. And we also, the degree of difficulty, we created a greater degree of difficulty because we wanted a glass roof to the box, because we wanted it more transparent. So you can see sort of we went into sort of discussions with Optitube. They showed us around some similar developments that they had done. They had were just, I think, completing the Tottenham experience, where they had large sheets of glass in that. And we went through a whole trialing and benching of the facade systems. And it was to try and get the aesthetic right. And that's why really I was talking for a while about the old protected warehouse building. We wanted this glass box to be in complete contrast, a very modern contrast to the old masonry building. Here's a view from the pedestrian way on the Calatrava Bridge. You see the end product here. You see the masonry warehouse building, the glass box over, and the office building to the rear. And then how did, we had all of these elements, how did we connect them all? Space was at a premium. We didn't want to connect vertically through the warehouse building with lifting. So all of the lifting and access really for the upper floors over the warehouse building are all in the new building. So what we have is a series of link connections into the glass box at the front, and we have connections from the new office building into, and you see it over here, the rear of the warehouse building. Here you're standing in the reception area. The reception is really behind the warehouse building. And on the plan, you see the connections. The warehouse building is here. The River Liffey is up at the top of the slide. The Calatrava Bridge is up there as well. So you can see we have that single concrete core in the center that is doing all the work. We have connections through at various levels from the new office building at the rear. And it's just, again, looking from the reception area into, through the rear of the old warehouse building. Another thing we discovered when we started pulling things down was there was no real rear to the old historic warehouse building. And what we discovered in most of these, and it was true for a lot of warehouse buildings along the quays, they kept on extending them. So the back elevation was normally made of a timber stud, and there was no brickwork or anything. So that's all modern brickwork made to look as if it was part of the original warehouse. I suppose what we were very careful and mindful of, that in all of the detailing, the junctions between the modern bits and the old warehouse building, that they were all set apart and stand away from. This is an image of where you enter the building. You can see the end of the warehouse building over here. This is a canopy that sort of leads you into the entrance area. And this aperture here is an actual way through the whole site. We also, it wasn't part of planning or anything. We just decided we'd make a connection between the Calatrava Bridge and what is called Whitaker Square at the rear. I think this is, is that the last slide? This is just, you know, some of the, how we got to the proportionality and everything on the new glass box. We took, you know, the lines of the historic building to create a volume there. We also, you know, worked as well. We had great crafting from Alucraft, who, if you forgive the pun, but they performed fantastic stuff on all of the underside of the glass box. All of these paneling systems are there. And I'll just say, I think I missed out a few slides, but it doesn't matter. Just to say, we have a lovely enameled pedestrian gates into that new side walkway. The area all here is to be a cafe, and there's an artist studio in here.
Thank you very much. Thank you. I have a lot of questions for you, but I'll probably do it over coffee in a little while.
I'm over by...
You're over time. But I just wanted to say, you put the kind of, there's emotional attachment to some buildings that we have, and we all work on refurbishment, but people actually have an emotional attachment, and that's clearly one of those buildings. And the way you've imagined it and modernized it is absolutely stunning. I can think of only one other example where something like this was happened, and that's the Antwerp Port Authority, where they just literally retained the old building and put a new one on top. Very similar experience. But thank you for that presentation, and thank you for stepping in today.
No problem. Thank you very much. Thank you again, everybody.
Before we have a coffee break, we have two technical presentations. The first one, James Brackenreed-Johnston. James, you're there? And the second one will be from Gareth. So we'll go first with James. He will talk to us about condensation and airtightness.
Thank you very much. Yes, my name is James Brackenreed-Johnston. I'm head of facades for the A. Proctor Group. We're a family-run business up in Scotland, about an hour north of Edinburgh in a little town called Blairgowrie. What we do is we specify and purvey high-end breather membranes, vapor-permeable membranes, and ground protection sheets, especially in regards to radon, which I know is quite prevalent down here in the Republic of Ireland. So today, what we're going to be discussing is condensation and air tightness solutions in the facade of the buildings. So we've obviously got a multitude of products that can be applied to these areas, but what we're going to do is go into the technical background behind what we do in order to decide what membranes should be applied in which area. So first of all, generically, we'll get involved at stage 3 with the architect. And initially, we'll look at the occupancy of the building. We'll decide whether it's going to be, obviously, a residential property, whether it's going to be a commercial property. If it is residential, what is the occupancy level that that building is going to have to achieve? Because it all takes into consideration the volume of moisture that's going to be put into that building envelope at the end of the day. So once we've decided on the internals, we then look at the outside. We look at the weather that's now going to be affecting that property through the lifetime of that build. As we've been discussing already today, the weather is changing dramatically and very quickly. So therefore, what we utilize is a hygrothermal assessment, which takes into consideration actual rainfall, actual temperature variance, and actual wind speed in the area that that building is being built in. If you've had your standard U-value calculations done before, your standard condensation risk analysis done before, you probably would have utilized something called a Glaser method, which is based out of the 1950s. The hygrothermal assessment is a much more in-depth investigation into the building envelope itself, okay? But it takes consideration the actual location of the property as well. So you can get actual figurative data for the previous 5 years in that area of those weather patterns. Based on that information, the software can predict how that area will perform over the next coming years. You can go 5 years, 10 years, 15 years, 20 years by predicting this software, can go 20 years into the future by predicting basically what's happened from the previous 5 years. So it gives you a lot more in-depth analysis on your build-up. And then finally, on the higher level, we look at the building itself, which from a designer's point of view, from a specifier's point of view, is the easiest one to control. But again, you've got to decide if you're going to use concrete, if you're going to use CLT, if you're going to use a hybrid system with steel frame and concrete or whatever it is. Obviously, with a concrete structure, you're going to have a lot of inherent moisture within that concrete from the start. But ultimately, when that dries out, you'll be able to receive the thermal mass of that concrete to help warm the building during the colder evenings and colder days. Whereas, conversely, if you used CLT, you wouldn't have that initial thermal mass. Sorry, you wouldn't have that initial water content within that product, but you won't get the thermal mass at the end of the day. So there's no easy way to sort of say, this is the way we're going to do it moving forward and that's it. It's just about working with the area that you're in, working with the products that you're using to make the building efficient and effective for the people living in it or working in it. So once we've understood the outer ring, then we move into what our core principles are, which is the heat, air, and moisture movement within that building envelope and within the building itself in general. Because you have to understand how much moisture is going to be in that building initially, how that moisture is going to leave the property. I'll just carry on. How that moisture is going to leave the property through the building envelope by utilizing an MVHR system, by utilizing a passive strategy, whatever strategy you go with, then we can accommodate that within the hygrothermal assessment to make sure that there is no interstitial or surface condensation created by those issues. Air tightness, I appreciate from a glazing perspective, air tightness is an easy way to utilize glazing is an easy way to achieve the air tightness line. But from a traditional rain screen system, having the breather membranes, secondary or primary on there, is a lot harder to achieve. But with the assistance of people like the Proctor Group, then we can get that working for you. So standard vapor drive from internal to external. Obviously, with a vapor permeable system, you allow that to go both ways. With the now inclusion of non-combustible insulants in the facade system, you're looking at utilizing a mineral wool, stone wool of some description from a non-combustible ratio, which means that you will still have that vapor permeability through the system. It's not a closed cell foil face product anymore. So having that vapor drive, allowing that vapor movement through the system is absolutely key. Having a breathable membrane doesn't mean that there's air traveling through it. It means there's vapor traveling through it. So air and vapor control layers. What was mentioned earlier was in regards to not having product in a build-up that may not really be required, okay, or aren't required. So again, utilizing hydrothermal assessments, what we can stipulate is that if you use a vapor permeable membrane that is airtight, on the outside of the building envelope, so on the sheathing board, yeah, what you do is take the onus from the VCL, from creating an air tightness line. So therefore, utilizing the hydrothermal assessment, we can actually potentially remove that internal VCL, but maintain the air tightness line on the outside of the building. What that does is reduce down possible penetrations through that VCL internally, not necessarily during the construction process, but after the construction process. And therefore, you can still maintain your air tightness line. It also means during construction of the process, if you have that air tightness line on the outside, once you have your windows in, you have your EPDM on, you can potentially carry out an interim air tightness test on the property in order to make sure that the installation is going well. Sorry, there's a little sales pitch there, I apologise. Vapor permeable membranes, so they can be airtight or they can be open, depending upon the performance of them, depending upon the specification required. Vapor permeability is key in accordance with BS 5250. Moisture neutral, so vapor works both ways. It's not moisture as in water, it's moisture as in vapor, works both ways. Can limit air leakage, obviously completely dependent upon the installation, but again, we can go into a little bit of that later on. And it's a simplified installation. As I mentioned, without having that VCL on the inside, if you've got this on the outside of the sheathing board, it's a fully self-adhered product, so it bonds fully back. It won't be affected by wind uplift or anything on that, especially from a high-rise perspective. The winds obviously do exceed quite high speeds. So all done in conforming to BS 5250, which is now classified as the Management of Moisture in Buildings Code of Practice. It's a much more detailed, every time they revamp it, it becomes a much more detailed document. There's a lot more moisture risk areas in here rather than just the condensation that it was before. They've got standardized details, so with a VCL, without a VCL, with just a breather membrane on the sheathing board. And as I mentioned, there's a primary and a secondary now. So if you're dealing with passive principals or passive house projects, which over in England now we're seeing more and more high-rise passive projects coming through, or principal-based passive house projects, where they want a breather membrane on the face of that insulation behind the cavity of the rain screen system. What this does, whether you believe it or not, is to negate thermal bypass and wind washing on the face of that insulation. So, you know, there's ways and means of basically securing the life of that building, making sure that the air tightness is there, making sure that there's no risk of any condensation within that build-up. The assessment methods of EN 13788 was slightly behind, along with BS 5250 in regards to acknowledging the hydrothermal assessment. The 15026 has acknowledged it for quite a while now. But from the changes that were made in 2021, the 5250 and the 13788 have now adopted the hydrothermal assessment and do advise that the client goes towards the hydrothermal assessment to get a full check done. So this is what you'll receive if you wish to have a VT of the assessment. What you'll see here at the top, if I can make this work, is the external temperature moving through the build-up to the internal temperature. And then down here, you've got the water content externally, moving through the build-up to the relative humidity internally. What you have down here, which is of great interest, is the moisture content within those elements. So the hydrothermal system works very, very well with a retrofit project in regards to a solid wall system. But in regards to what you've got here with a new build facade, even a retrofit facade, obviously these projects take a while to install. So you will, without a doubt, have rainy days, rainy weeks, when the insulation is exposed on that facade. If it's not capped over, that insulation will become damp, will become saturated. You then have an issue with potentially hydrostatic pressure forcing that water through the facade system. So what we can do with the hydrothermal system, the hydrothermal assessment, is increase the percentage of water in any one of those different areas within that buildup. And then we can cap it off, and then you can see how long that system will take to dry out. So you can do best case scenario, you can do worst case scenario. Again, harking back to the Glaser method, it assumes the whole thing is dry. It only takes into consideration average temperatures, average rainfall, and doesn't take into consideration wind speed at all. So you have no driven rain. So again, it's just a much more up-to-date way of assessing your building, because ADT, you want ABIS at the end of the day. And in order to facilitate that, you need to predict pretty much everything of how things are going to work. And again, further graphs in regards to moisture content moving through the years. This is all a large, it's not a one page with 12 charts on. You'll see the full document package with your assessment. So this was the first passive house leisure centre. We say the UK, but it's actually the world that's been carried out and is now finished down over in Exeter in England. So there was multiple different facades being utilised on this. There's multiple different assessments, obviously multiple different uses. We went for the design. I'm speeding up. So went through design, carried out the hydrothermal assessment with the architect, with the main contractor that was directly involved. Toolbox talks on site, so we don't just leave you from a specification point of view, we don't just leave you from a sales perspective, we'll follow the project all the way through to completion. We'll carry out toolbox talks on site, installation training, we'll do site reports throughout the project. We'll make sure that everything's sort of signed off in the correct way. But the biggest thing that I ever talk about on site is detail. The devil, especially when it involves air tightness, is in the detail. So when it comes to detailing windows, penetrations, plenum areas, anything on that sort of line, this is where we can assist. When it comes to the fact that the casting of the concrete isn't quite right, the SFS steps back a little bit or steps forward a little bit, then all these areas need to be looked at and addressed and designed properly. And it's about communication on site. I'm a firm believer that speaking to the people that are behind you, people that are in front of you, you have to make sure that the communication with your contractors is good. And if it's not, it needs to be remedied before they start installing. So it's just more images of obviously the projects I'm working on, using stick pins to hold on the insulation instead of standard traditional fixings. Utilizing, again, from this perspective, we had the Wrap-Tite on the sheathing board, then we had the 150 mil of rock wool. Other insulations are available, and then with our intumescent membrane on the face of that to negate the thermal bypass and wind washing. Again, that's a bit bright, apologies. All of this is done through training, on-site, site reports. We don't leave you alone, we keep going and making sure that the project will achieve, one, the air tightness line that you want, and two, obviously, speed on return in regards to the project completing. Other products are available. We're outside, so please come and have a chat with us if you need to, and we can go from there. Thank you very much.
Thank you very much, James. And as you said, they have a booth outside, so if you have any questions or if you have any projects you want to talk to them about, please see James and his colleagues outside. We are going to move swiftly on to our next presentation. Gareth is mic'd and ready. So Gareth will talk to us about lightweight stone alternatives, essentially. Is that correct?
Hello, everybody. Hi, I'm Gareth Black, and this is my colleague Damien. While I'm doing the presentation, Damien's going to do a demonstration on the actual product about how easy it is to remove sort of graffiti and markings on the actual facade panel. So we're here today to talk about Decton facades. We're going to start with sort of what exactly is ultra-compact manufacturing. Talk about the thicknesses available of the Decton, what the type of systems are, the colours, what exactly is Decton ID, the main USPs, and we have a case study and a video to highlight some of the projects that we're involved in. So, ultra-compact surfacing, what exactly is it? You know, it's a mineral blend that would be made of quartz, porcelain, and glass that would be heated, first of all, in a large format. It would be on a production line, and it's available in a variety of thickness and finish. I think the one thing that I would like to highlight is within Decton, there is actually no resins or binding agents used in the manufacture of this process. So what you can see here, first of all, is that in the bottom corner, you see the pH 25,000. What that is on the production line, the material comes through and then it is compacted by 25,000 tons of pressure, which basically pushes everything out of it and you're just left with the material. Once the actual press has taken place, it's of the 25,000 tons of pressure, it is then heated to 12,000 degrees Celsius. And the whole slab then, once it's actually, it'll liquefied, really as if it's the acceleration of stone over a sort of 4 or 5 hour period. And then once that temperature is removed, the actual panel will start to solidify. So Decton sizes, it's available in large format, 3.2 by 1.4. Why is that important in a facade panel? The reason that that's important is because it's a large format panel, when you actually detail your grid out, it says you get less wastage on that, which is important for costs. The material is available in 4, 8, 12, 20, and 30 mil thick, mostly for facade panels and the rain screen. The main panel thicknesses that we would use would be 8 and 12 mil thick. The other thing is that on the main body of the panel, the colour is all the way through. We'll be able to sort of demonstrate that. We have a stand outside and you can actually see the colour of the panel coming through. And it's a single piece, of a facade. So there's no layers or additional protection needed on this surface. When this panel is shipped from our factory, you do not need to bond it or seal it. It's finished product. So with the rain screen, there is a number of ways for this to be installed. The most common one would be a standard rivet fix, where you're just going through the front of a panel onto an aluminium carrier system. And the panel thickness that you would use for that would be maybe 8 mil. The next one would be a secret fix. We would have testing, ETAs, etc., from the likes of Coult and Fisher, and it would probably be the most widely specified one. The next one would be the DK2, where the actual panel will be routed underneath it, and an aluminium carrier system will go underneath it, and you can build the grid up like that. The next, the DKB and the DKC, which is in the bottom left-hand corner, because the panel is non-porous, it can be directly bonded against a structure. For example, if it was a block wall or concrete, the Decton can be used as a tile. The other one that shows there is that it can be directly adhered to render solutions. So you can have tiles 750, 800 mil square that can be used in high-rise applications. In the back of the panel, when you're using some of these, you just need to put in a clip that's actually routed into the back of the panel for additional safety measures. So just really about the available colours for Decton. Within the range, there's over 70 colours, ranging, from reds to ones with veins, so there is a good selection. And within the sort of Decton range, there is with Decton ID, if you actually have a project and you would like a colour to match something, or you would have a particular colour you'd like made, or if you'd like veining in it, whatever, we are able to actually manufacture that panel to your colour. This can be used to match a Pantene colour or a RAL colour. And the actual Decton would be available in matte, velvet, and extra gloss. So here's a project for Decton ID. On the left-hand side, you can see the slabs in the actual factory environment where the product actually has the veining through it. And this project was made to order. If you look at your top left, you can see all the different colors of the Decton ID. The red one in the middle, you can see it at the top. You can see the veining. So for this particular project, we were able to basically manufacture a pattern and a color for the architect's requirements. So the USPs for Decton, the first thing is that it's highly resistant to UV rays. So with that there, what we would be saying is if you were to install this panel like that against the wall, what we're saying is within 25 years, it's still going to look like that. The next thing is it's a non-combustible material. Decton is A2. So it can be used for high-rise applications as well as low-rise. As Damien's demonstrating here, I hope. Is it yeah, that's all right. I can relax now. It is easy cleaning. The reason it's easy cleaning, there's no there's no resin, there's no binding agents, so there's nothing for it to actually, take to. The abrasive and the scratch resistant, I'm not sure if Damien's confident to do this. So again, if this is installed at low level and you're worrying about vandalism, this would be a product that you would be using because of the scratch resistant of the product. As I said earlier, the variety of sizes and thickness. Again, you go from the 4 mil to the 30 mil, and you can have the large format tiles again that are 3.2, and the customization of the actual Decton ID. So those are the things that would be quite important, and the low water absorption. Again, the material is non-porous, so you can use it as a tile. It's frost resistant, and as Damien's shown, it is stain resistant. So with the actual product, there's a 25-year warranty in a facade solution. So if this is installed against your wall, there's a 25-year warranty. So that means that the material will still have the same color fastness that you install this in. It would be one of the, if not the only product on the market that will give a 25-year guarantee for that, or warranty. So obviously this is a buzzword that's been going around the industry. The product is carbon neutral. We have EPDs, we've got BBA certificates, there's LEED material available, BREEAM. You can see the photographs of the solar park there. Constantino has the largest privately owned solar park in Western Europe. So it is something that we take very seriously. A lot of the materials, there's large quantities of recycled material that is going back into these. So just a quick test report. It said the material was A2. This is a test that we did for a project in Singapore where the material was tested in a full-scale 8414 test that gives maybe a peace of mind that the material hasn't just been tested in isolation, it's actually been done on a full-size test. So this is really Decton-free other surface materials. The Decton, as you can see, stands up well against anything. You know, you can look down there, whether you're looking at porcelain, quartz, granite, all the way through to sort of fiber cement and marble. There's Decton is basically excellent in all those points, and some of those we're able to demonstrate. So the reason I was showing you this here is that this Decton, we have a factory in Spain where column casings and bull nosings can be manufactured through using undercut anchors to build up cleaning systems to really build up profiles for your building. So now I'm going to show you a few case studies for projects UK, Ireland, and around the world. So this is a project we have with videos, etc. off this project, and actually Decton was used throughout this building, walls, floors, sinks, everything. But what I would like to highlight on this one is this project is in Poole. It's close to the sea. We're not worried about any corrosion, salt, or otherwise that could affect this project. It still has a 25-year warranty, and it's on a standard ventilated undercut anchor system. It's a project that we did in London. You can see how the actual panel is being shaped or sort of manufactured with profiles to build it out, to give you overhangs, to make features within the walls. This is another project that we did. Again, Decton can be used as a spandrel panel solution. On this particular job, it's into an SG solution where the actual Decton is just bonded in place. Again, here's another standard Decton job in London. It's, standard brick effect. It's on a ventilated facade. This job, another one in London. This project, there was Decton ID made for it. There was 9,000 square meters, and it was made to match the architect's color. And with that, again, even though it's Decton ID, they still give you a 25-year warranty on the actual, on the finished panel. So here's sort of a few sort of starts. Yeah, this is just a quick video sort of trying to explain actually what Constantino is as a facade solution and really the size of the business.
A facade is a blank canvas on which to draw ideas that excite. Each facade is unique, and so is each design. We approach each project as a tailor-made suit. Colors, textures, fittings, thicknesses, and finishes specifically created to bring each design to life, just as it was envisioned. Costantino offers comprehensive, customized, and sustainable solutions for timeless facades. We marry performance and strength with endless installation possibilities and ease of maintenance. Decton transforms buildings into functional works of art. Composed of a mineral blend, it's sintered, heated, and pressed to create an ultra-compact inorganic material that unites performance and beauty, creating a technically superior surface. Decton doesn't expand or degrade with UV rays. It's resistant to extreme weather conditions. Available in large formats and with great dimensional stability, Decton panels can cover every corner of the facade with minimal joints. Decton boasts never-before-seen technical properties. It's non-combustible, impermeable, and with minimal maintenance needs. It's also available in thin thicknesses, offering maximum lightness and performance. Decton is cradle-to-grave carbon neutral, a commitment to our planet and our value chain. Decton's sustainable production process and high energy efficiency contributes up to 15 LEED and 14 BREEAM credits for facade projects. A world-class product coupled with world-class service. Costantino, leader in architectural surfaces, offers a robust global distribution network, delivering materials in record time to every corner of the earth. Additionally, Costantino City showrooms, located in the heart of key cities, have become a meeting place for connection and collaboration with the architecture and design community. Costantino's team of experts accompany clients every step of the way. from specification to on-site execution and post-sales services. Decton has become the material of choice for renowned architects, including Ron Arad, Francois Pienaar, and Ville Arret. The material clad some of the world's most jaw-dropping buildings, such as Toha, Leonardo Tower, Cap West, and countless more. This is only the beginning.
So the other previous case studies were all ventilated facades. Here's a job in Cork. The Atlantic is just in front of this building. And what you can see is the panel is directly bonded to the wall. So that it gives you like a tile effect and a tile solution. Here's a job we did in Derry. It's a ventilated facade. One of the reasons we won this job was because of the developer or the client had problems with graffiti on his previous buildings and he was tired of repainting it. And we got the next project from the same developer. And here's again, you can see that this is outside a bar. We got this solution because the owner of the bar was tired of people burning cigarettes into his facade. It's another job here. It's a ventilated facade in Spain. And this project, you can see the column casing that we actually made up with the Decton. That related to the earlier photograph. This job in, again, sort of ventilated rain screen. This here was a unitized project. And here is a showroom for Porsche. If you see the actual black on it, we're now winning projects up against maybe aluminium cassette panels because the panel is so flat. That's me. Thank you.
Thank you, Gareth, and thank you as well for the demonstration.
Yes.
It's obviously a lot of potential there, Gareth,
Yes,
with this as you say, as an alternative to cassette panels. So we wish you the best of luck with it, and thank you again. We're going to have a break for 15, 20 minutes, so please come back around 11:10.
So welcome anybody that's just arrived. Stephen kindly extended my scope of services to the second session, so you're going to have to listen to me for a little while. So the next speaker is Graham Coult from Ecclesy O'Callaghan. Had a little chat with Graham earlier on, and is he here? He's here, yeah. So the importance of adaptation, which is very apt and very current at the moment. So if you could give Graham a boule of bus again, if you don't mind.
You might notice the title's not the same. This is my third iteration. After I had quite a pompous thing about inevitable change, but I thought as an engineer, what I like about it is, we're playing around with things, we're constantly developing. And that really feeds into sort of our ethos and, well, certainly how I work, and I like to think how we work as a larger company. And this is actually a quote from Stephanie Quaylek, who was a chemist at DuPont, and she discovered Kevlar, amongst other things. But I'll zip through these so I can spend more time. But yeah, it's our 20th year, which is great. I'm the third one here, along with James and Brian. We've been growing strength from strength. We've got 11 offices now worldwide with a lot of a lot of projects scattered across the world. Various different types of project and structure engineering, facade engineering, and some really structural glass things. Quite a very varied sort of a workforce. We have physicists, mechanical engineers. As a facade industry continually evolving and far more complex than it was even 5 years ago, let alone 10 years ago, that the skills required to be a facade engineer, and I wouldn't put myself in that box, it is immeasurably different. But I think that's a really exciting part of what we can do and the services that we can provide. But it's sort of more framing the talk today. These are sort of our three of the things that we talk about, but they're no different to a lot of other companies. And oh God, it's a bit slow. But where we see. Anyway, where we see, where we work is where all those things could join, and we pull all these different strands together. We're not a big company. Well, we're a lot bigger than we were 20 years ago, but we're 100 in London, and that there's still a lot of fostering of relationships between teams and different skills, and that's really, really exciting to see. But what's nice is, we come to Dublin. Last time I was here was a long time ago. But we've got a couple of projects here with Henry J. Lyons. This is the Royal College of Surgeons just down the road, where we had 18 different facade types, as you can see on the little diagram on the left, but trying to rationalize that, bring it all together. Harcourt Square, sorry, it's flip sides. Harcourt Square, we've got, again, unitized system, stick system, stone, aluminium, glass, a lot of materials coming together, but maintaining a consistency of approach. Because of that complexity, we've been working a lot of how to bring some of that design into off-site manufacture, so working with the contractors and so forth to help that process. But I think we talked about the volatile oil, certainly Stephen discussed that at the opening speech. And, we've got the climate emergency, which is really pushing us as engineers to change the way we work. We've had Brexit, which involves some of us and not others, but COVID. And the last slide on the right was really the change in consumer price index from the Russian invasion. And just to get back, Stephen mentioned sort of the environmental disaster, not only the humanitarian disaster, but 30 million tons was a recent estimation of the carbon dioxide emitted just from the Russian invasion. So, that's a huge amount, but certainly not to belittle any of the humanitarian and other crises that war is causing. But it sets these things into context, and we can do so much, but we've always got more than we can do. So when we're looking at sustainability, there's many ways of framing that, but we look at it as the way we do most other things. It really is about good design, looking how we innovate and how we change what we do to manage the shifting performance requirements, and being collaborative. And I think the collaboration is something that the Emergency Climate Agreement asked us to do when we signed up. And we want to be rapidly changing what we do. We don't want to be repeating work. So that's so important. But I wanted to talk about a few of the tools that we've been developing internally, and sharing across the industry. So this is the Eco tool. So it's in its second revision now, plugs into Revit, does all the calculations, brings all the data together. This is open to anyone. So if it's something that you feel it will help you, just have a look on the website. There's a link, or send me an email, whatever. But this is something that we built upon a previous iteration. We've added our expertise onto top of it, and that's not to say that we shouldn't be developing it with others. And with facades, the complexity is growing immeasurably, and a greater requirement for traceability materials, not least for the change in the building safety regulator, but also the amount of materials and embodied carbon. These are all important things that we need to sort of capture that data. Changing the energy usage. So this is a little older project now, but again, it's a sun path diagram, looking at temperature of glazing, looking at the heat in different parts of the building. How is that going to affect our material choice or system choice for the facade? And the codes are struggling to catch up, and the world is changing at such a pace that we need to look at not what we need to achieve now, but what we might need to be achieving in the future. So looking at the robustness in the design is incredibly important. Not just to say we've satisfied the codes. What spare capacity is in this building. This is a neat little tool, our digital design team embedded in the, I'm not sure if this is going to play, hopefully it will. Oh, there we go. Excellent. So our facade team have built to really speed up the design process of that. So it's all parametric, grasshopper, all that sort of thing. It's way beyond me, but a lovely tool. Again, helping us go through those iterations of design. I'm not sure how long it goes on for, but you get the idea. But using all those tools, we have a number of case studies. This is looking at the life cycle carbon from, I can't remember. This is a project with Derwent. I can't read that, but and the products that are coming onto the market, I think we've had electrochromic glazing, thermochromic glazing, and other sorts of things. And dynamic glazing is yet to really get a real big toehold in the market, but we're working with a number of different product development groups about looking at different types of way to dynamically augment the facade or the performances, and there's some really interesting things coming along. 3D printing. This was a really interesting project that we're working on, and it's really that we know we can 3D print materials like concrete and so forth, but how do we then roll in all the other layers that go into an envelope? So the membranes, the finishes, etc. So this was really, looking at all those other bits and pieces that make the facade functional, and how can that be included in a simplistic on-site process. Inevitably, timber and materials, we're going to be using more of them. We have to use them wisely. We have to use them where they're best placed. But this is a black and white building in London, which was our first large-scale office building. But it's come out really well. Aluminium, as mentioned before, hydro, have gone to great lengths to recovering aluminium, keeping it in the life cycle. And one aspect that I have with these recycled materials, it's great. They're bringing a knowledge, and they're developing the industry. And that necessarily there's a price associated with that. There's a risk associated with that. And someone has taken, has a chutzpah to change what they're doing. But there also lies this, I wouldn't say responsibility, but maybe it is, we have as engineers, manufacturers, is that we need to make sure that these materials are available. We don't want to necessarily be pricing out those who are least able to afford it, using them to use dirtier materials. So I think that's a really interesting part that will develop, certainly with these types of products. But inevitably, there's going to be those early adopters, and we just want to see that continue. Again, recycled aluminium, I don't think anybody needs much introduction for that, but it's really about getting the message out there, and not with necessarily our small group that attends the conferences. These messages need to be spread further and wider into those that are perhaps installers working on residential and domestic buildings, and I'll come back to that later. Glass, this is a subject close to my heart. This is a paper I wrote with Rebecca, and this is a Sankey diagram. I'm sure you've seen them before. You may not know they're called Sankeys. But it's really about the material flow in the industry. And we started this project 2 or 3 years ago to see, what is the material supply chain? Again, I'll come on to that more, but this is about the energy usage added to each individual stage. Retrofitting, this was, one of our sort of, I guess, our landmark projects in what we've done with UNESCO, but a little bit more on that later. This is something that we've done with Saint-Gobain, is all of the glass from this building in Priest House in Athens was recovered and went back into the supply chain. So I would certainly echo Anthony's earlier comments of, if we can reuse the glass as it is, that's great, because we're using that embodied carbon and we're extending it over a period of life cycle. But we've got so much more to do. And so I think recovering glass and getting as much that in now is something that we can do. And looking at nickel sulfide, monitoring that's something we can look at in the future. And we will have to, and certainly the flat glass manufacturers will be. But we can't make that decision until we're actually recovering the material, which we're not. But it is improving. It is improving. And this is some pictures from site. This is a UNESCO project that I spoke about earlier. It's in Paris, largely done by our Paris office, which is an aluminium facade with glazed, sort of aluminium cassettes with glazed windows. We took it all apart, and what was nice about this, rather than having a steel-framed cassette, we designed a timber frame cassette to put back into the building. We were able to recover the glass, reprocess some of the aluminium. Some of it was too degraded, but again, it's really, the risk is, as Steve and Anthony were discussing afterwards, is the warranty and guarantees after that process. There's a lot more to that than specifying new materials and new products. The tools that I was describing earlier, we're looking at the different options of what materials we can recover, what the individual benefits of those are. So really, we can make the most of what the client's willing to spend on, hopefully, doing the right thing. But for this building, we came from 900 tons to 370 tons, which was really quite good. And in London, it's not any glass. This is the IBM building, which is on site at the moment, and I cycle past it every morning. And it's complete refurb, extended a little bit, so the client gets a little bit more for their money, as is usual. But these large concrete planks that form the facade are really iconic of the building, and so they want to be kept. Again, it's looking at the existing building, looking at some drawings which were okay, not always as built, but we had enough. What we did was we broke off the concrete nibs, as you can see here, and had designed a way to reattach those to the buildings with some analysis to check that it was. And we're happy with that to current code guidance. And I just want to finish with a bit more about what we've been doing with glass, because I think it could be glass, it could be another building material. And throughout this research, we're also talking with a council for aluminium building, and they've come up with a lot of the same problems that we had seen. So this is the supply chain for soda lime glass. So when we started this, certainly I was quite naive, thinking the architectural market was the only thing we needed to think about. But it's soda lime, and that soda lime material is used in insulation, it's used in the container glass industry. And so it's inevitably more complex. But coming out of that, it really seems that this was the initial idea of what's happening, is that we want to bring it back and want to make it as that supply chain as simple as possible. We want to stop landfilling it. We want to end end the single use of recycling, but we want to increase the purity, so it's making sure that it's sorted correctly, it's stored correctly on site, so we can keep the value going around in a clockwise fashion, hopefully get it back into the flat glass sector. But as I said a little bit earlier, I think the key to this is increasing awareness, increasing tonnage, increasing volume, and then look at increasing quality, because we've been able to do this for years and years and years, but it just hasn't taken place. But there's some really encouraging signs. So this, out of the paper, we looked at the benefit that that recycling this would confer. So we're certainly not, there's a transport cost to it, taking it back from site, but so there's a transport cost from excavating the raw materials, transporting them to site. I think it's well known about the reduction in energy, reduction in carbon dioxide emissions. So I won't dwell on that, but that's from the cullet perspective, that's where the saving is. And from stage 3 and 4 and onwards, we just need to be working smart about what we use and how we design it, and reducing and using less. But for me, the sort of standout thing that came out of all of this wasn't sort of the technical aspects and all that. It is that the discipline, domestic and commercial. So most of us are all in the commercial, love beautiful buildings, wealthy clients. But the sort of domestic glass tonnage is 70% over, 70%, while commercial is 30%. So while we can lead the industry in terms of what we're doing with our sort of small bubble of fancy buildings, is we need to really be working on distributing that to the domestic market, because it's 70% there. And so, there's a change in mindset about how we share, how we publish, how we share that information. And so the outcome of that is this website, which is online, but we're tinkering behind the scenes. And so this is a cross, we initiate this with one of our clients who sell computer gadgets and things, but we can't say who they are. But with some funding from them, we've built a website. We're building the back end of this to help domestic, small scale and commercial people find out who's recycling or where they can go to recycle the glass and what do they do with recycling the glass. So Arup have put in their knowledge into this, Thornton Tomasetti have put into this, and the website, as you know, won't have the XO Callahan thing in the background. It's sort of going to be glazing recovery. And it's something that we just want to share, we want to push out. I've been talking to trade glass magazines, conservatories, all these sorts of things, which I had no knowledge of until I started looking at this. And, I think for them, on a day-to-day basis, they're working on, different changes in regulations. They have a lot less time than, our consultants do, sitting in offices thinking about these things. They're the people at the forefront. They take the glass, put it in the building. And so if you can make it simple for them to return the glass, get it back into the supply chain, we'll be doing better than we did yesterday. And that's all we can hope for, really. But, and that's it. 40 seconds over. Thank you.
Graham, thanks very much for a fabulous presentation. Graham would be seen as a bit of a guru in the glass industry. I forgot to say that earlier on. And again, Ecclesy O'Callaghan, kind of very, very involved in the CWCT work, and I'm going to keep saying CWCT to so it gets through to everybody that we all need to come together, collaborate. Love to see the way Graham is saying that their carbon tool is open source and people can go in and have a look. That's fabulous, isn't it? It means any of you can go in and start to tinker around and do some work. A couple of questions for you, Graham. So in terms of the overall kind of race to net zero, what would you say is the greatest challenge that we face?
Changing habits. I think that, deconstruction on sites, getting things written into contract that means that it is possible. But I think, it's reaching all parts of the market. Because I said that, in this room, in our sort of, not ivory towers, but that we're doing all the expensive things with the clients that can perhaps afford to spend more money on their buildings to get a greater credentials and making sure they get a better, lower carbon building for their tenants, is that's such a small fraction of society. And so we need to look out of our sort of, not comfort zone, but our traditional sphere of influence and get that pushed down to those who are working with the tools, getting glass in, and say, well, if you don't have to, take the glass to landfill, if you take it to your producer and they collect it and then they ship it back, that saved you money, it saved you transport, and we're putting carbon back in. So that's been incredibly difficult.
Yeah. So it's a big cultural shift for the whole industry.
Absolutely.
Yeah. And you mentioned facade resilience. Is that as important in this part of the world as maybe some of the other regions that you work in?
Well, I think yes. I mean, it's different. I mean, we can see the rain that we've been having over the past few months. Certainly in the UK, it's been it's the wettest February and March. I don't know how many years, but we're constantly breaking these records. So how we deal with our facades, how we deal with our buildings, how we, it always changes. But our portfolio of projects are worldwide, so they change. But we have to use our energy more wisely, whether that's in the city of London or in LA or Australia, it's the same, but different criteria.
Yeah. And you mentioned timber. Obviously, you referenced a couple of projects there. Timber and fire, where do you see all that going, particularly, I suppose, for the London market?
Yes, absolutely. The codes are changing to accept that. In looking at the charring, one aspect we have been looking at is looking at different permutations, because obviously timber works well when it chars and it protects itself. But the different ways of modules, so we do, and the different stability criteria, it's very complex, and it's a different way of looking at these structures than we've looked at in the past. And so with these materials, bio-based materials, the testing and comfort from clients don't really want to take risks. We've been fortunate enough to work with clients that do take risks, but that's a small portion of the market. So I think it's going to require some brave design and from clients to start that and get that universal adoption of products that we know exist. Products can be used with lower carbon, but time and time again we said, well, there's a risk there we don't want to take.
Not a question, but maybe just a general observation. So you mentioned Rebecca there. So Rebecca is a young facade engineer that's come through University of Cambridge, and her work is pretty amazing. And I know you were helping her, but when I look out at the landscape here, I don't see many females, and I think that's something that we've got to challenge ourselves with. But females, maybe younger talent. I think Ahmed, that's something we need to work on. Is that kind of blend of bringing the young talent into forums like this, where we can grow them into what we need for the future. Because predominantly what I'm seeing is middle-aged males and a few females there, and we've got to challenge ourselves and change that. I think, particularly when we see people like Rebecca coming through, who is amazing. She really is, isn't she?
Yeah, I mean, she was doing a PhD at Cambridge when I asked her to come and help me. And she was helping while being a student and doing everything else. And it's an amazing focus. And, we're lucky that she's now working for us. And our split of our staff is pretty much 50-50 now. So, and that's great to see, because we were three, not middle-aged white dudes, but, sort of slightly younger. But now it's completely different. It's such a different atmosphere, and it's a much better place for it.
We brought Rebecca onto the CWCT Oversight Committee, Sustainability Oversight Committee, to just get a blend of, I suppose, younger people, older people, but to give a more diverse opinion as well. So I just think it's so important.
Absolutely.
Super. Can we give Graham a big hand, please? Yeah. Thanks, Graham. So the next presentation is from Shuko, from Stefan and Stuart, two guys I know very well, and they're going to come up and, am I right in saying that? Yeah? Yeah. Driving safe and sustainable facades, yeah. And I've said to them I'm going to ask loads of hard questions at the end, yeah. Yeah. Thanks. Big bull of us, please, yeah.
Good morning, everyone. I'm Stuart Hosier. I'm the National Specification Manager for Shuko UK and Ireland. And this is my colleague, Stefan Trifonov, Head of Facade Engineering for Shuko UK and Ireland. And today we're going to run through, with you, we're very pleased to run through two seemingly unrelated topics in carbon control and the latest innovations in fire safety from Shuko. As Graham mentioned there, we should never forget that sustainability is a wide-reaching topic, with the ultimate goal being the future well-being of humanity and our planet. Responsible consumption is an important piece of the jigsaw. However, at Shuko, we believe sustainability is much more than that. We also need a sustainable and resilient environment, and to us, responsible consumption goes hand in hand with safety and robustness. This is why we have brought to you today these two seemingly different topics in fire safety and facades and carbon control. However, we believe that they are related in their common purpose, which is ensuring well-being for now and in the future. So, Shuko carbon control. We've broke that down into 4 pillars, starting with design to decarb, build to decarb, operate to decarb, and then ultimately recycling to decarb, so everything goes back into the closed loop. Behind each one of those pillars is a toolbox that Shuko can offer. Starting from design to decarb with design, can we look to design out carbon from the very outset? Rather than looking at purely just the material, can we look to design out the aluminium content? Can we look to design out the embodied carbon? Moving on to build to decarb, where we're looking at the material grade itself, but also things like, are we able to offer the CO2 footprint at the push of a button? Moving to operate to decarb, where we're looking at the thermal performance of our systems, ever improving the thermal performance, the energy generation, can our systems actually produce their own power? And then finally moving on to recycle to decarb, where we can look at how we can trace the amount of recycled content in the material using things like our IOF. So ultimately we can then recycle that material, pushing it back into the building industry. I'm going to start with build to decarb. And there's 4 pillars again within build to decarb, as you can see there, that we've identified. First of all, it's the influence of the shape and the building, and Shuko can't have an influence on that. That's with the architect, the investor. But there are 3 other pillars that we see in terms of the influence of the facade design. So that's the width of the elements, that's the design of the facade, that's where we're looking to design out carbon. We then look at choosing the right solution, again, minimising the amount of material that we're using and the type of materials. And then finally, but no means least, the material itself, in the reduction of embodied carbon in the actual profiles that we're offering. And this is the reason we're looking at this. This is a typical Shuko system, our AWS 75 SI system. And what we've identified is that 2 of the 3 main contributors to the embodied carbon we're in control of. Shuko can control that. The aluminium has a 34% contribution to the embodied carbon of a typical window, and the thermal break. I'm pleased to say that from now, we're now able to offer 100% recycled thermal breaks, so that influence on the overall contribution will significantly reduce. But the biggest contributor there, as well as the glass, is the aluminium, so we need to be able to offer a solution for that. And I'm pleased to announce that we can. So, as of now, again, we now have 3 grades of aluminium. So we have the standard conventionally produced aluminium, but now we're also able to offer low carbon aluminium and ultra low carbon aluminium. And the important point to make there is with regards to the values, if I can get the pointers to work there. The information that we're able to provide you is based on the profile itself, so not necessarily the billet, but the actually extruded profile. With regards to ultra-low carbon, you can see there, that has a minimum post-consumer material, recycled material content of 75%. And as I mentioned there, with a GWP value of 2.3 for the actual extruded profile rather than the billet. And again, we use data going back 12 months. We can use 12-month historic data. So you can see there the arrows dropping. We fully expect these values to continue to fall throughout this year, going into the future as well. Fully accredited via EPD, as you can see there. So we have EPDs for all of our free aluminium grades. And I mentioned previously with the toolbox of parts that we've got for Shuko Carbon Control, we're able to demonstrate the GWP savings, the carbon savings at the push of a button. And that's available to all of our partners, our specifying partners, our subcontractor partners, through our design and estimation software, Coult. So you can see there an example where the person inputting a particular window design or unitised facade design can select the grade of aluminium that they want to use, from standard, low carbon to ultra low carbon. And at the push of a button, you're able to see the effect on the carbon that's having, those changes are having. So we're now able to offer carbon engineering as well as value engineering. Moving back one stage to design to decarb. And this is all about smart engineering. So again, I mentioned previously, Shuko are looking at it from a holistic approach. We're not just looking at one aspect of sustainability, we're looking at it from a holistic approach. As you can see here, this is a conventional unitised facade. And what we're able to do is look at system optimisation. How can we reduce the amount of aluminium content in our systems? Which sounds crazy for an aluminium sales company. But as you can see there, by using some smart engineering, we're able to reduce the materials quite significantly through innovative design. This is an example of some of the calculations that we're able to produce. And what we're looking at, instead of looking at purely just our part of the system, the aluminium, mullions and transoms, we're looking at a combination of the individual contributors. So for example, the glass, what contribution can the glass give to the stiffness of the frame? And using those concepts. This is the concept of minimal wool, which derived from Stefan's team in the UK with collaboration from Shuko International. But what we're finding is we're able to save around 25 to 40% material savings, but again, maintaining 100% performance. On the left-hand side, you can see a conventional section through a conventional unitised facade system. However, using the contribution of the glass, of the silicon bond, we're able to significantly reduce the overall depth of that system. So not only reducing the amount of material, but increasing the net lettable space in the building as well. Here's some examples of the savings that will create for you. So this is looking at a 100% glazed facade using this concept of the minimal wool. And as you can see there down the far end near Stefan, with a combination of using ultra-low carbon aluminium, using low carbon glass and other factors, we're able to save around 44% of embodied carbon on that facade. So significant savings using this technology. Of course, we appreciate that not all facades are 100% glazed. We've also looked at it from a 50% glazed facade perspective. And again, there you can see at the far left-hand side of the screen, the combination of ultra-low carbon with low carbon glass and the other factors, the other materials being used, we're still seeing savings of up to 42% over a conventional facade system or conventional facade design. So some significant savings in using this technology and way of thinking. But we're not only doing that with bespoke systems, we're also going through our range of standard products as well and looking at ways we can find savings with that as well. And what we're finding, on average, we can save around 4% in mass of all of our profiles, but again, maintaining 100% structural capacity. You can see in the background there some very intuitive software that we have at Shuko, which is running the die profile of one of our standard stick curtain walling systems through the software. And it's looking at areas within the profile where we can save material. as I mentioned, on average around 4% mass reduction on each profile that we're doing. Again, another example here from a conventional unitised system. And again, that 4% mass reduction on average is meaning for every 10,000 tonnes of aluminium that's extruded, we're able to save around 1,800 tonnes of carbon. So again, significant savings when you think about the amount of aluminium that we're using in the industry. And then finally, moving on to recycle to decarb. Now, we mentioned previously it's very important to ensure that the material that is being used on buildings today can therefore go back into the building industry at their end of life. MCCauley are able to offer a service where we will be looking at recovering aluminium, glass and gasketry from a building site, and you'll hear more information on that in the very near future. But a big part of recycling to decarb for us is based around our IOF system. Our IOF stands for Internet of Facades, and what this is allowing us to do is create a digital twin of every product that's going onto a facade. You can import a lot of data onto these small tags, small but very powerful tags, things like materials and EPD. So at the end of life, the client knows exactly how much material they have on their buildings. They've got the EPD, so they know exactly how much recycled content is within those products. But also thinking about the operational carbon and the operational life, you can start to contain things such as the service and maintenance regimes for that. So ensuring that the products that have already been installed, the longevity of them is maintained. We're not having to replace them over and over again. And if things were to go wrong with the system, a handle was to break, a hinge was to break, all of the data with regards to that system, so what handle's been used, what hinges have been used, the glass specification, for example, can all be contained within this very small tag with a big impact. So that's all from me. I'm now going to hand over to Stefan to go through our latest innovation in fire safety.
Thanks, Stu. Okay, so essentially, it's, as Stu just suggested, to us, sustainability is much more than recycling. It has a lot more to it. And when you look at the quote from the screen, I wasn't able to identify who said that first. It would be really helpful if some of you know and if you can tell me outside. But I think it rings very true when it comes to fire safety, and especially fire safety of conventional curtain walling, because I would like to make a clarification. We're not talking about fire-rated systems. We're talking about fire safety in conventional curtain wall. And what you're going to see now is the work of predominantly two of my colleagues, Raya Trifonova and Peter Enns. Peter will be outside and he would be able to help you with any questions that you have. But essentially what it's about is that in Europe, we have building regulations. And as you know, these building regulations are not harmonized in any way, but almost invariably, they have a variation of a sentence in them that says that the external wall must adequately prevent the spread of fire. And this is quite a vague statement, and essentially it puts the responsibility in you as designers. So you as a designer must make sure that your facade can adequately prevent fire spread in the building. And this is where it becomes problematic, because at by any reasonable interpretation of that, we would be leaning towards the so-called compartmentation, which is essentially assuring that we can separate compartments, and floors are normally compartments. So if you have fire on one floor, we have to make sure that this fire does not reach the floor above. And looking at this cross-section, which is fairly typical, it can be a unitized facade or it could be a stick facade, it doesn't matter. And we focus a little bit too much on combustibility. Combustibility is important, but it's not the only important thing. And the danger here is that if we look at this section, but we only think in 2D, we might be missing something, because there are several routes for vertical fire spread, and we know that the most unlikely route is through the structure, because essentially this is normally a concrete or a combi deck of some sort. And then the second route that people focus on a lot is the perimeter seal, which is the fire stopping. And there are products in the market that have a certain rating, and I'm afraid to say that too many times we think we take the rating of the perimeter seal and we kind of think that this is our compartmentation. So if you have a perimeter seal that has a rating of 120 minutes, integrity and insulation, we kind of think, okay, we have 120 minutes between the compartments. And whilst the regulations all across Europe are quite vague, I think when it comes to compartmentation, we must think about the facade. We must think about what our spandrel zone does in a fire scenario. And a lot of people do recognize the so-called leapfrog effect, that a fire can jump between floors, because we know that if a fire occurs on this floor, the glass will disappear, the aluminium is going to melt, because temperature of fire may reach 1,000 degrees, whereas aluminium melts at 600, right? So we know that in a fire scenario, this is gone, and then we start looking at the spandrel area. We understand the leapfrog effect, but what we fear at MCCauley is not understood well enough is that you have temperature transfer through the framing. And curtain walling, unlike windows are localized elements, right? They're within brickwork or some other form of construction. But curtain walling is different because curtain walling is continuous. And there is temperature transfer in that zone. So this is the elephant in the room, the way we see it. And it's part of the facade design that unfortunately gets neglected quite a lot of the times. And when you see a cross-section through this zone, and you don't sort of conveniently only think in 2D, you start thinking in 3D, and you can clearly see where the problem is. Because mullions, they have cavities. They're aluminium or another metal, which is a good conductor. It transfers heat. In the cavity, there's a chimney effect. So if we truly want to achieve that compartmentation, we definitely need to think about these problems, and we should not just rely on the fire stopping, or like we've seen a lot of details with fire stopping integrated into the spandrel, etc. We need to be more conscious about what is actually happening in that spandrel area, because if you look at the real fire, and this is a test, but it replicates quite well in terms of the temperature curve and how it develops. It reflects quite well a real scenario, and you can see that it looks like, you know, the flames of hell, and aluminium literally drips from that spandrel area. And yes, it might not be combustible, but it melts. So the standard that most regulations refer to when it comes to testing, if you actually want to have a tested solution, is this standard here. And we know that there are certain solutions in the market that are tested according to this standard, EN 1364, Part 4. And we are starting to see quite a lot of specifications that call for this kind of classification, or this kind of testing. The classification is another norm, but a lot of those are tested according to a configuration called configuration number 5. But configuration number 5 is a test of the perimeter seal. That's not a test of the facade. So when you specify your buildings and when you specify your facades, you have to make sure that you specify it to be tested to the appropriate configuration, which is 1 and 2. Because 1 and 2 is the configuration for actual spandrel areas in facades, and that is the real thing that guarantees your compartmentation. Because the test of a perimeter seal, how they test it is you have two fire-resisting components and you have the perimeter seal between them. So this is not a test of a facade, okay? But even with that being said, there is still a problem. There's a problem with that standard that a few people in the industry know about. And the problem is that we are focusing on this, this is a little bit strange. So we're focusing on that spandrel area, and we are replicating it in this sort of test. So we've got a furnace, we've got flames in the furnace with a defined temperature curve, and we are modeling our spandrel area. And essentially what we want to achieve for a certain period of time, which is our integrity and insulation duration, which could be 30 minutes, 60, 90, or whatever, the way we control it is that we measure the temperature at the surface called S3, and that temperature is the back of the system on the upper floor. However, the problem with this standard is that it's only thought about in 2D again. So S3 could be the back of the fireboard. It could be the back of your galvanized sheet that might have thermal separation. And is it truly a representation of what we actually build in our buildings? Because there are a lot of solutions like this. Schuko had this solution, okay, where we say, okay, we let the curtain wall run continuously, and to provide our compartmentation, we'll put a fireboard behind the curtain wall. And on that fireboard, and we've done the tests, and we know what happens, the criterion to achieve the classification is that your temperature difference from the start to the end of the test does not exceed 180 degrees, okay? So in a test, let's say you took this system and you tested it to 90 minutes, which is what you need to achieve for compartmentation. But when you test it, you measure the temperature at the back of your fireboard, it's 180 degrees, tick in the box, job is done. But then what we have failed to recognize, and we have the information from tests just above, literally just above the fireboard, the temperature of the mullion is 400 degrees. And if the cavity of the mullion is not filled, you have a chimney effect. So the actual temperature of the air inside the cavity of the mullion can exceed 800 degrees. So imagine that. We have a solution that has been tested. We've done our due diligence. We've specified our building according to the standards, 120 minutes, integrity and insulation. We think we're good. But then as soon as you have curtains or any sort of flammable material that may come into contact with those mullions and that framing, you're in danger. So complying with the codes does not necessarily mean that you have a truly safe building. So we need more. We need to work collaboratively, and in the interface between a fire engineer and a facade engineer and the system supplier, we all need to work together to define the performance of the building, because this is important. This is about lives, and 400 degrees is just not acceptable. But those are our findings, and then. Essentially, what you see is, if you test according to this, you're testing a fireboard, you're not testing a facade. What you need to do is you need a complex of measures that provide all the necessary thermal separation between the floors so that your temperature does not transfer from one floor to the next, okay? And you can see the comparison on these two videos. So if you don't have those measures in place, your fire will propagate, it will spread to the floor above. And what you need to do is you need to design your spandrel panel correctly so that this effect is prevented. And finally, you know, after the fire, you need to make sure that, yes, part of the building will be damaged, part of the facade will be damaged, but there will not be any uncontrollable fire spread. And our latest research and our latest tests have been done on unitized products. And this particular one that I'm showing you now is the result of discussions that we had actually with Alucraft Ireland back at the BAU stand in Munich at the latest edition. And what they said to us was, okay, you've done all that, which is great, but we need an SG product and we need a unitized product that is SG. So Ryan, Peter, they spoke with Alucraft. They collaborated on defining what needed to be done so that we can actually build something that people want to see on a building, but that something is already safe. And what we developed here was on the left-hand side, you see the standard configuration. And on the right-hand side, you can see how we went way beyond the code because we didn't just take the spandrel panel in insulation. We built that little bit on top, and that replicates the next unit, and that replicates the weak spot in the regulations and in the code. And we measured the temperatures in that to demonstrate that an SG facade, unitized, counterintuitively, can actually work for compartmentation. I'm nearing the end. So these are pictures from the test. You can see the standard configuration in the back and our non-standard configuration at the near end here. The lid goes on top. It's separated with that white stuff, which is a fire-resisting material. And here, an interesting thing that we did was we had a series of split mullions in that non-standard configuration, and deliberately in one of the mullions, we had cooling materials in the cavities of the mullion section, but we did not have anything in the chamber of the mullion. Whereas all the other places, we had a thing called a deflamed block, which is a Schuko product. And you can see in the thermal camera behind me, the regular mullion, the mullions that are protected and designed properly, they do the job. But the temperature in the unprotected mullion, it goes way up. And the temperature of the properly designed mullion was 70 degrees. The temperature in the unprotected mullion was 700, so 10 times higher. And that is only because there was this block in the cavity that was omitted. Finally, when the test was over, the facade reached a level of 120 minutes integrity and insulation. And this was beyond anyone's expectation. But the thing just kept going. And amazing results. I want to thank Alucraft for actually manufacturing the sample, bringing it to Technalia, and being a great partner with us on this journey. So we have a range of products that achieve various integrity and insulation ratings. Please speak to us. But safety is important, and we shouldn't forget it. Thank you.
Yeah, thanks very much, guys. I think in all of this, I thought what was really interesting was your pointer skills. You know, Stefan, you were good, but Stuart, I think Stuart wins the prize for pointer skills. Stephen, I think he deserves a prize. Yeah, well done. So, Stuart, just on your presentation first, the carbon control. How does that EPD process work? So you're using your system.
Yep.
You're getting an EPD.
Yep.
Just maybe explain the process.
So we've got the EPDs for the profile for the material themselves that I showed evidence of there. So we've got those EPDs. We're also able to run using our design estimation software. We're able to run project-specific EPDs. So again, that takes into account everything. So it takes into account the aluminium grades that you've used. It also incorporates the glass. Using a Gabi database. We are working with glass manufacturers at the moment to incorporate their data in that as well. Their low carbon glass will soon be incorporated into our software as well. But it also incorporates things like the EPDMs, the screws, everything's incorporated. So we can then run that EPD. So we can, from our specification team, we can run that at a very early stage with facade consultants, architects and clients, all the way through to our subcontractor partners pricing the project and then being able to provide a project-specific EPD at the end of the job as well.
Brilliant. Very good. Very good. Stefan, coming to you, fire is very emotive, and we had some good conversations in Bielefeld about this, but you had said, like, this is all about lives, yeah? And I'm a little bit worried for you because when you talked about your colleagues, one of the colleagues is your wife, right? Yeah, and you didn't mention her, so you didn't give a shout out. So I'm actually worried about your life, yeah.
Absolutely, yeah.
But just in terms of fire, and it is about lives, and we're all facade engineers and facade people. We're not fire engineers. What's the feedback from the fire engineering community on D-Flame? What's the feedback at the moment?
Yeah, thanks, John. This is a really, really good question, and the way we have discussed it with several people. We have discussed it not only with practicing fire engineers in design teams. We have discussed it with test institutes as well. In fact, we have a paper coming up between Schuco and Tecnalia in Spain, and the common theme, I think, with facade engineers is that they do understand that the current regulations and the codes of practice, they need updating. They're just not, in certain aspects, they're not good enough. And the difficulty is that when a building is specified, that has to follow a certain framework, right? Usually you would like to reference certain codes of practice, and you would like to reference EN 1364 and EN 13501 and whatever, and it should be a straightforward process. But they find themselves in a situation where they work on projects, but how do you specify something that is not just code, but you need to add extra bits to it because you know you have to? This is the difficulty that I think they are facing. And I think the interim solution can only be that we all come together and we work together somehow.
Yeah, so again, collaboration is
absolutely,
a big theme. Yeah, very good. Okay, super guys, thank you
very
much.
Thank you very much.
Big bull of us. So the next presentation is from Thomas Gardner from AHMM. We do a lot of work with AHMM. Welcome, Thomas. I think this will be a fascinating presentation. Form follows function, character conserves carbon. So we've got a fantastic carbon theme flowing through the session. Yeah, thanks, Thomas.
Thank you very much. Good afternoon, everyone. I'm here, I'm a director from Alford Monaghan Morris. I'm Tom Gardner. We're based in the UK, but we work worldwide. We have offices in London, in Bristol, in Oklahoma City, in Madrid, and presences in Belfast and in Sydney that we're building worldwide. We do lots of different types of projects. So we're from mixed-use schemes, including Television Centre down in London. We do lots of residential work, lots of office work, including lots of work for Google, repeat client of ours. Arts work, including the Saatchi Gallery, the Barbican Centre, lots of reuse and reimagining buildings, lots of master planning projects, education and healthcare. So examples of those are Lewis Cubitt Square down in King's Cross in London. This is recently finished and occupied by Meta, precast facade with an aluminium system in between. Down at Hawley Wharf, this is in Camden, so next to Camden Lock Market. This is a sort of retail market building with residential brick buildings adjacent. And reuse, this is converting the Whitechapel Hospital into a new town hall for Tower Hamlets, local authority. We also do lots of research. So we have an in-house building performance team, and we try and treat every project as a piece of research into sustainability and urbanism. So we release guides such as our Delivering Net Zero and Use Guide for architects to use in general. And I've divided this talk into two, so form and function. And I'm not as technical as most of the people in this room. So there'll be fewer graphs and more pictures than perhaps you might see in other talks. Then talk also about character and carbon at the end. And I'd like to do that through 3 examples of projects, one in London, one in Cambridge, one in Dublin. And 3 different materials. So one looking at use of stone, one looking at use of brick, and one looking at use of metal. Stone. So we do work on quite a lot of stone buildings in lots of different ways. So traditionally there's ashlar stone, like Portland stone, Nash facades seen in Regent Street, our project Reinventing New Burlington Place with a new stone facade on the back. Looking at ashlar stone laid as a rain screen on a structural backing. And that's similar again to what we've looked at with New Scotland Yard. So down in Whitehall, new home for the Metropolitan Police, creating new stone pavilions and reworking existing stoneworks and maintenance and repair. But I want to talk about a slightly different project. This is Soho Place. This is down in Soho in central London. 2 buildings organised around a central square looking through to Soho Square. And it mainly comprises an office building and a theatre building. This is a project for one of our repeat clients, Derwent London. We worked with for the last 30 years, investigating the workplace. And they and we have an interest in mid-century modernism, so continuing traditions set by buildings like Turani's Casa del Fascio, Lysander Rowe's IIT Institute, or for the theatre, Gordon Bunshaft's work, looking at ideas of transparency, opening up a building so it becomes a part of the theatre of the city, or looking at material. So at the bottom here is the Beinecke Library out in Yale, which uses stone as a transparent marble facade to allow light to filter in. So we have 2 buildings set on Charing Cross Road and Oxford Street, with a public space in the centre leading through to Soho Square and framing a view of St Patrick's Church, the sort of beige building you can see in the centre. And these buildings are built on top of underground stations. So they are icebergs. They have almost as much below as they do above. So we have London Underground infrastructure with the Central Line and Northern Line and a new Crossrail station on the south on plot B. So building A is the office, building B here is the theatre. And with a section through those, you can see the iceberg nature of these. In particular, the theatre. Theatres like to be quiet, and we have rumbling Northern Line and Central Line running right next to them. As well as that, we have extract fans that are as loud as a 747 at takeoff in the service building, which is the white tower you can just see there, which are about that far away from the auditorium. So the whole building's a piece of acoustic engineering. We call it a Swiss watch on an urban scale. But in terms of the facade, looking at this is plot A, or number 1, Oxford Street, and it's a unitised cladding curtain walling system. It wraps around a corner, it rises on the corner, and then steps down to Oxford Street and Charing Cross Road. And it builds on the idea of a simple gridded frame, that mid-century modernist idea. It has a different rhythm at ground floor with 9-metre units for the retail. We have the busiest retail shopping street in Europe, Oxford Street, coming round to Charing Cross Road here. There's transfer structures up at first floor level to then transfer that into a 6x3 grid above. And the stone appears as horizontal spandrel panels. And that stone is travertine. And with our client, we went through a series of visual mock-ups. So prior to the performance mock-ups, lots of visual mock-ups built in a warehouse out on the outskirts of London, where Derwent London like to test lots of their buildings before they build them, which is a brilliant process. And we'd recommend this for any client. So these mock-ups are not real materials, as it were. Some of the metal is actually sprayed timber, but the stone is stone. Some of the metal is metal, and we're testing finishes, facades, the glasses, the correct coating, etc. And that allows us, when we do then go into material selection, going to Tivoli, outside Rome, to pick the travertine and go through the stone selection, to know exactly what we're looking for and exactly what we're going to get, which reduces, I suppose, waste in terms of block selection and our range selection. We know what we're going for. So the end result, having gone through both a physical and a virtual digital dry lay, which reduces the number of journeys to site, works perfectly with the building as built. That's how the form of that stone followed that particular function, an office building and workplace holding the corner of a central London site, presenting a facade to the city. The theatre opposite is a very different type of building. It's a theatre. Our client for this building was very interested in glamour. So the stone here follows a similar language. It's horizontal spandrels, but these spandrels are thin. They are backlit, like the Beinecke Library. And they're set behind the glass, and they form the staircases that cascade down to the ground and that the audiences rise up, so forming a part of the theatre of the city. And we work very hard with Lixos, a company that takes stone and splits horizontal split slabs down the centre, from 20 mil slabs down to 5 mil slabs, and then grinds those down to even further millimetre slabs, laminates them in glass. So use very little stone, cover a large surface area, and it becomes transparent, and you can bend it in this way. So again, lots of visual mock-ups looking at the type of stone to select. And then finally, visits out to select stone. And interestingly, stone comes from, this is the Lasser quarry in Weißwasserbruck in northern Italy, in the Alps. I will attempt to pointer here. There we go. So the actual quarry is here, and they actually sling the blocks across this valley to this point, down this funicular, through this gate and into the yard down there. It's been going, I think, over 100 years. And inside that mountain is this incredible cathedral of marble, where the blocks are actually cut, excavated and pulled out. They have, I think, something around 40,000 years worth of marble in there. So not an inexhaustible supply, but still quite a lot to go. And using that, an idea of a thin stone spread across the building, we can create these backlit facades that talk of the glamour and life of the theatre, and turn them into staircases as well, that are then read through the facade, which is the idea about opening up a theatre to the city, which we can do because the building faces north on this orientation, and there isn't direct solar load. So it becomes a presence in the life of London. That's on the left-hand side of the screen. On the right-hand side is the south elevation, where we have the London Underground infrastructure coming up. So we have a louvered facade that takes out the solar load, where we do have dressing rooms. They get natural light, they get natural vent, and we use a more ribbed system. So as a previous speaker said, it's not the same facade on all four sides. It's very, very different, particularly in this case. So two uses of stone in slightly different ways. I talk about brick. So again, we do lots of projects in brick. So housing projects, social housing, down in Elephant Castle in this case, on a master plan. More small scale, sort of boutique housing, carefully crafted. This is Weston Street, again down in London. And then traditional sort of hand-laid brick in residential housing. But I'm going to talk today about a project in Cambridge. So this is the site. It's just outside the station to the south of Cambridge. The main city centre is up to the north. And it's surrounded on three sides by the Cambridge University Botanic Gardens, which define the character of the site, as do the character of the area and the buildings that are already on the site. So there are 4 buildings on the site as found. Botanic House, top left, the Flying Pig Pub, and then Betchman House and Francis House at the bottom. So the top two looking to retain. Top left is a landmark. The other one is a very much loved pub. Bottom two, built in the 1970s and 80s, end of life, looked at retaining, difficult to do, floor heights, difficult to do. So working with the client, the idea was to produce 2 new buildings, a red brick and a buff brick, sort of almost reinventions of those 2 buildings, but new, contemporary, ambitious, incredibly ambitious, aiming to be the most sustainable and intelligent buildings in the UK outside London. With that, the idea of producing these buildings in a garden-esque form arose. We are in the garden, we're bringing planting to the street, creating views through into the garden, and using the garden-esque form of the garden to create the massing. And that gave us lots of different elevations and lots of different conditions. And at very early stage 1, into stage 2, our own internal building performance team analysed the facades, looked at the solar load, and we iteratively developed a series of horizontal shades on the south and vertical shades on the east and west. And we were able to do that because it was in-house. That analysis then passed over engineers later on, but the quick early process got us to a design very quickly. And so the language of the facade of these 2 buildings is a series of precast spandrels, which are brick-faced. They have precast horizontal shades to the south that extend and retract depending on the solar load and the orientation. They don't do that dynamically, I should add. We're not sliding things in and out on motors. They The form of them, it just depends on their orientation. And then horizontal shades above that, their density extends and condenses depending on their orientation, and their angle also changes. Amongst those, we have vertical fins, which are louvered, with opening panels behind them, so the entire building is naturally ventilated, mixed mode, uses the thermal mass of exposed concrete soffits, and there's plug-in sections for enhanced fresh air for MEP systems up above. So we were trying to design a long-life, loose-fit, robust facade that could be incredibly low energy. This was designed, buildings take a long time, so this was designed some years ago. And we were aiming at that time at, I think, between 55 and 60 watts per metre squared in the external zone. BCO was updated in 2021, and that target came down to 40 watts per square metre. And we hit it with ease with this design, which was encouraging, the idea of trying to build for the future. So what that gives us looking around these buildings is southern elevations with these deep horizontal fins. You can see we actually carve those away where they're overshadowed by our adjacent buildings. So we try and open up and maximize daylight as much as we can, only use materials where we need it. That idea of not putting anything on the outside of the building unless it's doing a job, entirely agree with. But I do quite like jewellery. On the east and west, we have vertical fins, where the horizontal wouldn't give you much benefit because the sun angles are lower. And then on the north, we actually drop the spandrel to maximize daylight. And we raise it back up again where there's sort of privacy, trying to get increased privacy from the building opposite. So that's the buff brick building, we call building B, and then there's a red brick building which follows the same principle, so building C. So horizontal shades to the south, vertical to the east and west, and then dropping the spandrel to get more glazing to the north. And what that gives us in the streetscape, having brought trees to the front to complete the Botanic Garden, is this dynamic, rising, curving, garden-esque campus of buildings that sit within the city and form a new backdrop to the Flying Pig pub. And we think give the buildings character individually, but also work to create them an incredibly sustainable set of office buildings. They're aiming for the highest targets we can possibly do. So BREEAM outstanding. Neighbours, I don't think we're allowed to tell you our neighbours' ambition until we're properly certified, but we're aiming very, very high. And WELL Platinum, Wired Score Platinum, the highest we can get in every area. Metal. So again, we do a lot of different buildings in various different metals. This is the Post building, again in London on Holborn. This is actually a refurb that looks like a new building. So there's an old sorting office beneath this building, which was retained and extended up. It's a series, it's now been a unitized curtain walling system, but with a patinated steel series of details on the outside, and very large windows and floor plates. We've done steel exoskeletons on the idea that buildings often look better before they're clad. Shouldn't be saying this to this room, but the beauty of a simple steel frame expressed in the city, that idea of clarity of structure, shadow, light, and ventilation. You often see the structure standing there and it looks fantastic, and then we cover it. And still looks good, but there's a certain beauty in that we're trying to express with this. Express the structure, show how it's made. But talking about metal, I wanted to talk about a reinvention of a building in Dublin. So this is Boland's Bakery, just down by Granville Quay. This is a historic building when the building was first built, around 1948 to 1951. The previous bakery buildings, the low pitched roofs ones, from about 1873, around there. Bakery started in 1837, but a different site. And inside this building, a series of fantastic spaces. It's an industrial building, a bakery, it has high floor-to-ceiling heights, fantastic natural light, had natural ventilation, and was a great robust industrial building that sits within the city. That was reinvented in the 1980s, became the Treasury building, Treasury Holdings, NAMA occupied it, became an office building, and it took on a very different character. So atrium on the south end, new wings, and a sort of reinterpretation of that appropriate to its time. Revisiting that, as has been talked about, some of that cladding is now end of life, sort of 25, 30 years old. Looked at keeping it, again, warranties, risk, condition, decided probably not, but decided to keep the bakery building, but extend it upwards and outwards. So we end up with slightly enhanced massing, clarity about which areas were the old 1940s bakery, And again, a facade language that adjusts around the building to suit its environmental conditions. The north facade is more of a composition of stairs, lift cores, additions. It's more a series of elements that have been added on. But again, we hold a clear line and show where the building's being extended up above. And the north elevation, again, doesn't need much solar shading, so it's quite flat. On the other elevations, the south-facing ones, we look at, again, deep solar fins in the horizontal, and then on the east and west, more vertical fins. So the area, the corner that is curved, that faces due south, has the deepest and greatest density of those fins. And we're in the process now of a mock-up having been built out in Spain by Inesus. They've done a great job. We think about this as almost hyper-scaled crystal glazing that's been extended and pushed in various ways to 21st century performance from a sort of 19th century invention. And looking at the details of that, you can see how playing with the depth and articulation of that starts to give you the solar shading we're looking for. And installation has begun of that, which is an intriguing issue. It's the high tolerance, high performance cladding units working with a robust but much loved and much battered existing structure in some cases, and being very careful about the interfaces between those, controlling moisture, controlling thermal insulation, making sure the components all come together to form a coherent system. So 3 different approaches, 3 different materials, 3 different approaches to operational carbon in the main. So we're looking at solar load in great detail, looking at thermal insulation in great detail, thinking about long-term flexibility in great detail. But what about embodied carbon? So this graph always strikes me. This is a typical commercial office building, which, as noted, is perhaps only a small part of buildings generally, but residential has a similar but slightly different graph. That operational carbon is now so good, it's the grey area, so both regulated and unregulated carbon is about 1/3 of the whole life carbon of a building. About 1/3 of it, the dark purple, is taken to build the building, and then about another 1/3 is taken in fitting it out over its lifetime. So in our practice, we do a lot of graphs like this. This is a simplified version of it. Effectively, you use a lot of carbon to build it. You then operate it in the grey and use energy, and then you fit out a floor, you refurbish it, you might change the cladding, you might redo your glazing units after 25 years. And then after approximately 60 years, you dismantle it. You hopefully recover as many materials as you can, and that's your whole life carbon over 60 years. So obviously you want to minimize the first, minimize your energy use, and try and build the building as flexible and loose fit as possible. We've just released in the last week a study on Cat A fit-outs and how the first thing you often see as a new tenant comes to a building finished with fan coils and raised floors is skips full of that Cat A fit-out as the tenant comes in and does their own thing. And then at the end of their tenancy, they have to put it all back up again, and the next tenant comes in and takes it all out again. So the lease and dilapidations agreements of those, we think, could be treated in a different way. But with this graph, time comes into play, and we don't have time is the issue. So at the end of that 60 years is the sort of getting towards the end of the century, but we need to drop our carbon emissions now to limit warming to 1.5 degrees C. In February, we had a year of temperatures above 1.5 degrees C. So we're already outside that limit in terms of single year. We'll have to go a few more years to see how consistently we're outside that limit. So that initial spike of built embodied carbon is more and more important. And what do we do about it? I think everything that's been talked about this morning is largely what we do about it. You analyze every single piece of a building, you set your carbon budget, and you try and drive that down as much as you can through the supply chains, through the initial design, through the massing, through the technologies we choose. But I'm not going to talk about that because everyone else can talk about it much better than I can. I'm going to talk a little bit about character, and we're interested in a key thing about a building is that you want to keep it. If you love a building, you will take care of it, and you will keep it, and you won't demolish it, and you might not even rip the cladding off. And we're very interested in that, and the idea that there are certain parts of the building you want to be robust and keep and stay. So character is the personality of an individual. Perhaps it's moral characters. Not sure if a building can have those in too much quantity. But it's about careful work. We're not talking flashy icons, perhaps. We think a building with character is a patient, careful process. And it should sit within the city. And our publishing arm, Fifth Man, has released this book of our work where we talk about this idea, extraordinary. It's ordinary, but it's extraordinary. It's buildings of the city where we live, work, play. They should disappear into the background, they should be part of the fabric of the city, but they should be extraordinary. And buildings that have been loved and that we have converted can be, again, things like this. Listed buildings on Regent Street in London. That's pretty obvious. Other buildings of different characters. Actually, O'Callaghan talked about this one, IBM on the South Bank. Again, listed, Dennis Lasdon. Big piece of work. But a certain approach to, I suppose, composing space and a certain attention to composition, attention to materials that means we want to keep that building. But then also simpler, more humble buildings. So a warehouse on a corner on the outskirts of London, the Tea Building, which we've been working with down at London. We've reinvented time and time again over the years with a series of small projects. Again, this has brittle glazing. That's been upgraded. The entrances have been refurbished. The rooftops have been extended. The cladding's been insulated. And over its life, it gets refurbished and refurbished. So it has a certain character, but a character that wants to be preserved. And I suppose we're trying to do that to an extent with the buildings we do today. So this is Benjamin Street. This is a building for the Guild of Girdlers, who own the site in London, make belts in the City of London. They have a very long-term approach to their investments and their architecture in general. So they were interested in a building that could be long life, loose fit, and last a long time. So robust materials, around 40% glazed, and the idea is that other 60% of the building stays and persists over time. It's a simple concrete frame, it's a simple plan, and if you need to replace the windows, you replace the windows, but you don't need to or want to reskin the entire building. This is the Ray in Farringdon, slightly in the background. The historic building that's in the foreground is Victorian warehouse, but again, taking that language and running it through a new build to try and give it the personality of the old. And so even on large mixed-use new build schemes, so this is British Land down in Canada Water, we're looking at, if a facade is, say, 40% glazed, can the other 60% be something more robust, long life, with its own personality, with texture and detail and character? And so I suppose the new idea today is an old idea. You make a building, you give it a robust fabric, and then you put very high technology, very high performing elements within it, which used to be called windows, and now can be called many things and do many jobs, as one approach. And that's what I have today. Thank you.
Thanks very much, Thomas. It's funny how incestuous the facade industry is. I was looking at your mock-up picture, and I think it showed John Gribben.
Yes.
Yeah. So John is a design manager with PJ Hegarty's, I think.
That's right.
I worked with John. I think 10 years ago in Lendlease. He used to work for Lendlease, and then he moved on. But he's an exceptional guy. I think he's a trained architect, if I'm not mistaken.
I believe so, yes.
Yeah. Challenging, I would say, Thomas, yeah.
He's good. We enjoy working with him.
Very, very interesting. So it's interesting the way the morning's gone. We were predominantly talking about aluminium and glass, and now we kind of started to move into stone, brick. And is that something as a practice that you would look at? So you talked about time and whole life carbons. Is that something that you focus on, let's say early days, stage one, where you get longer design life, service life out of different materiality? Yeah.
Yes, is the answer. I mean, it's come from many different areas, but we do a lot of retrofit. We started that very early on, and we did a lot of refurbishments of warehouse buildings. And those long life, loose fit buildings with brick facades and incredible ceiling heights that were being reinvented for all sorts of purposes seemed a fantastic model to take into new architecture to us. So we did what's called the white collar factory, that tried to reinvent that and do a 21st century version of it. So yes, I suppose that idea about robustness comes into that. And then we do embodied carbon assessments on every single piece of facade we do. And obviously building out of concrete and brick can be carbon intensive. But when we look at either the aluminium systems that need to use it, or the aluminium technology is getting better and better, or other lightweight systems that need steel framing and reinforcement, often we find there's not that much difference in it. Again, depending on which materials you use, and the variance between EPDs of the same product can be vast. But yeah, the idea of elements of the building that last a long time, we think about theatre, stage set, and props. You build a theatre for 100 years, 200 years. Stage sets come and go within it, and your props come daily. And the idea of different cycles of permanence in a building, we're very interested in.
Super. I think we're slightly ahead of time now on this presentation, which is unusual for a builder to say. So
I tried to stick to time.
Yeah. So we might leave it at that and move straight into the panel. Thomas, thanks very much. Fantastic presentation. And
thank you.
Yeah, thank you. So I don't have my program. You wouldn't give me your program, Stephen, would you? So we might call to stage the panel presenters. So we've got Mr. Coleman Billings, who's waiting in the wing here, who's going to moderate. And then the panel is Seamus from RKD, myself, Kieran from Passive Dynamics Sustainability Consultants, Mr. David Entwistle, Director of Major Projects with Saint-Gobain, Dr. Glass, and then Tom Costello from Head of Development from IPUT. So welcome, everybody.
Thanks, everybody, for coming along, and thanks to the panel for joining in. I'm not sure if I'm supposed to stand here or sit down here. I might sit down in a minute. The idea of this panel is to have a reasonably open conversation about what we should be doing and what we are doing and what we should do in the future. But there's a lot of existing buildings that we wanted to focus on for now and then look into the future. But when you talk about circularity and you talk about recycle, reuse, these are terms that are getting slightly abused. And we want to talk about proper recycling where you're not downcycling, but you're keeping things on a level so that we can say it's a proper part of the circular economy. I think, John, you had some words from CWCT in how they use these terms and how they're developing papers for us to better understand these terms.
I think just in general, for anybody that doesn't know, you can go onto the CWCT website and look at, I think there's 12 papers there at the moment. Most of them are free, so you can go on and have a look. But what we noticed was that we had to start, from a sustainability perspective, whether it's circular economy or not, we had to look at terminology and get everybody onto the same knowledge page, if that makes sense.
Yeah.
So that that information is there. Then we moved on to kind of discussing again with the CWCT and the partners that are involved, looking at transparency, looking at consistency. So as we calculate carbon, are we all calculating in the same way, or is Anthony's tool in Arup the same as Graham's calculation tool in Ecclesy O'Callaghan? And they are now, because we've developed a methodology, and their tools are now in line with that methodology guidance that we've produced. The next thing is moving that onto supply chain and making sure that our supply chain are doing the same thing, that our manufacturers are doing the same thing. And I think we might start talking about greenwashing later on, but there's an element of that starting to come in.
So you can get a level playing field.
Yeah, exactly. Yeah.
And when we apply that to existing buildings, and you can see, like, as AHMM are doing, and we're working with them at the moment with Kieran on a project in Dublin, looking at buildings as assets and looking at, can you continue with this building as it is? Can you just maintain it, and is it still a marketable asset? And I think Tom, you had a few words about what you need to do with assets as a developer, as a building owner.
Yeah, and I think the previous talk there by Tom Gardner is an interesting segue to what I'll say, because on the one hand, we're talking about facades, a lot of focus on the sustainability side of it. Then we had the architect's viewpoint before that, and now, say, a developer. So it just puts the thing in context a little bit. So obviously there's been a lot of talk recently about the future of offices and the challenge of in the business we're in, there's been a big reduction in values over the last couple of years. So the iPut fund, if I just say, iPut is a property fund here in Dublin. It's around 60 years, so we've gone through a number of cycles. And values, and it's international in any case, but values have probably dropped by 25% in the last year, or close enough to it on the offices. We're mainly in offices and logistics, mainly in Dublin. So our fund value was 3 billion, so it's down about 2.5 billion. But just on offices generally, we love offices, and we are really embrace the whole concept that it's a challenge now in terms of creating places that people want to work. So over the last number of years, because of the demand for tech space here in Dublin, the pace of development was much faster than historically it might be. So it has created a little bit of a glut, but the glut is of high quality offices, which we and the developers who own those are very happy that those high quality offices, there'll be demand for those in the longer term. And the real challenge then is for the 70s, 80s stuff where people maybe, because there was a demand that wasn't fulfilled over the last number of years, the mediocre space was almost attracting the same rents as high quality space. But now what's going to happen over the next number of years is the high quality space, if anything, will edge up slightly higher, and the poor quality space will drop. So they will drop fairly quickly, really. So the rent here, the high quality market here was about €60. And really mediocre space over the last decade was still getting €50. So that's going to be quite a difference as time goes along. So then the other bit I just want to talk about, just in terms of where we look at our assets. So we build assets very much in the theory that Tom talked about there, is looking at it as something, we own our buildings, we hold on to them, so we build buildings that we love, in spaces we love, creating a public realm around them that we are mindful of improving. But if we look, say, at buildings where they're coming to the end of a lease, and we have a number of them, I'll just quote them because people will generally know the buildings I'm talking about. So we had 2 buildings in the city at the moment, where was North Wall Quay, where Goodbody's was a tenant, and George's Quay. So those were coming to the end of the lease. So we look at them and see, and it's a term that's been used a bit here. I don't know exactly where it came from, but the notion, has the building got good bones? So as Tom says, a lot of it is, if the limitation on floor height means generally it's going to be difficult, and there's not much point spending a lot of money upgrading a building which is very compromised in the future. So, but in the case of those 2, we were lucky enough that we could add 25 to 30% on in terms of area, in terms of height. And that additional height will fund the redevelopment of the building. When I say redevelopment, is we just keep the structure, and it's completely new facade, new services and all of that. So that's one model. Another one is it's on the screen there, Stein House, which Coleman was involved in. So that's one where the tenants are in place, and we look at how do we make that building fit for the future, so that it's not going to be stranded, so that people would be attracted into it. And again, Tom used the term, we use the term of the building identity. Tom used the term there earlier of its character. So that's, in a way, that's location is important. Yeah. The term character or identity is important. And then obviously the whole sustainability of it's important. So there's a number of other ones. And then another one recently we got planning for, which is the Deloitte building. where it's an unloved building. It was one of the buildings that was called a sick building going back some decades ago, but it doesn't have many redeeming features. So we looked at redeveloping, which in essence is demolition of that whole one. So in the last 2 weeks then, we got a planning there for a really good building from our point of view. We got a lot of increased area and all of that. So there's a whole lot of different thing. And then, finally, and I won't go on after that, is just the challenge then of, people say, can you convert it to residential? In a way, that's two things. For building, if it's a building and you cannot increase the area of it, and it's an office building, but you have to spend a lot of money upgrading it to make it attractive, or you want to convert it to residential, one thing that has to happen, first of all, is the value has to be, and people's value, it has to drop hugely. It has to maybe go from, €600 a square foot down to 200 euro. Right? And then the game is on. And finally, I'll just quote you one instance. So the building that we refurbed going back about 6-7 years ago was in Molesworth Street. It was the old EU office. So we bought that building for €200 a square foot. We spent €400 a square foot upgrading it. We sold it for €1,200 a square foot. It's back now on the market again. But if you have good quality, the market will hold. So it's actually, there are offers on it for in excess of €1,000 a square foot. So there's a story in that, really, is if you have high quality, but sometimes in order to invest in it, it either has to have low value or opportunity to add on to it.
So it's upgrading the asset is often a requirement for incoming tenants and things. And if we go back to Stein House, which Seamus, it was RKD were the architects on that. Originally it was a DMOD building, and we saw the image earlier on, and it just looked like a dated building, and we can't get away from the aesthetic moves on, and what is cool in the 1990s may not be working for you in 2024. So the work that you did on Stein House, and we worked with you on it, we actually retained the curtain walling profiles. The aluminium system is the original system, but we achieved an entirely different looking building. And do you want to just say a few words about that?
Yeah, I think there's a few different sides to it. Like in Stein House, there was a twisted facade that sort of gave the building a bit of identity. And just back to Tom's point on identity, I think that's really interesting in the current market because things are changing, and we're seeing more involvement from tenants in building selection and what they want. And sometimes identity isn't always as visual as a new facade. So things like really high quality endo-trip facilities, the sort of offering at ground floor, be that food and beverage or something unique that gives that building a USP, all sort of help create a new identity for that tenant. So sometimes, sort of perversely almost, we might start and everybody might think that the building is about the facade. And after looking at that facade and discovering that there's another 30 years left in it, we sort of redirect our focus and we decide that actually we're going to embrace what this building looks like, and we're going to really focus on adding to it, looking at the ground floor, how it interacts with the street, what it does to the public realm, or maybe it's something that's less visible, like creating an incredible bike hub at level -1 with a gym and bringing the atrium down so that every office user can go straight in down their bike ramp and then back up into the building. There's still an interesting piece about changing the appearance of a building, and in Stein House, I think we did that quite successfully with adding to the facade.
We actually kept as much of the material as we could in terms of the aluminium profiles. We did replace the glazing, partly because it wasn't performing particularly well, but partly because we needed to do some opening up to get at the structure to carry the fins to give us extra shading. But if we'd been in London, David, we would have been able to take that glass and recycle it, and we would have got a carbon benefit for that.
Yes, Coleman, we would definitely be able to recover the glass. I mean, it's an area that's taken off, certainly within London in the last 6 months, where we've really sort of cracked the code to get commercial glazing off buildings and return it back to make new building glass. But it was a nearly 3-year gestation period to get to that point. But at this point, everybody's embracing it now. And what's interesting is people's motivation for doing it are very varied. Interestingly enough, Botanic Place, we did a site visit this week with the express idea of recovering the glass and returning it back to building glass.
Yeah.
And sometimes it's the client, sometimes it's the demolition contractor, sometimes it's the architect. It's amazing the avenues that appear that actually open this door, and we are now actually making that happen. So, interesting times, very interesting.
And a lot of that comes from work stages analysis of what is the current building performing like today. And if we're going to do all this work and we're going to use carbon to upgrade and improve the performance of the building, that obviously, there's a building that's operational right now and it has a facade on it. And we're starting to see a steer away from just straight in, replace the facade and do something else. And there's a proper bit of analysis going into, should we keep it? Is it actually beneficial to keep that facade? Is it working well enough? Or is there something else that we can do to upgrade it? And maybe, Kieran, you can talk a bit about that kind of analysis stuff and making sure that the modelling is lining up with reality.
Yeah, well, it starts with building a digital model, a digital twin, a building performance model of your actual building and trying to represent that as best you can in terms of the actual real building. It's important, I suppose, to understand as well what your current U values are. What is your starting point and where do you want to get to in terms of that journey? What we often find is that if you're starting, say, for example, with a facade that's performing with a U value of around 3 and you maybe want to get to 1.4, there is a point you'll come to where you're at a point of diminishing returns, where you're not really continuing to see those savings. So you'd convert that energy saving if you're starting with a U value of 3 and maybe you're working your way up to 1.7 or 1.8. You look at that operational energy savings, you convert that to carbon, and that's quite easy to do. You can even convert it into projected carbon as well. So the grid is going to get cleaner over time. So you might decide to take that into account. And then on the flip side of it, on the embodied carbon side of things, you'd look at your glazing and then your entire facade. And what we'd often find is that if you're replacing just the glazing, you might have an embodied carbon of in the order of 50 kilograms of carbon per meter squared. If you're going to change the entire facade, it could be 3 or 4 or 5 times that. So that's your carbon budget to work within. And then you have to work out, well, at what point is there a tipping point where my embodied carbon is getting so high? If this building is there, or over the lifespan of the curtain walling system is 30 years, is it going to pay for itself in terms of carbon terms? So you'd be sort of balancing the books there, doing your digital twin model and making sure that the decisions you make are well informed. And apart from carbon, you'd be looking at other things as well as daylight and solar gain. All that is quite important as well, because that might have an impact in terms of your overall operational energy as well. So there's a lot to it.
Yeah. Now we were looking at 1 George's Quay Plaza, which is actually Ireland's first unitised curtain walling system. It was put in 2001, and we looked at it in 2023. And it's actually fantastically well preserved. It's an anodized aluminium profile with double glazed units. The G value of the glass is 0.37, which we see all the time with projects that we're doing now. The center pane U value is 1.3, but we reverse engineered the thermal modeling of the curtain walls system, and it's 2.7. So when we were looking at that, we were saying, well, should we keep this facade? It's really, really well built. So in terms of what else could you do? Like if you want to just keep that facade, do you look at air tightness? Do you look at introducing solid panels, or what kind of things would you bring to it?
I think air tightness is very important. Yeah, you'd certainly have to review that, carry out some air tightness tests to see how is that performing. It might be performing reasonably well in terms of U value, but is it leaking a lot? So that would certainly need to be addressed. And then, yes, carrying out daylight analysis to see, although your G value is performing reasonably well at 0.37, is there maybe too much daylight there? Do you need all that glazing? Could you introduce some solid panels to that to reduce your solar gain and still optimize your daylighting? So I would say with U values as good as that and G values as good as that, it's probably a harder case to make to replace the glazing, because you're starting at quite a good starting point anyway.
Yeah. Now, we had another issue that the glazing on it is structural silicon bonded to the frames, so it's painful to take that off and do the replacement. But I think there's other issues as well, David. We were talking before about the latest standards for engineering glass are resulting in increased thicknesses and weight penalties.
Yeah, I mean, one of the questions I get asked is because our strategy, it sounds a little bit brutal, but our strategy is we just want it broken and we'll take it away and we'll recycle it. And obviously within the waste hierarchy, the idea of reuse, well, doing nothing sits at the top and reuse is next and then recycle's next. But when we start looking at the concept, could we reuse stuff, we just hit a whole lot of issues. We've got EN 16612, which calculates the glass thickness, and it doesn't particularly like laminated glass, so it's pushing glass thicknesses up. We've got a question of, how strong is 20-year-old glass? And there's a load of studies going on at the moment to say, what's the residual strength of 20, 25-year-old glass? Is it as good as the day you made it? And the answer is probably not. So then you say, well, can I get a CE marking? Can I get a declaration of performance? Well, no, you can't. Can I get insurance? So you just kind of hit all these issues with what you've currently got on a building, which is why we kind of do this kind of brutal, let's just smash it up and start again mentality with it. And I think, we've got a job in London we're looking at the moment on Bishopsgate, which we put the glass on 25 years ago. When you actually look at the rebate size, you either got to get your cavity size down because the glass thickness is going to go up. You either make your cavity smaller, so then you hit your U value issue, or you try and create some sort of extender profile on the front to take a bigger unit. So, those are all the sort of practical things that people have to look at. Even if they just wanted to keep the aluminium frame on the building, you're unlikely to be allowed to use the same glass thickness now as you could have done 20 years ago. So.
And John, you worked on Triton Square in London, which was originally an Arab Associates building.
Yeah.
Take us through what you did on that.
Yeah,
that was
so
quite interesting.
It was a British land project. Lendlease built it originally back in the 80s. Scheldebouw were the facade contractor. Arab were there as well. And British Land wanted to, the building was probably close to the end of its service life. Certainly the facade was. They wanted to fill in the atrium and create more usable space and then go up the 25% that Tom was talking about. So when all the numbers were crunched and the facade was kind of interrogated from a due diligence perspective, it made sense to retain the facade and I suppose just take it off the building, do whatever we had to do with it and bring it back again. The interesting thing is that it was a double skin facade, so it would have been first of its type way back when in the 80s. We retained the external skin, which was toughened glass, and as a policy, we don't use toughened glass. So we had that interesting thing to get over. But at that time, we weren't recycling glass, David. So we took all that glass out. It did get crushed, but there was no. You weren't doing your thing at that stage. So we couldn't go to Saint-Gobain. If that was now, we would do that. And bringing that back into that glass back into the value chain would have been really important. Arup did all their calculations, and the saving in carbon was just enormous because this is a big building. We were interestingly Scheldebouw, after we went through a tender process, then told us they couldn't do the job, they were too busy. So we had to go to Gardner, who were part of the same, the Parma-Stedisa group, and they seconded, which is amazing, the same project manager that was on it in the 80s came in and helped out in 2022. We went back to the same quarry to get the same stone. It was an immensely difficult project, but it was so rewarding that we have a building that increased in size, increased net lettable space, performance-wise, because it was double skin facade, it works so well. And then I think
didn't you took the unitized panels off?
So we took
and put them all back again.
And put them all back again. The original drawings were available. Arab were there, and I think some of the original Arab guys were around as well, Anthony, to help out. So it was amazing. You had these kind of older people coming in who'd worked on the original project, helping out. But so it was an amazing project. The interesting thing, and that's why I was asking Anthony the question, when it came down to warranty, Parma-Stedisa were pushing back on warranty. We were kind of going, well, we have to get this over the line somehow. And it was at the end of the day, it was effectively British Land, Lendlease, and Parma-Stedisa coming into a room and saying, this is what we're going to do, and there was a deal done.
And we did the same with iPut and Steinhaus, where the aluminium profiles were architectural aluminium, and it was their own system, so it wasn't like a Schuko system that you could swap out parts. But in fairness to Alucraft, they did go in and replace all the gaskets, retained all the profiles, and we had to do a deal on the ownership of the bracketry and the bolts and the fixing back to the structure. And some of the things that we found that weren't particularly great that had to be redone. And there was the buying in of, we're all in this together, we're trying to work and learn how to do retention of a modern facade, because this is what we're finding, and it's relatively recently, it's like really in the last year, we're seeing curtain walling, stick system unitized on perfectly functioning buildings, but the asset is becoming challenged and it needs some form of upgrade, whether that's new glass into it or adding some feature to it. And in doing that, we're having to have these conversations about who owns what, who has the warranty for what. And you have to draw quite clear lines. But it only works if you can work together with the industry.
What we're finding is, particularly work that was done in the 80s, that the likes of Schmidling, the likes of Chamberbell, those older facade systems are actually quite robust. There's lots of redundancy in there. So you may have to look at the fixings, the bracketry back to the building, but the actual chassis, the aluminium framing itself.
So it's good bones.
Generally quite good. So I mean that's interesting. It'll be interesting when we get to start to look at systems from the 90s and then the noughties. Is that going to be the same thing? Because we're value engineering out quite a lot of that redundancy. So I think material fatigue will become more of an issue in the next 10 years.
As they're getting finer and finer. Although what we found on George's Quay was every bit as good as anything we'd see now. Like the fire stopping at the slab edge was pristine. It was a really
amazing, isn't it?
And it's a really well built building, which was talked about earlier on. That if you do it well day one, and I think there's a lot of architecture comes into that as well. That if you were to start from scratch with a blank sheet of paper, you'd look to have something that isn't going to age, but it's hard to judge what's going to age. Like I think fins are going to age. Every project has a bunch of fins on them right now. But if we were to look at the future, so we've been talking about existing buildings and trying to maintain those in a circular economy, trying to keep them on the go. Where you are doing a new build, what would your starting point be now, Seamus? Because it's changed over the years.
starting point for a new build.
Yeah.
New builds are easy, you know, and we're predominantly working on larger refurbs at the moment. So I think the principles around a new build office haven't changed massively. And maybe just to go back to a previous point, I think what's interesting for architecture and the role of the architect is that I think our role is changing, and I think that's a good thing. And we see some clients or building owners, maybe a building owner who hasn't been a developer before is becoming a developer because of a lease event, as they call them, coming up. And we are tasked with helping the client sort of figure out what it is that they need to do to bring their building into the next couple of decades ahead. And that's a bit of an unknown, and there are certain quantifiable things that an agent may recommend, such as replacing the MEP, upgrading the BER, maybe a new Cat A, maybe making sure that the WCs and the showers and all of that, bike parking is compliant. Everything else can sometimes be a little bit up for grabs, and I think it's our job to try and guide some clients on what we think tenants actually want. And back to facades, I think a lot of the time the replacement of a facade can be based on ego or the assumption that a tenant wants something that looks new and is new. And I think our challenge, and it's quite fun and it's an exciting sort of process because we're working with agents and developers, and there's a budget, and trying to figure out what's really important and where we need to spend the money to ensure that building becomes timeless.
Yeah. Well, I think one of the lessons we've learned is robustness. I mean, number one, Grand Canal Dock, which is one of yours, Tom.
Yeah.
That's now getting to the point where its energy performance is definitely in question, but it's so unique and special. It's what could you or even would you want to do with this building?
And that's another interesting, just on what I talked about earlier. So we're fortunate that we have 10 years to run on the leases here. So you could say that's fine, but it's not fine because it goes back again to the building identity. So the location is wonderful. The building is unique, but it has its challenges. So over the last 2 or 3 years, we have engaged in We've put in really high quality new reception area into it, new end of trip facilities. And there was one floor there where we put in our making it work model, which is a flex office model. And it, in a way, that showed people how you could refresh the building and make it really modern in terms of a fit out. But the challenge, going back to even say what Kieran was talking about earlier on, is now the energy rating, and it's something we need to be looking at there over the next couple of years, because there is that stranding challenge where we have to be mindful of it. No point arriving in 7 years' time and you have a lease event coming down the tracks and you say, what are we going to do now? So we like to think in all ours, we're thinking ahead. If you have a building which has an identity or a character, then that's really valuable. So you have to continue to hold on to that. But it's an interesting thing, which there's some people in the room like Anthony, yourself, and Kieran, where over the next short period of time, we need to look at that whole challenge of the facade.
Yeah.
And is it do you keep it or not? It's all really interesting. But you go back to what you asked there about new buildings. One thing we recognize now as a developer is that at the really early stages of a new build, you need to engage with the industry in a really active way. So like John talks about recycling glass, we need to talk to the contractors here about procuring aluminium, recycled aluminium, and be really mindful. Don't just design the thing too far that you can't recognize the where the industry has gone in terms of sustainability and the opportunity to do things in a really sustainable way. Really, so
Yeah, like I think there's a number of things we're all learning, but where we're looking at projects now, I'd love to be able to bring architects along to some of these buildings that we're now inspecting. And when you have a structural silicon bonded glass on the outside of a facade, which looks fantastic, and it looks fantastic all the time because it is just glass, and it's so robust as a material. But when you come and say, well, we want to do an energy upgrade, and one of the easier ways of doing that is replacing the glass and possibly replacing with solid panels as well. But it becomes really quite difficult if that's a structural silicon bonded system. But if you had capped curtain walling, you could keep everything. You keep the external cap, the internal profile, you can replace the gaskets, and you can whip out the glass and put in new glass. And things like where, David, we've been talking about recycling glass, and we have ceramic frit on spandrel panels or ceramic frit on portions of glass. And right now, to capture that glass, you don't want the ceramic. And so we're causing trouble for the recycling. We can make it we can make it easier if we can have simple double or triple glazed units, which are an individual sheet of glass that doesn't have any frit on it. And that just as one little design feature to say, look guys, if we do that, then when you get to 20 years, and it isn't generally 60 years, it is 20 years. Like I'm looking at buildings now that I was the facade consultant on, and I was designing the glazing, and we're being asked to look at changing it or upgrading it, and we still have the drawings. Mm. But the lessons that we're learning are that going further ahead, things like an anodized finish, which has a higher carbon penalty initially, but look at the quality of that finish 20, 30 years later. It's fantastic. Mm.
It's a tricky one, Coleman. Like I think when we talk about flexibility, we don't know what we're designing flexibility for sometimes. And you know, if we look back at sort of previous generations of office, I think the 1960s and 70s are inherently more flexible in terms of conversion into resi, say, but they were never designed to be converted into resi. You know, likewise, you know, Georgian townhouses in Dublin were never designed to be offices either. What we're building at the moment are deeper plans, higher floor to ceilings. In one sense, they are flexible in that they could be converted to residential in a certain respect. But as Tom mentioned earlier, you know, there's a cost with designing in flexibility when we're not sure what that might be in a building that we're designing for 60 years. But there's also an imbalance between, you know, one of the buildings on the screen, Adelaide Road, the value of sites and the value of offices just doesn't tally with the value of potential residential on it. So we can get 34 apartments into an existing building, or we can replace that building with a 21,000 square metre office. And those figures just don't stack up as it currently stands. But I think in terms of the flexibility, it's interesting because there's very few sort of credits or reasons why say a developer may pay or lose area to enable a future alternative use for their building when, you know, inherently it's the shorter term, which may be a 20 or 30 year tenant that's going to occupy the building for that current or, you know, immediate use.
Yeah, so I think we are looking to just, in terms of circularity, there's obviously the aluminium world, there's stone was talked about earlier on. We've done a couple of jobs where we've taken the stone off and reused it. And these are durable materials, and I actually think that's the direction we're going to be going. It's going to be all about durability. There isn't actually a measure for that right now. We talk about carbon, but if you were to talk about durability, it's a better discussion because it's a longer life and a more recyclable, but you don't really want to be recycling. We want to be holding on to that. Like we're doing a project with one of the universities, and they were looking at aluminium rain screen versus stone. And actually stone is the better answer. It causes them a few issues, but in the long term, the stone is going to be the correct answer.
it's interesting, Coleman, when you look, let's say, at the London market and the likes of Grosvenor and Great Portland Estates, they are starting to set up material repositories and creating libraries where you can store material from one project and then potentially use it for another. And I know David's been talking to them as well, but like Great Portland Estates, their workload has shifted to about 95% refurb. So they're fully invested in this now. So they're now using reclaimed steel from one project on another project, and so durability, materiality that has longevity is interesting, particularly when you look at, say, Great Portland Estates, who now have an internal carbon tax of £90 a tonne. So they're incentivizing within their business to do better.
Wow. Yeah. There you go. You want to incentivize your business.
Yeah, so I'm listening here about stone and brick and all that. I just going back again to the building's character, its identity, and this is a nice thing to say because this is an industry event. Glass and what it does to a building, particularly the internal, the enjoyment of a building, the daylight, the views. It's a huge, in terms of the building's attribute, it's still right up at the top of the list, really. There, and certainly, no, it really is. So it's important to recognise the event that we're at.
So I think that more or less brings us to an end, unless there's any questions from the floor. You've got 90 seconds.
Everyone's hungry.
No questions from the floor? No?
When's lunch?
Can I say a big thank you to Coleman for moderating this panel and to all the panelists for their contribution. And one other small thank you to say, and that's to John. John's not going to be with us in the afternoon. He has another engagement to go to. Thank you for being part of today and being, part of the hosting of the event. Really appreciate it. Thank you. The rest of you, please enjoy your lunch, and we will come back again in about 45 minutes for the afternoon session. Thank you. Very good. Welcome back. I hope you can hear me at the back. Please take your seats. We will start the afternoon session. I hope you enjoyed the lunch. Was the lunch good? Yeah? Okay. I think we're ready to go. Our next speaker is Rory Murphy. He is a director at Reddy Architecture and Urbanism. And Rory's talking to us about facade and envelope connections and the relationships thereof.
Hello, everyone. Yes, so particularly coming after what was discussed this morning, and I suppose there was a lot of detail, a lot of quality work, a lot of quality projects and speakers. What I was looking to do when I was asked to speak was try and look at architectural expression and maybe its discussion and even a group discussion like this in a slightly different context. And I was thinking about the connections in buildings and facades and the relationships between the people who work on these buildings and the pattern of those relationships and the patterns of the buildings and how you build on pattern. And so in terms of just a kind of a context, so it's this whole matrix of relationships that we rely upon. And we tend to, because it's a facade conference, I'm trying to look at maybe a focus on that and the story of that relationship and the fact that we have probably, where materials meet is where the difficulties arise, like where people meet. As an individual, you are yourself, you develop a little bit, but when you bump into the person beside you, that's where either the success or the difficulty occurs, and it's the same with buildings. For me, interesting when you look at we're across all these sectors, yeah. And as a practice, we work in healthcare, master planning, architecture in terms of everywhere, interiors, workplace, commercial, conservation, residential. So today, what I'm going to look at is a series of buildings, but discussing them from a different perspective in each case, all arriving with the facade, all having issues within them, but taking an angle which I think you'll find interesting, I hope, let's say. So within all of those projects, there is a huge array of participants, yeah? Serious, experienced people. So I've just put them all on the page there in terms of the connected relationships of knowledge and intertwined knowledge. And if you can get the crossover between projects, sometimes there's great information in that and great experience. So we have, developers, project managers, architects, collaborative architects, facade specialists, engineers, specialist consultants, and even up there, Sistra, for example, traffic engineers. Lots of energy goes into the building. There's lots of issues to cope with all the time, at the same time as trying to juggle the game plan, which is this idea of how is the building going to perform, and economically, how will the building sit in the marketplace at the end. So we spent, as a group, our lives on teams. There were no teams originally. We were going to meetings in person. And I was looking at this issue. You usually go take an hour to get to a meeting. You'd maybe sit in a meeting. You'd have a consultant there whose opinion was really valuable, but you had wasted maybe 2 hours of their time for 5 minutes of their opinion in the meeting. And that world changed with Microsoft Teams. And it made me think a little bit about where the architect sits in the team and how the architect can try and help with the energy of the team. It's dynamic. It's sustainability, because ultimately we talk about sustainability all the time. We're talking about energy, carbon footprint. We talk about materials, U values, G values, Part L, heat producing appliances. And really we have to look at sustainability of human energy a little bit as well, because creativity, discussion, you all coming here today, us going again for the next building, it all requires human energy. And I think that's something that we have to give back to each other. If you ever stand beside somebody and they're taking from you, or you're giving to them, you have to recharge. So this conference is about that recharging. But in terms of teams, look here at, say, the rugby, which is currently quite live, and unfortunately we didn't win last weekend. But I grew up watching the All Blacks, and the All Blacks were the team to beat, and they were the team to watch. But the reality was that we couldn't play as well as them. We didn't play as a team. When I was young, we were always losing. But the ball for me was a matter for design. And they all cared about the ball. They all cared equally. They moved across it. And so we have seen in the last generation of players a much better understanding of the team and where people play in the team. And rugby I find interesting because if I'm slightly indulgent, the architect likes to think of themselves as the out half, the creative, the playmaker. But sometimes it's a bad day, and you're not playing the right game. And sometimes you have a great footballer who maybe is a great position player, but not a good team player. And I used to think of the match where we were playing the builder, whereas actually we're all on the one team, and we're playing the project. And the game doesn't always go according to plan. And what do we do together as a team when it doesn't? So I looked at this slide here. I was just trying to give some context. So looking at teams in terms of the T for technology, construction technology, information technology, we've been kind of more and more absorbing more and more data in my lifetime. I mean, at the beginning, it was just making space, and there's more and more information coming. We have to control it as architects. The engineering becomes very important, because that needs and the architecture sits in the middle of that, trying to regulate both sides. Then there are parties who have to manage the issue, manage the expectation, manage the program, manage the team and the energy, and we require momentum to get that done. And then success and sustainability comes out of these projects. So I've just taken a couple of stories from each building with a different focus on it, and I'll try and go through them quickly. So this one here, the first one is Deanston Wharf in London. Ballymore project, really successful project. Collaboration where Glenn Howells would have done the basic permission, builders were involved, modern methods of construction, all about technology. And it sits at the, it finishes off this development on the River Royal Wharf. And what was interesting was if I try and use the pointer, sorry, am I using the pointer? There we go. Yeah, so the two of the buildings here were built using MMC, and these blocks here were using traditional construction. And what was interesting in the course of the construction is that the manpower required with builders, where all of the components were fabricated off-site, was that 14 people were assembling the buildings, whereas a traditional building took more labour. But at the end of the job, we ended up with the apartment layouts which were set. They were already modular. They were a similar pattern in both buildings. The assembly details, a lot of work went into the time with builders. Yeah, a lot of prefabrication. Again, you see the same issues of fire, facade, ventilation, assembly, but the time scale on the buildings was actually similar. And even though the technology was hugely valuable, the reality, I think, is that you'd need to be rolling out large areas of multiple buildings to really benefit from the time that was put in at the beginning, because in the end, the blocks are sitting there. They were both built with different methods. They required different energy, but there was way great value in the MMC, but ultimately the management of the other factors in terms of momentum and scale gave a different pathway to the way they arrived. So on the engineering side, this was a project which is just taken to planning stage, but it was all about the engineering, and it was to do with the fire engineering with MSA, who had inherent knowledge in the building, and then the client knew about the building. So if we talk about the previous speakers, when they talked about coming back to a building 20 years later, so this building, Jervis Centre, they wanted to look at taking away the car parking and going above it and seeing, could you represent a building in the city? And I had worked on the Cleary's building, and the issue here was if you wanted to appear above the skyline, you had to appear with quality. So in the sort of the context of that, the facade was a key factor in how the building would present. So before we could get to looking at the facade or the concept, the fire engineering was critical, and the existing staircases all had to be assessed and calculated to look at the existing occupancy to see how we would get from the new staircase on the top of the facade here, how they would all find their way out. And so a lot of time went into fire engineering in parallel then with the composition of the facade, and then Tess, who are a European facade consultant, came on board, Tom Gray, and again, deciding how we would control the facade to get the presentation of the materials in terms of a qualitative way. There was a lot of discussion about how you could get the plan to present equally, albeit that the facades were not symmetrical, but to get the top to sit symmetrically. So we looked at this idea of the floating form, which again was discussed previously. It's been done before in Antwerp. And the key parties here was if there wasn't design with the facade consultant, if there wasn't design with the fire consultant, there wouldn't be design energy coming back towards the architect. And the whole issue for me is that everyone is a designer. And engineering is design, facade is design, but the architect has to engage with the energy that is required from them and try and be careful not to waste their energy in the pursuit of, say, an idea which maybe is not fully deliverable. Here, with the ability of the modelling, we were able to look at a prefabricated structure that would sit on top of the building. The existing building had a Fresnel slab, and it had this section in the middle which you couldn't put load on, and that allowed us to generate the response for the atrium in the centre. So that sits over the rotunda in the Jervis Centre. And the building looks quite controlled, but there was a huge amount of engineering went into getting it to sit very simply on the top. Then, just very quickly, just under the heading of architecture, looked at the Bon Secours Hospital here, where, again, it's a large private hospital we're doing in Limerick, and it was very much about the clinical planning and the architectural form, which was part of the visionary issue. The client wanted the building to look like it was a place where you could get care, you would be treated at a different level. It's a private hospital, And the form of the front building with the curve was about the embrace and to bring in people for the daycare in the front, and the longer stay clinical spaces are at the back with the patient pathways. Again, a lot of kind of clinical planning, architectural planning, but the facade sits outside as quite a simple response. You're looking to get the terracotta panels, and then the rhythm, which is what I was talking about earlier in terms of, say, how architecture and the materials, it's like this, like music sometimes, like an orchestra, like the glass expands and contracts in terms of someone's idea of a visual rhythm, but the technical details are quite similar to the various buildings. We're always dealing with the same issue of fire at a floor. We're always dealing with the same issues of ventilation. We're always dealing with the same thermal issues. And the modeling is there now, though, and the 3D modeling is there. We've a lot more ability to look into how buildings will be assembled, and it gives a lot more order and control of order within the materials. The mock-ups were done in the building here, but ultimately the tone here was to get the terracotta building sitting to the front with the aluminium panels to the rear. But it was quite interesting, did you get the tonal match of a single kind of uniform architectural expression, and yet the form and the technology behind the two buildings are very similar. So I'm just looking at my time here now, guys, sorry. So in terms of management momentum, I wanted to talk a little bit about Park Gate Street. So this building, I've been working on it for 5 years, and one of the key players in the design team has actually been John Paul since they came on board, because trying to deliver the building becomes the issue, trying to have the ability, because architects, for all we might be able to look at and all of the design, if you can't build it, then you can't actually create the idea, make it into a reality. So we would have looked a lot at the precasting. We again would have collaborated with Glenn Howells on the project, and the original concept was for the double order to come in through the building to represent the scale that was being looked for with the city. But ultimately, BDA worked in this project with us, and Coleman, who was there earlier, and a lot of work went into how you would get the panels, not just to get the visual, but how you could get them to be assembled, how you could get this building to climb and to be affordable in terms of time. And the process of managing the project became a very difficult issue between Chartered Land and Lafferty's to manage time, and then John Paul coming on board, all the time trying to, as a team, keep the design as being a current relevant issue, not allowing the building to be disassembled by these challenges. But one of the issues that we looked at in the mock-ups was how we could change the way in which the facade was assembled. But this is a key slide here, which was that it was the contracts manager for John Paul who picked up on a point that we had slightly over-designed the facade. So we had way too many fire barriers in the facade, and we only had to fire barrier within the compartments. And he had built a building and brought that knowledge with him. And that's part of what I'm trying to get us all to see, is that we need to share more. We need to get the knowledge between us so that we can build better teams, more sustainable teams in terms of how we move forward, because these buildings are all quite similar. We're making space. We're not really doing new ways of building in the 20, 30 years I've been involved in the industry. But that knowledge is key. So here, the full mock-ups have been done. All of the studies have been made on the building, and as I said, it's going to be terrific. But I'm hoping that it can find its way through the issue of finance, which is this word about sustainability. Sustainability, which is this project here I've just put up, which is just finished now, which is another precast building with Techcrete again, and Gunlennon put a lot of work into this building in terms of they took control of coordinating the aluminium facades and of all the detailing, but Techcrete were doing their elements. But the knowledge from the panelling here was crossing over previously to Park Gate Street, even though one building is not finished yet. And this office building in Glencar is finished. It sits beside Facebook there, opposite the RDS. But with it as a building, again, a lot of technical knowledge and detail coming through from Porrick and Paul and Gunlennon, and from all the team in Techcrete. And again, you'll have heard the previous speaker, Thomas, with AHMM, talking about similar issues in the buildings he showed. And so I've just got these slides were there, all the work was done to put the building together, and it sits in its place. It's a hugely successful piece of city. And the little anecdote here is that Paul Mitchell from Mission McDonald said to Tony at the time that I'd never have given you that facade, yeah? And the reality here was that the planners, when Mary Conway was in the meetings with Tony on this, he said that if you'll do this, I'll give you this permission. And so the look and feel and the quality of the facade was central to getting the initial planning permission, but then to deliver the building required all this engagement from all these other highly experienced designers, from Techrete at Gun Lennon and Walls would have built the building. But the situation now in terms of sustainability, it's just won a whole series of awards. It has all of the credentials you might have, but it's not yet tenanted. So the question still sits, as was talked about by the panel earlier, we still have to get people to be in these buildings. Yeah? So just in a short conclusion at the end, I want to just talk about a little personal project. So, because this issue of team and needing additional energy when you're a creative person is everywhere. Yeah? You always need the support of your peers, you need the learnings, you need the energy, you need, as I said, teams, technology, engineering, architecture, management, sustainability. And so this was a little structure that we put up in IMA, and it was up there, it was supposed to go up for a week, but this was a 9-week project from when it was first asked about to when it arrived and it was sitting for the exhibition in October, just October of 22. But the initial concept was, well, we wanted to celebrate sustainability and place and space. And so this was about, well, what is space and what are we doing? And this is a facade conference. And so you're either inside a space looking out or you're outside a space looking in. And how much is enough space and what is sustainable? And we're trying to think about what is sustainable for our own energy and what is sustainable in the buildings. But this wouldn't have been possible without initially Lioncore, who sponsored the piece with IMA. And then IMA, they talked to us, and then we had a meeting every Friday, and each Friday you were just trying to find the no point. Where is the no so I can turn it into a yes? And then MJ Duncan's got on board, and a young fella, Sean, built a mock-up, but none of that would have been possible without us getting the calculations done by Barrett Mahoney, because if they didn't say that it would stand there and not fall and kill somebody in a windstorm, the project would have stopped. So engineering was key, the lighting design with Willie Duggan was key, the money was key, the client was key, and the momentum of each week, keeping it going, was all key to manage time. And so just as a last moment then, I just want to finish on this. So in terms of connections and relationships, so I come from a father who's an architect. He's 91. He's not great at the moment, but this is our family home, and it was built, it was just finished just before I was born. And when he built this building in 1963, there were no building regulations. There were no planning regulations. He went into Wicklow County Council and they said, well, you're an architect, you can do what you like, yeah? And that is not the world we now live in, right? So this building has a single glazed, untoughened glass, yeah? I drove my little toy truck through the window twice as a kid, yes? So I did. I had my 50th birthday there, which these photographs are from. That there is from the building, that's from 7 years ago. But the photograph there is me sitting beside my father, and he has always been my energy. And I just think that with everything we do, we have to be respectful of technology. We have to mind the money, because the money doesn't care about what we care about. The money wants its return. But we need facade excellence, because the places we wrap ourselves in, the clothes we put on ourselves, it's really important, yeah? And how you feel when you put it on and how you look when you have it on. So I hope I haven't tried to say too much today, but it's just very, very important that we remember that we're wrapping ourselves up every time we build a building. So wrap up warm. Thank you very much.
Thank you very much, Rory. That was really beautifully put, because we build buildings with other people, we're building it for other people, we're building it for ourselves, and you illustrated that so well. An old client that I worked with used to always say, buildings take on the characteristics of the people that work on them, and you always had the teams around in everything you presented. Thank you so much. Really enjoyable presentation. I'm sorry I can't ask you any questions.
That's okay.
Because we're running out of time.
That's good, thank you.
Our next speaker was meant to be Patrick Field. Unfortunately, he can't be with us. And I'm really delighted that Patrice McVeigh has agreed to stand in for him. She's already made a huge improvement in retitling the presentation. It's now called Facades and Relationship to Environmental Comfort. Patrice.
Yes, I am not Patrick Field, in case anyone's confused, but I hope that doesn't matter. So I'm here today to talk about how the relationship with facades really is important to environmental comfort within buildings, and how important that actually is in terms of building design. In order to do that, we're going to focus on a case study from O'Connor Sutton Cronin, which is One Balls Bridge. So it's a recent project that we are working on in terms of design. And the push for this project is to be as sustainable as possible. So in designing One Balls Bridge, we were hoping to achieve the highest levels of sustainability. That includes, from an environmental, a health and well-being perspective, energy efficiency, and down to material selection as well. So just to give you a bit of background on the project, the overarching sustainable principles is that we want zero fossil fuels in line with all the current climate targets. To get our emissions down, reduced by at least 50% by 2030, and we are going with zero fossil fuels. We're also trying to achieve zero emissions from transport on site, so all car parking will be facilitated to be e-charge with e-charge cycle spaces, everything like that. Biodiversity has become a big issue recently, with new measures coming into place where we're going to have to show an improvement in our biodiversity net gain. So biodiversity is very important on this project. In terms of sustainable materials, we have targets that we want to hit at least 90% of all materials being sustainable. That means that the majority of materials we want to have EPDs for, we want to have a certain element of recycled content, and materials that have been reused where possible. We also want to consider this as being potentially one of the healthiest buildings to occupy. So good internal conditions for indoor air quality, for thermal comfort, for daylight, all of that is a big focus on the project, and then 100% renewable as well. In terms of certifications, I'm sure you are pretty familiar with all the sustainability certifications out there, but just to touch on it, the project will be targeting LEED Platinum. LEED, for anyone that isn't familiar with it, is to do with the environmental aspects of the building itself. So how energy efficient it is, how much water conservation has been considered, and how sustainable the materials are essentially. In terms of WELL, we'll be targeting WELL Platinum. WELL differs from LEED, where it's about the occupant of the building at the end, just so it's about how of a healthy environment there is when the occupant actually occupies the building. We're also looking at EU taxonomy, which has come in at EU level. So if you're familiar with that, if you're trying to secure green finance, you need to show that you're EU taxonomy aligned at this point in stage. In terms of wired score, we're targeting wired score platinum, so that's down to the building connectivity, all incorporating the sustainability of the building. And again, there's another certification, active score, which will also be achieving platinum there. So just to give a bit of idea of the energy and carbon emission targets for the development. So you'll be hopefully familiar with the IEA's 2030 climate challenge targets. This is where we need to reduce both our operational carbon emissions and embodied carbon emissions to a certain level to achieve the climate challenge targets. So in doing that, to get our operational carbon down, we are targeting a BER of A1. And then from an embodied carbon perspective, we're hoping to achieve approximately 450 kilograms of CO2 per metre squared. In terms of embodied carbon, that is the carbon released from the materials that are used to build the building. So whilst the focus has always been in reducing energy-related carbon emissions, the focus is now moving to embodied carbon. The carbon emissions from materials is really contributing at this point. And then in terms of health and well-being, the facade element is actually very important. So Rory made reference to Glencar House there. We were currently given tours to agents in Glencar House last week from a sustainability perspective. The daylight that you're seeing in the floor plate into Glencar House is amazing, and that was all down to how that facade was put together as well. A big driver here on Ballsbridge was optimising the daylight into the floor plates, ensuring acoustics is going to be very important, and then ensuring that the thermal comfort and everything is very much considered. Apart from those certifications, we also have our building regulations. So in terms of considering the facade, we have to apply with the Part L requirements, which are our U values, and we also have to consider overheating, where we're related to TM52. So in terms of considering the facade, all of those elements have to be considered. So just to see, this is the Ballsbridge design. From an architectural perspective, the shape was very much important, as well as the balconies. So given the large floor plate, we had to do a lot of work in ensuring that daylight was maximised into the building. The overheating aspect as well, we had to balance the glazing with the solid panels, and then we were able to use the balconies for a natural shading element. We had to develop many iterations of our energy model to do this. So this is our IES energy model, and we went through a number of iterations with Mahoney Architects just to ensure that we were balancing optimum daylight with our solar gain. We didn't want to be overheating, and then we applied many iterations of shading to make sure that everything was compliant from a facade perspective. Once the facade was set, that allowed us then to move on to our M&E selection, which is what this is about. It's very important to have the facade pinned down, which will then relate back to how we can work with our M&E. So the typical office will install fan coil units, and what we did was we went through our other office developments to check how that system was working, and did all the fan coil units operate throughout the year. One of the particular buildings was the Central Bank of Ireland, and what we discovered when we went back to test there and look at the analysis, a lot of the central fan coil units were not required, so they were never needed to be turned on for heating. So this got us thinking that, do we actually need the fan coil unit system? So for anyone who's not familiar with the fan coil unit system, a fan coil unit is typically in the ceiling. Warm air is provided in winter for heating, cool air is provided in summer for cooling, essentially. What we wanted to do was see, could we move away from that? So at this point in time, we're investigating displacement ventilation. Displacement ventilation differs where there is perimeter systems providing air to the floor plates. One of the conditions when we were looking at the design was COVID. So the client was very, very particular about ensuring that air was not recirculated. So with a fan coil unit system, there is some element of recirculation in order to maintain heating. What the displacement ventilation allowed was a full fresh air system. So we removed the issue with recirculated air from a COVID perspective. What this meant was we had to go and test if this would work, essentially. So there was a testing centre set up in Germany to understand how this displacement ventilation would work, and would we be able to maintain temperatures that are required for thermal comfort. So that was the mock-up. And if I go to the next slide, this was the system in Germany. You'll see the grey wall to the side, that's actually glazed. And we also ensured that we tested the system for future climate change. So that grey wall at the side was 37 degrees, essentially, to account for future climate change, to make sure that we are compliant from that side. So you'll see, I hope these videos will play now. This is the first one is an office with a perimeter vent where the smoke is being used to show the air movement. So it moves from one side of the room to the other. which showed that the temperature then could be maintained at 23 degrees across that floor plate in the meeting room. And then the second video is more of an open plan office scenario where we've got the trench on the right-hand side, and then we've got a couple of air diffusers on the floor, which allow for a bigger open plan area to maintain that 23 degrees temperature. So all in all, I suppose what we're trying to show here is that if it wasn't for the importance of all of the work that was done on the facade at the beginning, which allowed us to maximize daylight, we're able to reduce the requirement for cooling because of the facade that we've installed with all the shading elements. It allowed us to push the boundaries on the M&E system and go for the displacement ventilation option, which removes all the requirements for the fan coil units on the ceiling. So you've reduced the amount of M&E equipment that's needed, which in return has reduced our embodied carbon from an M&E perspective. I think if we compare it to a typical M&E development of fan coil units, we've saved about 13% in embodied carbon by going down the displacement ventilation route. And it brings us back then to the whole focus, which was reducing embodied carbon in the first place. So I think that's the end of the presentation. It just is short and simple there.
Thank you. Thank you so much for that. And it's good to see that these displacement systems with fresh air are actually working, are really effective. Thank you. Thank you so much. We'll move swiftly on to Allan Gibson. Allan's going to talk to us about laminated glass.
Okay, so welcome to this presentation from Cleary. And what I wanted to do is just go through something a little bit more morbid. I know everyone's been talking about embodied carbon, sustainability, circularity. I'm going to talk about transparent armor for man-made threats. Now, what I mean there is like ballistics, blast, forced entry, those sorts of things. So this presentation will go through many different aspects. But for those of you that don't know me, I'm Allan Gibson. I work for the Advanced Interlayer Solutions division of Cleary. We are a specialist manufacturer of interlayers for laminated safety glass. And I've been involved in the specification of specialist products for the construction industry for maybe 25 years now. And I'm very fortunate to be working with a great company now. And now this presentation is really, it's been brought to you by Cleary, and underlines their commitment to the many different changes that are going through the glass industry and the construction industry. And that's through leadership and research and development. So, moving on, a little bit about Cleary, then I'll go through some of the threats related to the security aspects of facade and the buildings. And I suppose you could resemble it to sustainability, because at the end of the day, it's all about longevity. It's all about making sure that products are going to be fit for purpose, and those products are there to serve a purpose. The particular laminated glass that we'll be talking about will also go into some research and development at the end of the presentation. And there we'll be looking at how we can use the coupling effect of an interlayer in a laminated glass situation to reduce embodied carbon by using less glass. So, the Cleary's Advanced Interlayer business we're a leading global specialist of manufacturing interlayers for laminated safety glass. And those applications could be architectural, automotive, but also the marine industries. And this is served by a global presence, a network able to supply and support our customers worldwide with 7 manufacturing sites, 2 research and development laboratories, 18 sales and customer service positions all over the world. And this provides a local service globally. So it's quite a devastating video, this. Man-made threats, unfortunately, are part of our modern-day society, mostly through the voluntary action of a person or a group of persons, but sometimes by accident. as witnessed by people in Beirut in the not too distant past. So it's this type of situation where it was actually the annealed glass that caused most of the fatalities and injuries in this particular situation. Security hazards from man-made threats cover three main areas: forced entry or exit, firearm attack, and explosion. So when we're looking at forced entry, especially now where you see a lot of protests in our inner cities, our urban areas, it could be robbery, it could be theft of property, the riots, the terrorism protests and so on, particularly around high urban areas, but also those areas of sensitive nature. There could be public buildings, could be police headquarters, or even places like embassies and things like that. Which then goes on to firearm attacks. So firearm attacks is a little bit more sinister, tends to be more planned, and they tend to be more around those governmental buildings. But actually, as people become a lot more VIPs in the world today, you'll find that residential properties are also under risk, and also the automotive industry is another big player of this particular market. Now, explosions are very similar to firearms attack, where they do tend to be around those very secure, sensitive buildings like the embassies, governmental buildings, areas of high risk, but also transportation. So in our inner cities, where you have the metro or you have the subway or whatever, those will be very high prone to target from those people that want to cause harm or make a stage for themselves for political gain. So when we're looking at architecture, as architects, we're using a lot more glass. Because of sustainability, we're using less frames. And as a result of that, it makes it very difficult to have a glass solution that's going to provide a solution against these three areas. And it's not just the glass itself, it's not just the frame, but how that frame is anchored to the building that can also have a huge big impact on the performance of that. So with the increase of light, transparency, we're getting a lot more challenges with providing solutions for forced entry, for ballistics and blast within our buildings. Now, the threat of security and the need for this mitigation is a growing requirement, especially in our inner cities. You see a lot of mixed-use buildings where maybe residential on the top, you'll have these beautiful shopping facilities, and of course these could be prone to attacks from forced entry in particular, but also if they're located next to a subway or a metro or a bus station or a train station, or next to a governmental building, they could also be of a similar risk. And that's why we need codes, we need standards to be able to help us to fully understand the expectation of this glass and how it needs to perform. And if you look at the EU and the US, you'll see that there's some very, very strong classifications. Some are glass only, some are system tests. And I'll touch on that in a little bit later. But just as an overview, we give them classifications. So this is the EN 356. It's a ball drop test. Just to make you aware, some of these slides are from a very extensive workshop that we have specific to this topic. And obviously, they only give me 15 minutes, so I'm very limited on time, so I'm trying to squeeze and squash as much information into the limited amount of slides that I have available. But we can organize this by teams or in person. We can go into in a lot of detail. So anyway, moving on. So EN 356 is a hard body impact test. It's a steel ball that's dropped by height, and depending on how high that height is, would determine as to what sort of classification. And the classification, at the end of the day, a laminated glass panel must not tear. It must not rupture. The steel ball must not fall through the glass structure. So this is a hard body impact test in 356 on the left-hand side, P1A to P5A. Now, a little bit higher security is when they introduce an axe to this glass surface. And this will give a classification of P6B to P8B. So first of all, you have the hard body impact with a steel ball, and then you have an axe test, a physical axe test, where they're trying to make an opening within the glass. And if we then put this onto the European test, then you can see the resistance there with the RC1 to RC6 classification, and similarly, you'll have the EN 356 standard next to that. Now, if we put this into a generalization, there is a new test certification that's been coming out of the BRE, the British Research Institute, and it's an LPS classification. And the LPS classification is specifically targeted towards the higher level of security. And we work also in the Middle East, and the LPS classification is also becoming quite popular there. So it was very important for us as a market leader to lead the way with classification in this particular area. And it was something that involves many different types of varieties of tools. And you'll see there that you've got the classification of A to H, and that determines the level of security. But you'll notice that some of these have a single balaclava, and some of them have two balaclavas. That means a one-person attack or a two-person attack. Now, we were able to achieve, here you have a list of all the different types of tools. They start with hand tools, these types of things that can easily be found in any robber's backpack, but it's not something I carry around. But here you've got so axes, you've got claw hammers, pickaxes, and if you go into classification C, you see as you go up, the tools get stronger and heavier. D, you've got lump hammers and really sledge axes that are used by the fire brigade. And then you go into electrical tools. Now, normally, in order to achieve something higher, sort of E, F, G, and H, you need to have something else within a laminated glass panel, like metal carbide or something of that nature. Now, we were very fortunate, very, very pleased with the results that we got. Because imagine, glass, it's fragile, right? And then we put an interlayer in between, we make it laminated glass, and as a result of that, it's able to withstand so many of these tools over time. This is time, 1, 3, 5, 10, 15, 20 minutes, and this is the attack using the various different things. So you see the old SR1, SR2, SR3, and SR4 classification. And using some variety of different constructions, we're able to achieve D, which is the top level there, for 5 minutes without penetration. And the penetration could be a small rectangle, or it could be a circle, or it could be a body size like an oval. It's, you can see some of the pictures there. It's horrible, absolutely horrible. You've got beautiful laminated panels of glass, okay, transported to site, and then you've got some hooligans really ripping the hell out of this glass, trying to break through. It's demoralizing, so unfortunate. But anyway, we're very pleased with the results that we've got, and this will feature within our security brochure very, very soon. Next thing I want to show you is another product that we have. This can go into ballistic. Like I said, I'm flitting through different slides of the presentation here, but it's very important because when we look at ballistics, then it's all very well stopping the bullets, but if you're on the safe side, you want to make sure that you've not got all that dust and all that spool and all that debris flying in your face if you're on the other bow. So we produce another product called CPAD or Spool Shield, and this prevents all that debris from flying in. Another thing I want to show you is this. So this is an arena test in Spade Adam, and it's a facade, a bolt-fixed facade, 4-point fixed. And what we want to do is really show you an arena test. This is a real live explosion, and you saw just before the explosion, you've got all these different panels on a facade. And what I wanted to just explain is that when you have a blast attack, you have two shock waves. You have a positive blast and you have a negative phase. Now, the positive phase, you can see you've got the convexed and the concaved different structures. And this is during the blast process. And at the end, you can see all the panels that have been that have actually left their fixation. And then the next day, when we went back, even more panels had dislodged and fallen to the ground. And this is an important factor because quite often it's the following day when the emergency services are doing all their recovery, trying to find missing people within the blast. So the last thing you want is for these huge big panels of glass to be falling from their fixation onto the people that are trying to save lives. So it's very important to understand the full phase of this. But like I say, we can go into this in so much more detail if you pick up the phone and give me a call. Okay, so how do we do all this? Laminated glass. These are the three different breakage patterns. Annealed glass, very sharp shards of glass. It can cause injury and cut. And then you have fully tempered glass, which is also classified as a safe glass, safety glass. But actually, if you've got these big clumps of particulate falling from height, then they can still cause damage. And then we have laminated glass, which is what I do. We laminate glass with a PVB film or a Sentry glass film. It's then called laminated safety glass. And these can be developed in a variety of different construction types to meet all the different types of risk that I mentioned a little bit earlier. Okay, very, very quickly. We have very excited, we have a brand new product coming out in a couple of weeks called ES Pro. This is a stiff PVB used for structural interlayers. And this is where we can add a little bit more onto this embodied carbon bit, because the beautiful thing is, and if we compare this with Sentry glass, which most people are very familiar with from a structural interlayer perspective, it means now that we have a clear PVB that's stiff, so it has mechanical properties as a structural interlayer. And as a result of that, it means then we have modulus data and we have deflection qualities very, very similar to those deflection qualities that we normally associate with our very popular product, the Sentry glass. We can go into this, thank you very much, we can go into this a little bit more detail. You see all the familiarity with the slides and so on, with the stress, the deflection and so on. And when we put this through the 4-point bend test, you can see that the actual performance is far, far in excess of our standard ES or stiff PVB. So 1.5 hours, 100 newtons, you can see that it still performs extremely well in a worst case scenario. But most important, the reason why we are who we are is because we supply the architectural industry where clarity is key and low iron glass is often used. And here we have something now that's crystal clear, like our ultra clear PVB, high adhesion, great coupling, and just as importantly, open edge retention. So if these glass edges are in an open area, especially in a high humidity area like Dublin on the coast, it means that you're not going to get the moisture ingress and the risk of delamination at a later stage. So that's all I have to say. Thank you very much for your time.
Thank you, Allan. Very clear indeed. Thank you. We move swiftly on. Our next speaker is Hugh Whiriskey. Did I say that right?
Close, yeah, it's good.
Okay. Talking to us about fire again, I believe.
Correct. Yeah.
Okay, over to you.
Thank you. So the idea with today's presentation is to give everyone an idea, I suppose, about who I am, but also a little bit about Partel. So my name is Hugh Whiriskey. I'm an engineer by trade, technical director at Partel. Partel are an Irish company. We are established in Galway, head offices in Galway, huge stocks and available products there, but we're active as a home market in the UK. We also distribute to a number of European countries, Canada and North America generally. We are founded by architects and engineers, and that's been really important for us. That's our ethos. It comes through from that, and we feel that we benefit from understanding the projects and the problems that you encounter on a day-to-day basis. We're extremely active in building physics, and that's a huge part of it. So understanding how facades work, where the issues might be, and where we can be a part of a system that introduces some safety. I suppose overall we're known as a building envelope protection company. We in-house have a great deal of technical expertise. That's architects, engineers, designers, thermal bridging, WUFI analysis, U-values, on-site support, and we've got some extremely interesting R&D projects, and we'll touch on this a little during the presentation, but a lot of people have talked about the longevity and durability of materials, and that's huge for us. So compliance is one thing, and durability is another. So it's quite easy to have compliant products, but having products that are genuinely long-term, that's a little bit harder. So we'll talk a little bit about testing and standards for our industry. Quite brief, as you look, I know we're dealing with a knowledgeable bunch here. So broadly, when we talk about membranes, we're talking about how they perform in a fire, not really what they're offering you as a resistance. So what does the membrane do in the event of a fire? So we've got class A through F, and we've got the smoke emission and the production of flaming droplets. And I thought it might be useful to have a short video on that and to take a look at what a Class E membrane is compared to a Class B. And we should, hopefully the videos are working well, yeah. So we see what happens when a Class E membrane is ignited. So this is droplets, quick to ignite, and will actively contribute to the fire. So there's real reasons why people would consider using Class B products as a default, not using a Class E. We've had occurrences where people have changed from Class E to Class B on a general level because of on-site construction issues. So there's a lot of products that create sparks during construction. So Class B could be a good default. In Class B, you don't have a great deal of sacrifices in terms of weather performance, adhesion, compatibility. And in Class A, it's a little bit different. It's harder to be non-combustible, and there are ultimately some sacrifices that we need. That video on the Class A isn't broken, it is on, it's reaching about 600 degrees and will remain the same with that flame on it. So looking at application where our products fit, so when you talk about membranes, really we're talking about all building types. So the single family or the one-off dwelling to the mid-rise and high-rise. It applies to roof, wall, ceiling, floors, to commercial, residential, and we're quite agnostic with materials, insulation. We focus on our products and we try to have an overall, I suppose, a view on the safety of the system. So we will work with all insulation types. In terms of how our products sit with compliance, maybe the best way to look at it is the fire safety engineering aspect and your path towards compliance. So we're always following the construction regulations and the classifications, but I suppose what we're seeing is people funneling into that in two different ways, so be it prescriptive or analytical. So in the prescriptive products, that's where people are looking to retrofit buildings and they'll stick with the Class A system or non-combustible. In that case, you don't have a tested wall or you really can't. So you will typically choose Class A vapor control, Class A breathable membranes. If we look at the analytical, and this is going to be an incredibly busy area over the next number of years, it's where people are building fire tests and including membranes. So for us, most of our membranes will fit in a tested fire system. Not everyone knows that, but it means that our membranes have a very, very small contribution to fire anyway. So when you test a full wall, it's usually possible to use a Class E or Class B or Class A membrane and still end up in a similar result if it's a tested wall system. Whereas we need to remain non-combustible, it's prescriptive, and we stick with Class A. So looking at how our products line up, you'll see kind of three sections. So we have a complete Class A system. That's two breather membranes on the outside. I'll talk a little about those in a moment. And a vapor control layer for the interior or exterior, depending on its use. There's a complete Class B system and a whole range of adhesives that support that installation, connections, details, things like that. That is just one part of the Partel range. We do a lot of different things. But we also support everything with clear system warranties. So we'll do the WUFI analysis, we'll do the specification, and we'll support it with a 10, 15, or 20-year warranty. I'll look first at the isoprene plus A2 membrane. That's the one that we saw the flame on a few moments ago. It's a very high SD, really tough, durable product. It's a UKCA, CE marked as you'd expect, BBA in the next couple of weeks. So, but for us, maybe the area that's different, or the one that I want to mention or talk about, is how we approach these membranes. So, unusual to talk about a tape that much when we're looking at membranes, but the tape, as you'll see there, is tested as part of the system. That's really important. So when you're considering a membrane and you choose an A1 membrane or A2, you kind of have to ask, how has it been fixed? How has it been joined? And if the tape or the joining material isn't part of that fire test, it's not going to be compliant. So this tape is, or the system is overall A2 when 10% of the system is tape. That's an important part for us. And if we go a little further, we look at our free-hanging solutions. So this is the class A1, A2, and the B products, it's the same situation. The tape is part of the overall system. So really important for us. I want to talk a little bit about durability. And I've noticed the theme throughout the day where people will focus on that, so longevity of materials. So every product you see in the market is compliant, but for us, we're really focused on monolithic technology. Monolithic technology is common in most of our products, and here it's a reason why we would prefer the A2 membrane over the A1 membrane. So people might be tempted to think A1 is better, it's better for fire, but really there's compromises to go from A2 to A1. So the A2 membrane has a 5,000-hour UV test, so does the Class B product. Ultimately, it means in commercial projects, when we know that those buildings are going to be exposed for significant periods of time, our durability of the membrane isn't affected. So these kind of products are ultimately 5, 10, 15 times longer than cheaper products. So, like I say, quite easy to be compliant, but it's important to ask the questions about durability. The next product I want to take a look at is something a little bit different to the market. It looks similar to other products, but it is different. So it's completely self-adhered, breathable, monolithic product. It's a 6-layer product. So on the top, it's got a UV-stable waterproof protection layer. In the next layer is a monolithic layer. We'll talk about that in a moment. Protective PP film, additional reinforcement, adhesive, and an easy-to-use split-release liner. There's 2 key layers in that. So the first is the monolithic layer. For us, that's an extremely well-protected layer, both from the layer on the top, but really it's about its UV protection. So it's good for 9 months of use in the UK or Ireland, can be exposed, uncovered, and that's not common. So for us, it's kind of a standard product. But the other one is the adhesive. So our particular adhesive in this product is a little bit different. It's completely water resistant. Itself is completely UV resistant. So it's really worth getting into the weeds a little bit when you consider those products. They're really, really different. So an adhesive that doesn't age and a material that doesn't age. That's critical for the durability of the building. I want to look a little bit about the specifications and building physics and how we approach that. So again, going back to our background, architects and engineers, we're more than happy to consult, understand, know, and advise on robust ceiling solutions, both for airtightness, breathability, and window connections. We talk about and use WFI a great deal to analyze the building, the facades, in terms of condensation. So there's 2 current paths that we can use for that. That's the Glaser method. Glaser is quite a weak, outdated 1960s method that doesn't account for rain, hygroscopic materials, failures in airtightness. So really you can't simulate a facade using a Glaser method. So products like WFI or Delphin are critical. And on the left, or on your right, you see the build-up of the layers that we've chosen in this current and live project. They're using the Exoper Mono 250 on a cement board, and also the Isoprene Plus FR on the inside. And what we can do with WFI is assess and analyze each layer, what's happening with it over time, how much moisture is in it. But probably more interesting is this video taken from the analysis, and it shows at all times, over a period of time that we choose, where the risks are, and we can easily make adjustments, make a recommendation to the specifier. If you move this layer here or switch to this product, you can really increase the safety of the overall layer. So just a little about some of the current projects. I guess we've found that we're a key supplier for the off-site construction industry. So here you see the Exoperm Monoduro 200, so free-hanging membrane being used with a Class E membrane on the inside. So they're part of a tested wall system with an off-site supplier. That's a long-running project in Limerick, multi-year with different, I suppose, different stages of the project. The product on the inside is worth kind of talking about, Isoprene Plus. It's an passive house tested airtight system, and maybe that's another speciality that we have. We're very good at the airtightness side of things. Our products are highly specialized and quite different to what's available on the market, and we're used to doing that on-site training, helping people get good results. I wanted to show this slide, and it shows the Exoperm Mono 250, our self-adhered product, and how that started to be used in off-site construction. What you see on these projects here is kind of their second stage or their second go with that. So as people start to put more value in these boxes built off-site, they used to wrap them in plastic, condensation can become an issue, but really as they put them together, instant water tightness is what's needed, so it needs to be complete. So they've opted to use much more expensive products, but it protects the interior, your gypsum, your plasterboard, molds, all that kind of thing. A little more local to here, Central Plaza, so we supplied the interior and exterior airtightness and weathertight systems for this one. It's a really cool building as an engineer, I love it. You don't always see steels like that, but it's quite a tricky one to manage to get the airtightness right as well. So we would have spent a good deal of time on site working on that one, dealing with those details. And yeah, a couple more photos from the hospital in Limerick. This is UHL, so we're involved in a few of the hospitals there, a good few different buildings. Again, you see the Exoperm Mono Duro. This is the free-hanging durable product. I'd say maybe the first person today finished early, back on time, so I don't know if there are questions now or not, probably. Fine, okay. But look, thanks everyone for the time, appreciate it.
Thank you. Thank you. The next speaker that's in your program is not actually going to present today, so that will not happen. We move to our final presentation of this session. It's on rain screen facades, and it's from David McMurtry. Good. Floor is yours.
Brilliant. Thank you. Good afternoon, everybody. My name's David McMurtry. I'm the National Sales Manager for Equitone here in Ireland, with about 24 years experience within that business, mainly based around roofing and cladding. So today we're going to have a wee quick look at who and what is Equitone, who are we, where are we from, the range, quick touch on the range and our fixing methods, and then we'll have a look at our sustainability journey, the durability and the flexibility of the product as well. So here are ETEX and here are Equitone. Equitone are part of the ETEX group. In Ireland here, we would have been known until 2020 as Tegral. We rebranded back then to give real focus on our brands so that everybody knew exactly what they were doing and give real focus on the industry. So very much ETEX as a group has an ethos for lightweight building solutions. So the fibre cement products fall very neatly into that range. Equitone then is a fibre cement rain screen facade material. It's installed really just as a finish panel on the ventilated rain screen system. Like all ventilated rain screens, you have open panel joints to aid ventilation, and the whole idea of the Equitone board is to give an attractive, flexible design option for the specifier. The benefits of the ventilated facade or the ventilated cavity, they get an evaporation and a stack effect, so any wind-driven rain that crosses through the open joints gets ventilated out by that stack effect, and any interstitial condensation or moisture exiting the building also condenses in that position, so there's no interstitial condensation. Very much ideal for traditional steel, timber, and modular construction, so it's a very flexible product, can be used in a wide range of building applications. The Equitone itself, what we manufacture the fibre cement material in a sustainable low energy process. A very, very durable product with a 50+ year life expectancy. We've had it in the market here in Ireland for over 30 years now in different brands. A very functional product, it's UV stable, it maintains its aesthetics for a long time, and it's a very flexible product when it comes to design choices. The choice really is up to the designer. There's a range of textures there, range of finishes, and really the finished look is up to the designer. It can be cut into different shapes, different patterns, and different orientations when it's installed. The range within the Equitone brand, we cover a lot of bases with our colours. So we have on the far side there, Equitone Pictura and Textura, which are flat painted products with a very, very UV stable finish on them to give real bright, you can get really bright, consistent colours across the facade. Then you're moving into the likes of the Linara product there, which is the opposite end, the very rough face, stone effect board, through colour on an unfinished fibre cement product. Tectiva has a very light line within it, again a through colour product. So again, you get a little bit of variation depending upon the orientation of the panel, so you can play with that when it's installed. The Natura is a high density air-cured product with a very smooth finish on it. It's a translucent finish upon it, so it allows the nature of the fibre cement to really show through. While the Linnea on the bottom side there is a strongly grooved panel, so it has a very deep rebate within it. So again, it gives real choice for the installer and real choice for the designer, on the orientation, whether it's put on horizontally, vertically, or even diagonally. So really, really nice product. So just a quick touch, and I appreciate I'm talking to a room full of experts, but just to have a quick look at the installation methods for the product. This slide actually shows the Rain Street concept quite well. So fixings are all colour matched to the board finish to provide a discreet but very attractive finish. There's two options really. It can be screw fixed back to timber, but more and more we're seeing it fixed back to aluminium rails with rivets. The rivet system that we offer is fully compatible with all the major rail systems out there, whether it's envelope or downer or arteries, So that gives real choice then for the designer and the installers of which rails that are being used. 2 fixed points only per panel. They allow the board to move, expand and contract with heat, and also they allow for the differentiation between the expansion of the aluminium against the fibre cement. Nice thing about the face fix is it can be easily combined with the secret fix system. So at lower levels you can use the secret fix system, and for whatever reason, whether it's weight or whether it's cost, the face fix can be used working up the building where the fixings can't be seen. And like all our systems here, it supports our own fire rating of the A1, S2, D0 fire rating. A2, S1, sorry. The mechanically secret fix system then typically needs an anchor on the back of the panel. So the panel's the bracket's mechanically fixed to the rear of the panel using an undercut anchor, either a Turgo system with a 12mm or on an 8mm an SFS system. Anchors are then secured onto that using those expanding plugs, and the panels then are effectively hung off a horizontal rail, which can be fixed either back to the structure of the building or again on an aluminium subframe. It's very important in these kind of cases that the boards are fabricated and the panels are fabricated off-site under controlled conditions, so there's no mistakes made and they're correctly cut before they arrive on site. So that's how it all goes together. Just to give you an idea of the different looks of the building, there's a wide range of colours and finishes in the board, as we've seen. So from an aesthetic point of view, you have this nice modular look on this project in Holland. Perforation is also possible with the boards, so the boards can be perforated fully to give nice design details, either at certain points in the facade or across the whole face of the facade. The Linnea, as I say, can be, the orientation of the board really, really affects the look of the board. So if you have vertical or indeed at the bottom, if that works, horizontal. So that gives a really nice effect. This is a project in Austria. It's a concert hall, and it's a really unique project with geometric shapes, rivet fixed back on the aluminium. So really nice, unique looking product. And then if you wish to get a bit of 3D effect into it, this is a project in Hong Kong, the Hong Kong Museum of Art. This was a refurbishment, and the main focus was to have that 3D effect as well as a low embodied carbon product, and that's where Equitone fitted the bill. Getting a bit more local, something a little bit different, again with Linnea. It's a public building down in Care, with Linnea installed both on the roof and on the facade, with a secret gutter there to give a nice faceted box kind of appearance. So again, just to touch on the standards and conformity and durability of the product, all the boards come with manufacturer warranty on the board, both on the structure and on the finish of the product. And that's grand, that's okay, us saying it's great, but it's also manufactured to the full ISO standards management systems for environment, health and safety, and also manufactured the AN 12467, which is the standard for fibre cement manufacture. All products are CE marked. All products come with an EPD. We're members of the Irish Green Building Council here in Ireland, and also of the MMC Ireland, the Modular Offsite Construction Organisation, and in the UK then with BBA approval there. So the products are very, very durable, very long lasting, and say with a 50 plus to 60 year life expectancy. We also are unique in Ireland in that we're members of the Cradle to Cradle Institute with the bronze certification, so we're unique worldwide. Actually, it's the only fibre cement facade manufacturer with that certification. On the fire side of things, as I say, all the products are A2S1D0 classified, so it's a non-combustible board with zero droplets, or very little droplets, zero droplets, and very low smoke propagation in the first 10 minutes of the fire. So scores very, very well on the fire classification front, and when combined with a correctly designed and installed facade with the correct fire barriers, you have a very, very secure system there in the event of fire. Just to touch on sustainability then, it's a big topic today, and rightly so, with 33% of water consumption worldwide, 40% of carbon emissions, and 50% of all extracted materials are the result of construction, with 35% of waste generated worldwide caused by us guys in construction. So it's important that we all work towards improving that, and at Equitone we're committed to reducing our impact on that water consumption, on emissions, and raw material consumption and generated waste. We're on the road to sustainability with a target of 2030, where we have firm commitments to reduce the harm that we do to our people and to the environment, with a zero harm product being the end result. To that end, we're working to reduce raw material use by 35%, increase on this journey to circularity, with 20% of our materials to be used to be fully recycled. And also, very importantly, we are introducing by 2030 in 80% of our markets in Europe a take-back service where we can actually take back products that have been installed previously in previous years and recycle them or reuse them and repurpose them into our systems. So just to touch briefly on what the Cradle to Cradle program is, we've joined the Cradle to Cradle Institute and have achieved the bronze certification. And this has really challenged us across our supply chain and the way that we work, to focus ourselves, to rethink the way we do things, to actually become eco-effectiveness and eco-effective and be positive as opposed to being just efficient. So what does that mean? It means we'll work on material health, no contaminations and no materials that cause harm. Product circularity, so whether it's repurposing or recycling the products or reusing them. Social fairness, so we're good to our people and good to our customers and good to the consumers. Locally then, water and soil stewardship, that we're not reusing, or that we're not putting water back into the environment or using potable water, and obviously clean air and climate protection. In practical terms then, what does that mean? Let's say our products or our raw materials are all checked for no contamination. Recyclable and reusable materials, we have absolutely no landfill within our factories. Everything in the two factories is completely reused and entered back into the process if there's any waste product. Also, we're committed to reducing our energy and water use. Any electricity that we buy in is from 100% renewable sources. We have a closed-loop water system, and we also generate our own electricity with solar farms and photovoltaic panels. and we're working locally here in our slate plant to install rainwater harvesting. So no potable water to be used in our system, and to as I say, absolutely reduce the absolute minimum our raw material and our environmental usage. Just to give you an idea now of where we sit today without these improvements, for facade materials, this is a comparison of the carbon dioxide use per square metre of facade material. At the very, very top there, you have traditional red brick with 97 kilos of carbon per square metre. And very down near the bottom there, you have, where is it now? You have the fibre cement material from Equitone with 6.99 kilos. So we really are at the minute a low CO2 impact business, and we're working very, very hard to improve that further. Just to show you one small example of this in action, of this circularity in action. This is a prototype house in Germany, which is a prototype using and testing as many recyclable and reused materials as possible. The facade is 90% recycled between the materials in the facade and also in the build-up behind it. It's a timber frame construction, and all the materials were taken from the clients' other sites for repurposing. The fibre cement panels shown here, the black panels at the top and in the middle, were originally installed in 2007 on another site. They were carefully removed, cleaned, and then reinstalled there. So that's our journey towards circularity, where the product can be reused simply, and there's another 50 years of effective service life in that product. So, in conclusion, hopefully we've shown we've got a durable product, we're working towards sustainability, and we have a very aesthetic, effective product. Thanks very much for your time and attention, and if there's anything else that we can help you with, we're here today, or you can get in touch with us at your leisure. Thank you very much.
Thank you very much, David. Just inside your time as well. And we are more or less back on schedule. We're going to take a coffee break now, and if we can come back as per program at 10 to 4, please, for the final session of today. Welcome back, and first of all, congratulations to all of you who are still here. You made it into the graveyard shift. Well done. Yeah. It's actually the best shift of the whole day, so well done. We have a presentation first, and then we're going to have a panel discussion on a fairly landmark Dublin project. But we start with a presentation from John Dobbin. He's a director at Shay, Cleary Architects, talking to us about architecture and character, no doubt.
Thank you very much. Yeah, I'm going to sort of not be very technical, and I thought it'd be interesting just to talk about architectural ideas, really, in relation to kind of two projects that we've recently worked on in the office. Primarily because I thought it would be interesting, and secondly because I thought that might help avoid my embarrassment or my embarrassing myself in front of a bunch of facade experts. We actually got the idea for talking about this for something I unearthed completely randomly recently, which was a lecture by this man ringed in red, much like today. His name is Reg Chandler. He was an associate and later a partner in Stevenson Gibney. This was their practice, which is now gone up on Bride Street. It's been replaced with a hotel, although the facade is staying. And Reg did this amazing discussion, or sort of lecture, I suppose, to students or something like that. It was called Dimensional Discipline. And I just thought, that's an incredible thing for a partner in a big architectural firm to talk about. It's not something that architects talk about much today, even though it's absolutely fundamental to absolutely everything that we do, of course. He was talking about this building, which is Agriculture House, amazing building at the time, finished in about 1974. And it's of interest to us in the practice, I suppose, because the practice redid all of its reception areas a very long time ago. This is a project that was finished in 1996, from which I hope you will either deduce that I was a very talented 13-year-old or that it was done by my partner Shay a very long time before I got involved in the practice. So this kind of establishes two ideas that I just wanted to very briefly talk about, and they're things that we in the practice are just totally obsessed about, that are totally fundamental to facades, whether they be unitized and so on, which is the grid and the unit, or the coordinate unit, as we sometimes call it in the office. And I just put this up because it works on a number of scales. This is my partner Shay's absolute favorite urban design project on a very major scale. It's the town of Montpazier, which is in southern France. And it just has that incredible idea of that coordinate unit, making on the right-hand side the ideal city plan, and then even over time as it gets fragmented, still having that amazing power that's instilled really by repetition and incident and contrast in architecture. And I have to sort of admit that I'm a total nerd about grids. This book sits over my right-hand shoulder in the office. And even though it's specifically about graphics, it's something that always kind of inspires me and our interest and obsession in grids, which is something that, you know, if you, at the very, very start of a project, is something that we're just constantly thinking about. We're thinking about the way in which grids influence buildings. We're thinking about the coordinate units, as we call them, or the unitized elements, as maybe some of you might refer to them. And we're thinking about the dimensionality of those from a very, very early stage in a project. It's something that has completely obsessed us for a very, very long time, whether that's at a very large scale or down to the scale of a kind of shop front or something like this. And I think it's fair to say that if you looked at some of the projects that the practice has been involved with over a very, very long time, you can start to see a demonstration of our absolute obsession with grids, whether it's done in a heavyweight material here as in precast, or whether it's done in lightweight and unitized systems like these ones. It's something that has been a recurring theme and something that really is a bit of an odd inspiration to us, whether that's in plan, in elevation, in section. It's always something that is incredibly important facet of every project that we work on from a very, very early stage. And I think that probably the granddaddy of all of those schemes that were based on coordinate units and grids is this still one of my favorite buildings of the practice, which is a simple staircase in glass that was added to a protected structure. Absolutely astonishingly small floor plan, not quite sure how we got away with that, but we built it anyway. And this was all based on the coordinate unit of the biggest glass sheet size that could be established at the time. I absolutely love that photograph because it's the minimalist contrast of the sort of expressionless piece of architecture next to this historic warehouse. And a lot of those ideas in many ways got translated into later projects by the practice. This, ironically, only about 150 yards away, the Alta Vetra Tower, which is a residential project. It was finished in 2008 and was one of the earliest things that I worked on a little bit in the practice, and was probably also one of the very earliest unitized systems that we worked on. It was one of the earliest unitized systems in the country. Here, completely determined by the 1200 grid, although there was one slightly bigger and slightly smaller, all serving that kind of idea of the architecture being generated in a way which gives a clear urban project, a clear urban form, which doesn't really give a huge amount away about what's inside it, apart from the kind of floor plate elements. And I think those kind of ideas about the kind of clear urban object building, which is totally generated by its parts, maybe reached its apotheosis recently in a building that we finished called the EXO building, which is not too far away from where we are here. And I think what was exciting about this project is that, like the Alta Vetra building, it's an office building, this particular one, as opposed to Alta Vetra, which is resi. But while it doesn't engage with its neighbours on either side, it also, in a strange kind of way, doesn't engage with the ground in the way that a normal building would. So it can be up above the level of the street for very good urban design reasons. And so by that sort of thinking, it becomes a very clear and pure structural expression held upon these three major core elements at the bottom, and then totally generated by the logic of its component unit, in this case the unitized facade element. Ooh, that's a bit freaky, so I'm going to jump by that. So this one in particular was a fairly standard office grid, 1500 by nearly 4 meters. This one made out in Spain, and all sort of made and fabricated in the service of making the simplest possible architectural expression to give a space that really is up in the air and gives these absolutely magnificent views over Dublin, held up off the ground, almost uniquely not engaging with the public realm, but engaging with it in a very specific way, in that people sort of walking to the concerts in the Point Depot next door use it to shelter and walk around underneath all of the time. It's a very unique sort of idea, and probably one that maybe only once in your career as an architect you might get the opportunity to work on a project like that, which is so, in a way, specially disengaged from everything else around it, and yet engages in a very sort of specific way with its public realm and its ground level. So the idea becomes a little bit different when you and I'm saying this in a slightly tongue-in-cheek way, when you move to the other kind of unit, which is the original unit of unitized facade, the humble brick. And here we have the same sort of idea, but generated in a completely different material. This is a low-rise, high-density project that we finished recently in the practice, and very, very high density, the same density as you get with a kind of apartment scheme. Never gets above 3 floors though, and is generated entirely around the idea, and I don't want to dazzle you with jargon here, but making the brickiest building we could possibly make, and ensuring that every decision that we made on this project was sort of generated and referenced back to the idea of the proportion of the brick. And I should say about this one that it's very, very simple series of traditionally built structures around a central community landscape, which really sort of forms the heart of the development. And I think really that the best clients in the universe are the clients who will let you make a building out of one material. Those are the best kind of clients, definitely. And this just gives you an overview of how it works. The density of this is very, very high. As I said, it's taking the place of things like apartment blocks that we don't seem to be able to build in a viable way in Ireland, and yet provides these really fantastic outdoor spaces and a really amazing quality of life on an own-door format, which in many ways is much more familiar to us in Ireland. Again, the nature of these spaces completely generated by that discipline and coordination of what we call the coordinating unit. In this case, it's the brick. Of course, this takes people, and it takes an awful lot of brain power to make it work sort of elegantly and effortlessly like this. So I have to call out my 2 colleagues on the left-hand side here, Carl Tobin from the second from the left, who did the heavy lifting on site, and my colleague to the front on the left-hand side here, Mark Halpin, who's known as Mark Brickdims Halpin in the office, who set the whole thing out with the kind of the rigor and the sort of discipline that working in brick construction always gives to an architect, and is so rewarding when the whole thing comes together at the end, because it kind of happens effortlessly, and you can work with people on site in a very sort of collaborative way to achieve something that's very carefully made. And of course, all of those ideas go into every single detail of the project, whether it be the metalworks finishes with harmonise with the colours of the brickworks, the 12 sample panels that we did with the client to sort of sign off things like brickwork colours and mortar, the way in which the precast top sections will coordinate with that and don't have any overhangs, which I'm still a little bit nervous about. But we really wanted that sort of, because the architectural form is very rectilinear and very geometric, we really wanted that material to tie into some ideas of Victorian garden walls that happened in the locale around it. And that was kind of our touch point for how the project material would come together, and the usual inevitable and interminable sort of sampling processes and benchmark processes that go on around that, working through really deep brick reveals, brick lintels, and all those ideas which work towards making the building a really singular expression of its coordinate unit. And of course, all of that really takes a huge amount of effort in terms of oversight and ensuring that you are getting throughout a project like that when it's traditionally done. And perhaps this will be the last traditionally made brick building that we do, who knows? But you really have to pay an immense amount of attention to it. So that means that I have to get into these tiny sort of spaces and make sure that the quality is okay. And that sort of reached a little bit of an impasse with the brickwork contractor, where that is me with the yard brush cleaning down the facade and trying to show them on an area that didn't quite work, that they needed to do a little bit better. So that's the madness of the architect, but sometimes it's what we need to do in order to get a product of real quality. And we like to think that the project really speaks for itself, I suppose. It's disciplined, it's ordered, and it's rigored. And it's an architecture that in many ways is generated by its material and also by the sort of key rigor of the architectural thinking around it. And if I was to leave you with one sort of idea about building, the most important one I think would be is that always get photographed on top of your building when you're finishing it having a martini. This is a very, very important idea. So there's really 2 projects that in a way bring towards you, I suppose, the architect's point of view about our obsession with grid systems and our thinking about the way that we should make buildings that are made out of their coordinate units in a very rigored and disciplined way from the earliest stages. And I think that that really is the answer to value engineering. Value engineering is not some idea you bring in at the end in order to make the building look like wallpaper. Value engineering really should be from the first time that you set pencil to paper. And you should be thinking about the way that the building is made so that nobody can value engineer it away from you. You've designed the most economical building in the most economic material you can. And just a very small coda for you. We're beginning now to think from this project about a lot of low-rise high-density projects. And these are ones that we've won recently in international competition in some cases, and that we're delivering in different parts of the country. And that is forcing us to sort of think about the coordinating unit not only being the material that the building is made out of, the brick or the unitized panels, say, for instance, in terms of making that kind of urban form and making that urban fabric. But of course, it's also the individual typology unit, and this is sort of extract from our Revit models of all different sort of versions of low-rise high-density typologies that we use in different cases and in different scenarios. And all which I hope brings us very neatly back to Montpazier and the idea of the ideal grid and the ideal dimension with its elements of sort of repetition but also incident. And the idea of the architect that even though you start with that beautifully ideal diagram, it doesn't always work out like that. But as my great architectural hero, Daniel Burnham, used to say, once the noble diagram is recorded, it's never forgotten. And we certainly hope not. Thank you very much indeed.
So we have a few minutes for a few questions while the stage gets set up for the panel discussion. You gave us some nuggets there. You said value engineering starts from the first step on the project. Maybe you can elaborate a bit more on that.
I think something that I worked in London for a long time, and one of the most interesting things about working there is when you hand over a project in design, it often goes to an executive firm, and sometimes that goes well and sometimes not so well. But always the objective of the executive firm from the client is to make the project as cheap and as simple as possible. And I think that's today our biggest enemy, because it makes architecture into wallpaper in many cases. And architecture is much more important than that, I think. So we as architects have a responsibility, I think, to, from the earliest stage, ensure that we're making the building the most logical way, so nobody can take it away from you. So I think that's one of the key themes that is most important at the moment.
But that means that you guys are thinking about how that building is going to be built. You're thinking about what materials you're using. You're bringing all this consideration from the earliest phase.
Yeah, and we're probably a bit unusual in that. But I think it's something that architects, having relinquished the kind of master builder role, we have to kind of grab back onto that, and we have to use things like BIM to help us grab back onto that, because in a sense we're the people who are best placed to control it, I think.
Interesting. Almost an engineering type of thinking rather than some of the sort of more artistic architecture type of thinking.
Absolutely.
Which is great to see. It's a good mix to have. How do you find that when you've put out jobs like this, does it end up being pushed and pulled? As you said, you worked in London and we got used to seeing our projects being pushed and pulled. Is that happening here with these kind of projects that you showed us?
It happens much less, but it is becoming a theme, which is, I think, very interesting. The EXO building, for instance, we were the design architects, and MCA, based in Dublin, were the executive firm, and they did a fabulous job, did a superb job. But I think it is becoming much more prevalent that approach of there being a separation between design and execution is becoming more normal here. And I think that's something that we try and fight, particularly because we're equally interested in design and execution, and I think we have to be.
And is your market at the moment mainly in Ireland? Do you work outside Ireland, or?
We work a very small bit in London, still trying to break in, so if you know anybody.
Okay. Okay. Certainly your architectural style will appeal to a lot of people, I think. It has an honesty to it, it has a basic kind of considered thinking from the very earlier stages, which a lot of people will find very appealing. So well done, and thank you so much again.
Thank you.
Okay, the final part of the day. I'm delighted that I will be moderating our last panel discussion this evening. And we have a really distinguished panel. I'll invite them onto the stage one at a time, and if you would kindly welcome them. Starting with Kevin Delaney, who's Senior Development Manager at Glenveagh. And Following him will be John Macken from O'Mahony Pike Architects. Albert Moran. Albert is from Murphy Facade. He is standing in for Neil Murphy, who unfortunately couldn't be with us today. Thank you, Albert, for standing in. We have David Cleary from Colin Construction, who is the project manager or package manager? Contracts manager. Contracts manager for Colin on this project. We have Ronnie Mills, who's managing director at Alucraft, and we have Stefan Trifonov, who you saw earlier talk to us about fire, who was also involved in this scheme. So Stefan, who's head of engineering at Schuco UK and Ireland. Please take a seat. I think you can just pass the microphone. So we thought we would do this panel discussion slightly different, because if we all just sit here and talk at you, you'll be bored and go out for a coffee. So we thought we would actually start by telling you a little bit about what happened here, why this project is relevant. We've been talking all day about collaboration, and so many people highlighted this as a key step in delivering a quality project, a quality building. And I think this project demonstrates it very well. So I think what we will do is we will give you a short presentation where the panel will describe what their contribution was and how they worked on this scheme. And that hopefully will give you some food for thought. We will expect questions from the floor in about 10-15 minutes. So we'll start maybe with you, Kevin. Just give us just the overview on your journey, because you're the initiator of this project.
Right. Yes, well, obviously, I joined Lendlease just after this project got planning permission.
You might hold the microphone.
Oh, sorry. Got planning permission. So at that point, we had the greater Castleford Business Park. So there was a hotel and an office building. It was a joint application, which Manny did for us. And then there was a wider scheme, which was a second application for a residential part of the site. We subsequently sold on that site. So clearly, at that stage, once we got planning on the hotel, we were approached by Whitbread to look at getting a lease on the hotel, which kicked off the project from our perspective. So we entered into a lease with them, and ultimately we started negotiations with Colin Construction to build the hotel. But because the two buildings were adjoined, the decision we had to make as a client was whether we would proceed with the office building on a speculative basis, because we had no, as it were, exit strategy for it. But we made the decision to go ahead because it seemed to be the best thing for the site. And then we also entered negotiations with Colin then on a separate contract on it. Both were D&B contracts. So that's how the project got initiated, obviously, then. From that point onwards, then we were in obviously the tender stage, and as a client, usually what it is, they want you to approve the budgets, and they give you something to make a decision by on a Thursday and tell you that if it's not approved by tomorrow, you're in delay. So that's the way it works usually. But it was a good process. We had a lot of engagement with Colin on the D&B process. They kept us very much involved. It wasn't a case that they got John's design and ran off with it and didn't give any consideration to what the overall objectives were. Yeah.
Maybe just also add a little bit about the context of the project, where it is in Dublin and what it means to that location.
Yeah, well, listen, I don't know, people growing up in Dublin know Sheriff Street never had a great reputation. It's like the American who was parking his car in Sheriff Street, and the little kid's looking at it up and down. He says, "Will my car still be here when I come back?" And the kid said, "No matter where you park, it'll be here when you come back." And Sheriff Street had a bad reputation. Castleford Business Park had a lot of small industrial units, but where the specific site for the hotel was a Dean Waste segregation facility. So from that thing where skip trucks were coming in, the waste was segregated, sent back out for processing to different places. From the existing residents, it was a vast improvement to the neighbourhood, and OMP have given us, and Colin have constructed for us, 2 superb buildings there, the hotel, which is now up and running, and the office building, which is completed. and it's transformed the area as far as I'm concerned. The other part of the site, the residential site, is now on site. O'Mahony Pike are delivering that with Eagle Street and John Paul Construction. So that's about 2 years before we start seeing PC on some of the buildings there, but it will change that area completely.
Before I invite the others to say something, you mentioned at the beginning that you had a DMB arrangement with Colin.
Yeah.
So at the early stage, you wanted to have a kind of indication of what your entry price and your exit price.
Absolutely.
So it's hopefully a secure GMP or guaranteed maximum price.
Yes. Yes.
Has that worked out?
It has worked out, yes.
Yeah? Okay.
Absolutely, very little variation. We did a lot of work pre-contract, and it was a negotiated contract, so it was, in a sense, not quite a pre-construction service agreement, but a sort of a hybrid. So we knew what we were getting very early on. So
it's great, fantastic. Maybe from your side, John, a little bit about the context of the site, the architecture, and the location, and why we ended up with what we ended up with.
Yeah, sure. Like I think back, it was probably 2018 where this project started. The project to the north of the site, East Road, we started on, which is 554 apartments. And then about 6 months later, the client bought Castle Forbes, which it was a mixed-use zoning, and they kind of gave us a carte blanche to design offices, residential, cultural, community use as well. So this project kind of arose out of that. Given the fact that there was the SHD process and different kind of zoning, we ended up having about 6 planning applications over the whole project. And as Kevin described, the office and hotel came first because there was the Premier Inn let was happening. So that's how this kind of moved at a quicker pace than the rest of the scheme. So again, it was one of these kind of crazy projects you never think you're going to get. There's on the 2 sites, there's nearly a kilometre worth of street frontage. And, it was very exciting to be involved in it. But then just to go to the building itself, again, kind of like John is talking about, we were interested in the idea of a module or a unit and how that can be wrapped around a building, and then how do you bring variation from that module. So we're looking at this kind of 1950 bay window, effectively, a unitized bay. And to kind of accentuate that, the framing is oversized, so it's about a 150 mil frame, so just to accentuate that. And then each panel is overclad with an aluminium sheet, so there's no vertical lining on any of the panels. It's a clean laser cut panel over it. And then just within that, there's the kind of gold banding, which just wraps around, unifying the whole building. It's kind of an unusual shape because the way the master plan worked, the building has, I think it's in the round and has nearly 8 sides, so we have to kind of consider each side differently. Some are more prominent with the square onto it, some onto the street, some onto a service bay, and then one onto the rail tracks. So they're all kind of perceived differently. They have different relationships to the buildings around them. So again, this is where the module kind of, we break out of it, and we kind of have this almost deconstructed checkerboard where you come frontal onto the building. We kind of animate the facade with these bay windows that hopefully are kind of breakout spaces or areas where the glazing's facing upwards, so you look up, or the smaller bay windows are face down, you look down, or that you can kind of perceive the street and yourself within the building. So that was kind of, again, you can see where the typical bay window was then just broken up apart and then into something a little bit more animated. On the image on the left, you can see where then that hits the ground and we have a large entrance. I know we're kind of talking about the unitized system, but TechRead were involved in the base of the building. And that base across the building is an 18-meter long single piece of TechRead, and it's kind of just hung from, just suspended from below. It's not attached to the building at all. So it was a bit of a fight to get it over the line that it was one single piece, but I think it has that weight and drama as you go into the building with the triangulated curtain walling below. So then this is kind of the second iteration of the bay, where we again take where there was a checkerboard in the front, we'd have a more rigorous checkerboard, but then within that there's a slight inflection on the solid bay panel, so you get the 2-tone panel with that slight shadow being cast, creating that diamond, having a kind of a memory of the bay to the front. This again, it's a different facade that you perceive more obliquely, so it's part of a rhythm of a street as opposed to something you're looking straight on at. Then finally the crown, again, it's the same module, but this time we look at the idea of folding the panel instead of in a much simpler way, but then that it kind of catches the light and then it crowns the building quite elegantly. And then with the panel, the railings above just have that same inflection on them. So look, there's just a lot of kind of plays with light and shadow and color just to bring a kind of texture to the building.
Great. And in this early design phase, you obviously had some support from the consultants at Murphy. How collaborative was that process?
It was very collaborative. It wasn't a case of kind of pass the baton on each stage. They were Neil and his team were working with us quite early in the project, so a lot of the ideas of the different bays came through conversations with him. We were producing little models of each bay, and he was taking them away. And some things we thought were quite simple were quite difficult. Some things that we thought were quite simple were quite difficult. You know, it was educating us a little bit on glazing sizes and how panelization works, how to kind of sell it back to a client in terms of this is obviously there's a lot of variation in the building, but then to get that efficiency in how you design it and talk back to Kevin about how that all comes together in quite a, efficient construction system. So that's where Murphy's were involved a lot.
And you mentioned also there was input from TechRead. Unfortunately, TechRead are not with us today, but they must have had a fair amount of input to get that 80-meter beam.
Yeah, there was
agreed,
weeks,
and
there was weeks and months of conversation of how you could subdivide it or, support it off the slab and looking at the structural calculations. But I think Neil and his team helped us argue that, the simplest and most dramatic way to do it was just as one single piece across the facade.
Yeah.
And we were just under the maximum length of a piece of concrete that they could produce, that they could fit in the back of a truck. So it was a coincidence rather than design.
Brilliant. Maybe, sorry, did you want to add something? Maybe a few words from you, Albert. I know you weren't personally involved on the project, but you worked with the team, and I think you got a good feeling as to how that process went.
Yeah, absolutely. It was a really interesting project for us, and we're very proud of how the job has turned out and our contribution to it, both in helping John and Kevin and ultimately Ronnie and Dave. We were appointed as the facade consultant to provide the facade consultancy services for the project. It was the usual level of input. We were to develop the performance-based specification, develop the technical concepts based on John's visual intent, and to follow through with the construction stage review activities. I suppose for this discussion, I'm going to focus on the technical concepts because that's generally the most exciting bit of the project for us, the most interesting element. So based on the elevational treatments, we could have made the mistake that thinking that this was going to be a very straightforward unitized curtain wall job. There was a lot of repetition, a lot of regular modulation, but it became very clear really quickly that OMP's vision was for something, far more interesting. They aspired to something, just something more fundamentally just better. They had this particular design intent for these glazed apertures that John mentioned, which were kind of framed out by and recessed back from this external flat opaque surface, almost extruded out of that flat plane. And then internally, that glazed aperture was bound by these really generous, framing sightlines. It was clear that those requirements didn't lend themselves to an off-the-shelf unitized curtain wall solution. So we set about developing our initial technical concept, which incorporated these large elements of heavy gauge aluminium sheet, which were cut out to form the glazed aperture. That sheet was then mechanically fixed in a really discrete manner to these large bespoke unitized curtain wall profiles. And I suppose then that kind of bespoke design approach ultimately led or inevitably led to a series of project-specific testing requirements. So there was performance-based testing, there was some acoustic testing, there was visual testing by means of visual mock-ups, and the guys will probably talk a little bit more about that in due course. In developing the initial technical concept, we were very aware that there were a number of other iterations or conditions on the project that we needed to address. So the basis of our design was that the base unitized chassis would be easily adapted to incorporate each of the subsequent conditions that we were going to meet, such as the external vertically and horizontally orientated projecting profiles, the larger opaque elements with the distinctive fold, and the projecting elements and projecting bays to the east elevation. And you can see on the screen at the moment, our kind of technical drawings for these concepts, and you can see there was a significant amount of complexity and articulation required in them to achieve the both the performance requirements, the technical requirements, and the visual intent. And I suppose to conclude, we subsequently then went on to develop technical concepts for a number of other conditions, and the most interesting of which was probably the one John mentioned earlier, which was this mega long beam at the main entrance. And it just occurred to me earlier, one of the other speakers mentioned the idea that it's you talked about collaboration. It's one thing to conceive of an idea, but to actually make it happen, needs a full team. So it was easy for I suppose John and Neil to say, let's have an 18-meter long beam, but it took Techrete and David here to make it happen. So it's a really good example of that level of collaboration.
Thank you. So David, from your perspective, at what stage, what's the earliest stage that you got involved? Was it at planning or before planning approval?
We got involved. Planning was still going through, but we got involved in very early negotiation. Because it was negotiated, we were involved, I'd say, 6 months before it happened on site.
That's right, yeah. As I say, it was sort of a hybrid pre-construction service agreement. I mean, we weren't going to any other contractor.
Yeah.
So Colin had that certainty, and we could take advantage of their supply chain and their experience in delivering what we needed.
Yeah.
So.
I'm just listening to John and to Albert, and I'm sure, Ronnie in a minute, and they're talking about, the complexity of this, right? It was extremely complex, right?
Yeah.
But we, as a contractor, right, found that these guys here didn't make it complex for us, right? We left the specialists to do their work, and how we were able to do that basically was extremely early engagement, right?
Yeah.
Continuous engagement.
Yeah. So you basically didn't have an independent executive architect. You used these guys as the executive architect. So you took on board the full team from the client under your wing as a
Yeah, they were, everybody, the design team were novated to us. We took on the responsibility then for design, and after that we went to tender, we found the subcontractors, and a good one, right? Yeah. And to be fair, as I was saying, it was early start, right? Lots of it, early engagement, lots of engagement the whole way through. We had somebody full-time down there, I'd say, for 18 months taking care of this package, but it was very, very, very much assisted by capable teams on all sides. And I'd say it was a very tricky site. There was no room. Well, people say compared to other inner city sites, there was plenty of room, but there wasn't. I mean, we were landlocked on all sides, and we were also building a 262-bedroom hotel on the same site, right? And that tended to take, if there was space, that tended to take it because it was, there was far more activity in that hotel because we were fitting it out, yeah? So, but I will say, the early engagement allowed to early decisions on our structure and allowed us to basically do it. But I will say that Glenveigh, from day one, were not taking any savings on the facade or on the tech REIT, being they had decided this was going to be a quality building. And I think, to be fair, the team have delivered a quality building for Glenveigh.
Great.
Yeah.
Tell us a little bit about some of the key drivers in terms of site logistics. We mentioned the 18-meter beam, and hopefully you have some pictures you can show us on that.
I don't have them here, unless you put them up, John, did you?
Yeah, there was one earlier, sorry.
Yeah, sorry, I haven't got it being delivered. There's one photograph of it.
All right, never mind. But some of these would have driven a lot of the decisions you had to make in terms of site logistics and also in terms of element size for Alucraft.
Alucraft delivered just in time, really. Everything came off the truck. It was lifted once, maximum twice, and that was it. We stuff in onto the floor, and I'll let you explain how you hung it, but the stuff was lifted once directly in onto the floor, and then after that, taken back out and was lifted once or twice to avoid any damage. The more often you lift, the more damage happens.
Yeah, because some of these three-dimensional pieces are not necessarily standard handling.
If I was to say the job went very well, right, I'd say the job went very well for 95% of it. And those three-dimensional pieces were difficult, right? But well handled.
Remember, David, though, we had an RC frame contractor who wanted exact setting out for slabs and everything. So decisions were made very, very early in the process. Right. And as a client, one of the risk items in the price was ground contamination. We decided we'd do that ourselves, so we wouldn't get perhaps a main contractor margin or anything like that. So when they started on site, the site was ready for them. They would have lost some of the time a contractor has to agree details. But they had appointed their RC frame contractor on the hotel who was on site, who was very keen to move on straight onto the office building. So again, decisions had to be made very, very quickly. Yeah.
Everything Kevin said is correct.
That's collaborative working, because when you identify a risk such as ground contamination and the client says, okay, I'll deal with it, that's collaborative working.
Yeah, but we hear a lot of talk about teamwork and collaborative working and that, and it only works when you make it work, and you have to have the right people there at the table.
You have to work at it.
You have to work at it, and the team that are here did it.
Yeah. I'm going to come back and have more discussion on this topic, but I want to hear from Ronnie and from Stefan a little bit. I don't know if you have slides in there.
Yeah, so Stephen, look, what I'll try and do here over the next couple of minutes is just take you a little bit through the journey from a facade contractor's point of view. Obviously, it's a scheme we were delighted to get involved in. Very proud of our involvement in the project, very proud in terms of the result of what we've all been able to deliver across it. So really, from the outset, a project like this, when it arrives into a facade contractor's office, a specialist like ourselves, it's very much a design-led process from the beginning. It's a very technical facade. There's been a lot of work put in terms of the design team and the consultancy team before it reached to us. We have to try and understand that. We have to try and be sympathetic to that the design intent, looking at the employer's requirements in terms of the performances, etc. So it's very much a design-led process from our side in terms of how we then go about developing this. So right from the outset, we were able to identify 4 distinct facade types that were on this building, and the picture that's on the screen should give you an indication from the facade type 1, which was we'll call it the more simple, straightforward units. Then we had the facade type 2, where it had the deeper 400mm projecting fin and the diagonal articulated panel. Then facade type 3, where we had the units with the golden crown on the top of the building, and then facade type 4, where we had the projecting bay windows that we've looked at. So when we started to look at this, it was very much a collaborative process between ourselves, taking the ideas and the requirements and the specification and the design intent, taking that all, starting to sketch up some ideas, being sympathetic to everything that has been presented to us from the employer's side, Starts with a bunch of sketches, starts with us doodling, trying to figure out, we're thinking of the logistics, we're thinking of the manufacturing of this, how are we going to put this down a production line, how are we going to be efficient at doing that, and we want to try and minimize the number of parts to maximize our efficiencies. So we start with a series of sketches. In this project, we worked very closely with Shugo, our delivery partner of choice, where we're looking at the system solution, what parts and pieces can we use from existing. But it became very apparent early on that this was essentially going to be a completely bespoke solution for this project, utilizing standard parts where we could, but essentially a bespoke solution. Those sketches develop on through their life. They start to develop into more firmed up ideas. We're having workshops all the time with the consultants team, the client side, discussing these ideas, looking at them, testing them, checking their validity, and we move on to a stage then of where the drawings are starting to become more solidified. We're getting firm ideas in terms of how we're going to go about the various facade types. And the result of that, in this particular case, ended up we developed a suite of 13 profiles. So from that suite of 13 profiles, we were able to construct every facade type on this project, which was excellent. So I think, very clear sort of message to me in that is that something that is bespoke, something that is unique, can also be very economical and can also be very sustainable. Because from that suite, quite a concentrated suite of profiles, we were able to deliver the entire project. And when you look at the project today, there is a lot happening on the facade. There's a lot of different elevations. There's a lot of articulation, and we were able to develop it from that. The economics of that shouldn't be missed. We move on then. We go through a period of certification. So we take again to ensure that we're meeting all of the code, all of the standards, the employer's requirements. We built the panels. We tested 3 different facade types in the one assembly at the test centre, put it through its paces, and we're able to demonstrate that what we had all designed had worked and was delivering the requirements. There were some other more unique or more specialist testing needed for the project. I mentioned earlier we had a 400 millimetre deep projecting fin, both in the vertical and the horizontal. So again, as a team, during the workshopping, we were concerned about rain noise on that horizontal fin. And again, it's something that there's not a lot of existing data available for in terms of us understanding that. So we went, designed a test, set that up in an acoustic laboratory, carried out that test to demonstrate and to satisfy ourselves as a team that what we were going to be building would be meeting the requirements of the end user when they would move in. So again, lots of little bits of R&D and lots of good collaboration and a lot of interesting technical content in all of that to develop the facade. We then get to the stage where we're moving into production. So again, what I talked about earlier, by that stage we've gone through a lot of design drawings and technical submittals and technical approvals, and now we're at the stage where the product that we've all been working hard to develop is now on a production line, and that production line has to flow, it has to move, panels have to be coming off that production line every, whatever it is, 45 to 50 minutes. And that's where then all of that good work that we've been doing is really tested. Have we been successful? Are we able to deliver these panels consistently to a high quality? And in this case, we absolutely could. Traceability of the components, you can see that in the slide there, in terms of the QR coding, everything's QR coded in the factory. That gives us a full passport, a full sort of traceability, if you like, a thread of information following that panel right through from its beginning, right through to its installed on site. We then move on to the installation side on site. David talked about the movement of the materials, so vertical distribution of the panels was provided by David and his team in terms of offloading the trucks up straight onto the floor plates, horizontal distribution by ourselves in terms of moving the panels around, positioning them at at the workface, decanting, installation with an independent mini crane or spider crane, so it takes the reliance away from the tower crane, and with only the specialist elements such as the large prefabricated bay windows and some of the corner panels, we would rely on the tower crane for installing those because they're outside of the weight limits of that. So look, that's a very quick sort of overview. Took an awful lot of time and effort and an awful lot of people working very hard in our business to bring that project, but that hopefully touches on a sort of each of the areas in the business from how that moves through our specialist fabricator like ourselves.
Great, thank you. A few words from you, Stefan, on how you got engaged in the project, working together with Ronnie and the team at Alucraft.
Yes, thank you. I think, if I'm not mistaken, the first time we got this inquiry must have been in 2019. So there are two sort of things that I think are quite worth mentioning. And the first is, how long it takes to actually deliver this type of project. 5 years for us, and we probably even didn't get involved from the very beginning. So I imagine that you guys must have worked on it for years before that. But from a system supplier point of view, a company that sells metal and that has a lead time of 14 weeks, to actually wait 5 years to develop such a scheme is quite fundamental in terms of the service that you have to give to actually get to do these bespoke projects. And the second thing I wanted to share was that I'm a little bit embarrassed to say, but I didn't think it would look as good as it does. In actual fact, when I received the first inquiry from Alucraft, it was your colleague Ken, Rory, that sent it. And there wasn't much explanation in the very first email. It just had attached the Murphy's drawings. And when I saw the drawings, I thought it was a mistake. Looking at these white profiles, because everyone at the time, they wanted as slim systems as possible. They wanted to see more glass, and they wanted a 65 mil unitized system, or even less if that was possible. So I thought there was something wrong. But then, of course, later on, we got the backstory and we got the explanation. There were discussions about, okay, but do you really need one profile? Why can't you just make something out of an aluminium sheet, to replicate that effect? But we understood that fairly quickly that this was part of the intent. And it wasn't our job to really question that. We just had to deliver on that architectural intent. And again, I didn't think it would look as good as it does, and it really looks brilliant. And for us, it was quite unusual to design a system that was as big and as chunky as possible, because normally we try to make it smaller. And that comes with its own sort of small system-related challenges, because a system like this, normally we work with corner cleats and mitered system where you can't corner cleat these monsters. They had to be screw fluted and connected with screws. But even accessing a screw through a profile that is so deep is a little bit of a challenge in itself. In terms of the glazing details, everything was so pristine and designed with such care. When you look at the glass, it's shuffle glazed vertically, and it has glazing beads only horizontally. So the end effect is really sleek and quite impressive. These are just some examples of the fabrication drawings that we did to assist Alucraft in their own production design, and it was quite rewarding in the end. And And really, I must say that this project and the architecture went way beyond my expectation. It looks amazing.
Thank you. Do we have a video of this?
I think it was up at the start.
Is it possible you can play? Does it have sound in the video? Or maybe just mute the sound and leave the video running in the background. And then we'll go to some questions. I don't know if anybody in the audience has a question. If you have a question, please raise your hand and somebody will come to you with a microphone. Any questions from the audience at this time?
Take one back.
Okay, none so far. I have a question.
No, there is one.
Oh, there is one. Okay, sorry, I didn't see that.
Ronnie, just back to the 13 profiles. I'm just interested to understand the time in figuring that out. Did you guys do that? Did you do that with Stefan? Because the variation on the facade is just fantastic, and it's just to get that in 13 profiles is astonishing. So the time to do that, to get that efficiency, could you just talk us through that, if you don't mind?
Yeah, okay. So, Anthony, it was very much a collaborative process between, obviously we had a set of documents, which was, I'll refer to as the employer's requirements in terms of the consultants and the architectural design intent. We started looking through those and doing sketches. We involved Stefan and his team, and it's very much a collaborative process between Shugo and Alucraft. I can remember us on various calls and even sitting talking about things where, like, we used to shuffle glaze shop fronts. So, like, there's the idea, why can we not shuffle glaze this system? We've got a deep profile. We've got loads of ability to have a deep glazing rebate, which we don't normally have. We're normally looking at rebates, and we're normally looking at, have we got enough space left in this rebate for proper drainage and ventilation? So we've this deep rebate, so we can start to incorporate, let's go back to what we were all doing 25 years ago. We were shuffle glazing things, and so those ideas were very much a sharing of ideas, and nothing's off the table. We were talking and discussing, and then you start to sort of solidify the main things. So you start to get the main idea in your head about how the chassis, the main sort of profiles are going to work. Then you start looking at, okay, the other maybe smaller, less prominent, or the less areas of the other areas of the facade. You start to look, well, can I start to incorporate in the features that it needs? And it was really a case, I think, of that we established, at a point we established a base that we could then see, right, well, we can build on this and make the other facade articulations that's needed in the other facade types. And we didn't particularly, we obviously set out to do it with the least number of profiles possible, but it is one of those things that I think is pretty impressive in that, you know, bespoke design like this can be very economical when you have the time, and it is important. It does take time. So I don't know, Stefan, if you've anything else.
Yeah, absolutely. I mean, and in terms of the economics of it, there's this misconception that bespoke is always more expensive, but quite often we make bespoke to make it cheaper, right? Mm-hmm. Because it would be easy to, well, maybe not this building, but so in many buildings you can use a system, but the system is actually more expensive than engineering it precisely for the project.
Yeah. Any more questions from the audience side? If not, I have a question for John. I mean, John, you've seen this now materialize on site. And from your perspective, it looks like very clean lines, very well-tailored piece of work. Has it met your architectural expectation?
Yeah, I couldn't, it was hard to kind of perceive what it would actually look like in the end with all the, I think the colour particularly, how that would work in the light, especially. And I think in person, buildings are always different to what you perceive them to be. So yeah, I think, I guess what surprised me was those standard typical bays with the oversized framing. It was kind of a detail that I just felt that very standard windows, I think it could have looked quite banal if you didn't just skew it a little bit and oversize them, and then it kind of takes a second glance when you look at the size of them and how they look compared to a typical window. So yeah.
So you're happy, basically?
I'm happy, yeah.
What about you?
As a client, we're happy as well. Yeah, no, it's very much, he talks about colour. I think probably the only bit of stress in the whole process was at one point we had to make a decision on the colour we were submitting to DCC, and there was a different colour palette at one point on part of the building. And I think he got pushback from us on that. But I don't know if that's why he's looking a little bit wistful or not. He wanted his ochre or whatever it was at the time.
Yeah, there was a kind of a pop of red in one of the facades, and that was kind of linking in with the residential.
Yeah.
And I think it was the right decision to get rid of it. It would have been a little bit overbearing. But.
Yeah. Can I just also ask to Ronnie and maybe to Albert, how much collaboration was there between you at that kind of very early stage when you were sketching what's been described as a fairly unusual system, and you probably haven't done one quite so chunky for a while. How much discussion was there between you and Alucraft?
Yeah, well, again, you mentioned collaboration, and a lot of the theme today is about collaboration. Neil talked about like a very early engagement with Ronnie, and I think it was at the direction of Kevin and David. Prior to moving forward, let's make sure that we're all on the same page. Let's make sure we understand each other. So I believe Neil and Ronnie went through, were locked in a room, could have been a virtual room maybe back in those days.
At that stage, a lot of this was on Teams, but I think, Stephen, what was very good, once we had sort of established that we had an idea, right? It didn't have to be, it was an environment whereby we didn't have to have every answer, but if we were at a point where we had an idea, we felt that idea had legs, we were using it, we were setting up virtual workshops. It was on Teams. We had David's design manager in those meetings, and we were very comfortable sharing with the guys where we were, what stage we were at. And I can remember we started off and we said, right, well, this week we're going to look at facade type 1. Right, this is when we shared our ideas on it, and we were getting feedback in terms of our thoughts on it, where we were going, and the guys were all giving their input into it. And we would probably been in that position thinking, well, okay, that's good, we're getting progress with facade type 1, now we need to shift our focus onto the next facade type. The following week we would reconvene again, we would have another discussion, and now we would widen that into facade type 2, facade type 3, and gradually we were building up this picture and getting, as we were going through that journey, getting the input and the support that we needed from the design intent and from the project specification from the team, to give us the confidence that we weren't going miles down the road and then having to redo work. So again, to do this type of work, it has to be that way, because we are developing something from, in a fairly unique product here, and we needed everyone on that journey with us. Otherwise, we would have been doing a lot of U-turns and wasting a lot of time and effort and energy. So it was, I think that's what's good when you have a bunch of people that each respect each other's knowledge and experience and depend on each other to collaboratively end up with a product that is the best possible because of the input of the team. It's not just the input of any one or two individuals.
So based on the experience you all have, sorry, I'll come back to you, on the experience you all have with other projects, how do you rate the process that you've been through here? Is this ideal? Is this how you would like to do all the projects in the future? Is that fair to say? I mean, 9 out of 10, 10 out of 10?
Who are you asking the question of? David? Yeah.
David?
I would 100% be happy if...
There you go. If a general contractor says that, you've done something
I would be
right.
100% happy to walk in the door and meet any of these guys on my next project.
Brilliant.
I can retire now.
And that's the way it's been. That's the sort of job it's been.
From a client perspective, we would say the same. Listen, you want people who are passionate about what they do, and on occasions that it leads to, frank discussions and stuff like that. But generally, it was a very happy.
It's very
project
important to
from
be able
start
to have
finish.
a frank discussion
Yeah.
and another discussion after it, right?
Yeah.
You know, so, and we could do it here.
From my side, all I can say, fantastic and congratulations. It's a good example for all of us to learn from. Thank you for sharing it with us. I have no more questions. We have 1 minute left on the timer. If there is a question, we will take it. Yes?
Yeah, just a question from the team in general. Did you use much in the way of digital graphic design or graphic representation of the building during the approvals process? And would you have a comment on how successful that is? Or do people want to see the stuff, you know, as mock-ups? Do they rely on mock-ups a little bit too much? Or for the future, is there a way forward for digital BIM models or Rhino models or things like that? And can you get your point across with those?
Pat, I'll answer sort of from the facade contractor's point of view. We used some of those digital tools at the early stages, and you've seen some of the images on the screen where we had CGIs and models built of the various facade types. There is a place for that, and there's a time for it, but it is no substitute for then moving into the next stage, and that is doing, first of all, joinery trials. So when we bring in a new suite, if we develop profiles, we bring those profiles into the workshop. We do what we call joinery trials. So we're testing the joinery methods, the connection methods that we've sat and looked at. And there is absolutely no time in the future where I would want to see mock-ups, visual mock-ups, performance mock-ups substituted for digital type things. We as a fabricator, we need those mock-ups, we need to learn from them, we need to fine-tune our fabrication processes, we need to fine-tune our ITPs, our hold points, our quality control points, and that we can only learn that when we build real-life mock-ups in the workshop and use them to learn what we're doing before we go whole-scale into the production of a large project. So from a facade contractor's point of view, digital's great at the early outset, but it does not and should never replace the real thing in terms of mock-ups and testing. That's from my point.
I'd second that for buildability. You know, it's easy. Yeah. It's easy write it. It's easy draw it. It's not easy put it in place. So
yeah, I think we'd all concur with what you just said, Ronnie. That early stage visualizations, renderings, and so on. It's good to get an impression. But in terms of buildability and how things fit together in the real world, there's really no substitute for trials and mock-ups. I think we are now 2 minutes over time, and I know there is a cold beer waiting outside. So I want to thank everybody on the panel again, and I want you to show your appreciation to them, please. And thank you, all of you, for staying the course and staying with us till the bitter end. Just by way of closing remarks, I want to say thank you to Shalja, who's put a lot of effort in today's program. Well done. And to the whole Zak team. Some of them are fasting. We know they are fasting and have done a fantastic job. So thank you, Zak team. Thank you, everybody, and hopefully we see you again in Dublin in 2 years' time. Thank you.